This will be a fun module because in MongoDB you cannot just query text, booleans, numbers, dates, you can also query locations. And with this I really am talking about queries like find me all restaurants in this radius or find me the nearest location to my current location. So there are a lot of fun queries you can do with this so-called geospatial data. And in this module, we'll have a look at how you can store geospatial data in the special GeoJSON format. And you will also learn how you can then efficiently query this geospatial data with the help of indexes and a couple of special operators that are suited to work well with geospatial data. So let's dive into this and let's start working with some locations and places. I'm back in the terminal here, and I will enter a new database, Awesome Places, by using it. And in this database, I want to add some nice places, essentially locations, which I can then query. And we'll do this together right from start. We'll also add these places right from start so that you can understand how geospatial data needs to be stored so that you can work with it. In the official docs, you'll find an article about GeoJSON, how it's structured and which kind of GeoJSON objects MongoDB supports. Because GeoJSON is not a standard invented by MongoDB, it's actually available outside of MongoDB too, and there you have more objects available than are supported by MongoDB, but MongoDB supports all major important objects like points, lines, or polygons, as well as some special advanced objects. Now, this article is definitely worth checking out, but the most important thing here is that you understand how a GeoJSON object is created. And creating it is very simple. To work with some data, I chose the San Francisco area, but of course you can open up Google Maps and work with different locations. I'll use Google Maps to pick some locations so that we also can see something on the map and kind of validate whether our queries work correctly. Now, let's work with that Golden Gate Park. And let's start by adding one simple location in our database. Let's say we are going to pick some awesome places. I like this park quite a lot actually. I've been there. I've not been to every place I'm going to pick now, but let's simply pick some places here, like the California Academy of Sciences. Now in Google Maps, if you click on a place, you can easily access the coordinates of that place from inside the URL. You'll find them here. Now the important thing is the first coordinate until the first comma is the latitude, the second one is the longitude, and you'll need to remember that to store it correctly in MongoDB. Coordinates are always expressed as latitude-longitude or longitude-latitude pairs, because the longitude essentially describes a position on a vertical axis if you draw it onto our globe, onto the Earth globe, and the latitude describes a horizontal axis on the Earth globe. And with that coordinate system, we can map any point onto our Earth. So let's work with that data, and let's add this as an awesome place to our collection. So here I'll add a new places collection, and I'll insert one new place. Now, you insert a normal document, this doesn't change, and I'll give it a name of California Academy of Sciences, because that is the name that we see here. And then I want to add the coordinates in GeoJSON format. Now, there's nothing special about GeoJSON. You can add any key you want with any name you want. I'll name it location, but you could name it log, you could name it totally different, that does not matter. What matters is the structure of this value. The value should be an embedded document, and in that embedded document, you'll need two pieces of information. And these two pieces of information are also mentioned in the official docs. You'll need to define the type, and you'll need to define the coordinates. The coordinates are then an array where the first value, and now this is really important, where the first value has to be the longitude, and the second value is the latitude. So let's add a point exactly the way we can see it here. Let's go back and grab our longitude first. So this second value here on Google Maps, copy that. And then here, I will first of all add a type, and type here is point because I add a single point. And then I add my coordinates, and now these key names here are not up to you. This one has to be named type, and it has to be one of the supported types, like point. And this one has to be named coordinates, and it has to be an array where the first value is now our longitude, And the second value, separated with a comma, is then our latitude. So let's grab that latitude here and enter this here. With this, I added this place, and therefore, if I now simply find one, the only place I added thus far, this is now my GeoJSON object, exactly this. And it is treated as GeoJSON because it fulfills the requirement of having a type, which is one of the supported objects, and of having coordinates, which is an array where the first value is treated as the longitude and the second value is treated as the latitude. Now, with that point added, we know how a GeoJSON looks like. Let's now find out how we can query that GeoJSON data. Let's run our first geo query. For that, I'll work with my places, and I want to find places that are near my current location. Now, what is my location? Now, always keep in mind that, of course, rarely will work with the shell as we do. Most of the time, you'll write an application that does what we are now doing with the shell. Or then it will do that with its driver, of course. So therefore, you might have a web application where users can locate themselves. You can do that through some web APIs. Or you have a mobile app where users can locate themselves. Such location APIs will always return coordinates in the form of latitude and longitude. This is the standard format. So your application will give you some latitude and longitude data for whatever your user did. For example, locate himself. Now let's fake that part. So let's simply click somewhere, here for example, and now I marked a place where we also see the coordinates. If I click on that, I can also copy them from there. Again, the second coordinate is the longitude, first one is the latitude. So this is the location we assume we're getting from our app. So how can we now use that location to find out if this place here is near our location? And what does near define? Well, let's see that step by step. In find, I definitely want to have a look at my location key. And if you named it differently, you need to name it differently here. This is not a reserved keyword. This is simply referring to our key here. And then here, the value is a document where I use $near. $near is one of the operators provided by MongoDB for working with geospatial data. $near requires another document as a value, and there you can now define a geometry for which you want to check if it's near. So $geometry. That again is a document, and this now again describes a GeoJSON object. So we could check here if a point we add here is close to our point, and that's exactly what I'll do. So since we have to pass in some GeoJSON here, I'll again add a type, and that type will also be a point. We'll work with different types later, by the way. And I will pass my coordinates. And just as before, because this has to be GeoJSON, we have to have a type here, which is one of the valid types, and we have to have coordinates here. And you therefore, of course, also know which format coordinates should be in. Correct, it should be an array where the first value is the longitude, second value is the latitude. So let's paste in that longitude we grabbed from Google Maps, and let's then also grab the latitude, and let's paste this as a second value. Now if I hit enter, I get an error, and the error is telling me that it's unable to find an index for the GeoNear query. And GeoNear is simply the behind-the-scenes name of our near query. So for this, we will need a geospatial index for this query to run. Not all geospatial queries require an index, but they all, just as with other indexes, will most likely benefit from having such an index. So let's add a geospatial index in the next lecture. Now our query failed because we had no geospatial index. We need one for the near query here. So how can we add such an index? It's pretty straightforward. Just as with other indexes, we use createIndex to add such an index. And then we add the index on the location field because that is where we store our geodata in this example. Again, if you named that field differently, definitely use your name here, you have to. And then the type of the index is now not 1 or -1. We don't sort it ascending or descending. It's also not text because it's not a text index. It's a special 2D sphere index, written like this, not like this, like this, 2D sphere, in quotation marks. With this, we created a geospatial index on the location field. And now if we repeat that query from before, it does succeed. And we can also print that, and we see that it found this one point. Now, it found this one point, but that doesn't really tell us too much. It's near the location we added. But how is near defined? Well, near doesn't make much sense unless we restrict it. So typically what you would do is, you would not just pass a geometry to near, as we're doing it here, but you would also pass another argument and define a max and maybe also a min distance. Now, max distance is simply a value in meters here. So if I define like 30 meters, I should actually not find anything. We can also add the min distance and say it should at least be 10 meters away. So if I add this, I actually don't find anything. And that makes sense because if we have a look at Google Maps, this is the place, the California Academy of Sciences, and this is where we are. And that seems to be a bit further away. We can actually measure the distance by right-clicking onto the map and measuring a distance. And then if I click here, I can measure the distance to the California Academy of Sciences, and it seems to be around 435.36 meters. Let's validate this by repeating the query, and I'll set the max distance to 400. So this still should not suffice, and it does not. Now if I set it to 440, looks like I'm a little bit off with my place, so let's set it to 500, and now we find the place. So now we are within 10 and 500 meters, and therefore we find our favorite place. And this, of course, is a great query because it allows us to find out which places are near us in a certain radius, which, of course, is often a question you want to answer in an application. Now, in the last lecture, we answered the question which points are near to our point. Now, another common question you want to answer is, hey, I got this area, could be a sphere, could be any polygon, so I got this area. Which points are inside of that area? That is another typical question. And in order to answer this, let's add a bit more points to our database before we dive into that. So, in our Golden Gate Park, we added the California Academy of Sciences. Why don't we also add the Conservatory of Flowers? And again, you find the coordinates in the URL up here. So let me grab that longitude and then move over to our database. And there, in my places collection, I will insert one document, and that will have the same structure as the other document. I'll add a name here, and that is the Conservatory of Flowers. And I'll add my location, which is a GeoJSON object, where the type again is a point, of course, and where the coordinates are, let's say, my longitude, obviously, and then I also need the latitude. So let's grab the latitude from Google Maps and add this as a second value in the array. So now we added the Conservatory of Flowers. Now let's add two more, and definitely feel free to pick your own ones, of course. Now, I will also pick the Golden Gate Park tennis courts. And again, it's the same game as before. Pick the longitude, and by the way, important, what you see in the URL here, of course, is reflecting the center of your current screen. So if you're not centering perfectly on an item, as I did before with the Conservatory of Flowers, you'll actually pick the center. For the purpose of this exercise here, this will be fine though. So it only matters that you have some points from inside this area, no matter if it's exactly that point or a little bit off. So for the Golden Gate Park tennis court, I did focus on it, so this should be in the center. And I will add this place, therefore. Simply added my previous query. Golden Gate Tennis Park. And I will override my longitude. And of course also add my latitude here then. So let's replace that too. Like this. And now let's add a fourth place. And that is why it won't matter, because that fourth place will be from outside here. So let's say we take NOPA, whatever that is. So let's try to center on that. And let's grab the longitude, of course. Again, let's insert that. NOPA. Let's replace the old longitude of the last query with the new longitude. And of course, grab the latitude too. So grab that from the URL, and we're good to go. So now we got 4 places in there. I can quickly find them all to show them to you. Now again, the coordinates might be a bit off because I did not always center onto them, but we got 4 different places with 4 different coordinates. That is what matters here. And 3 of them, the first 3 are in the Golden Gate Park, and 1 of them is outside. Now, in the next lecture, let's run this query to find all places that are inside of a certain area. So I want to find all places inside Golden Gate Park, so no bus should not be included. Now, to find them, what I will do, because that makes it a bit easier to work with that, is I'll go into the Your Places tab and create a new map there. And here, it will be a bit easier to navigate around and find coordinates, and also show which place the coordinates are for. So in here, I want to basically, well, draw a polygon around my park. So let's start here. Doesn't have to be perfect, but somewhere here will be my first place. So what I will do is I will add a marker here. I'll delete it immediately, but here we got the exact coordinates. So let's take that and let's use that in a future query. So first of all, to make this a bit easier, I'll create 4 variables, p1 let's say, which essentially will just store these coordinates. So here I have the longitude of the first place, the first corner of my polygon, and the latitude will be my second element. And since the Mongo shell uses JavaScript, I can't just create constants like this, so this value is now simply stored in p1, and we can always access it under this name. So with that, let's remove that point here, and let's create a second point in the next corner here. And of course, if you already got your coordinates, you can skip this whole exercise and just go with them. So this is my next point. Const p2. This is my longitude. Now let me grab my latitude here, copy that, and store this as a second value in this array. And let's get rid of that point now. Let's move all the way to the left, to the end of the park on the west side. Add a point here. All right. Grab the longitude of that point, like this. And of course, grab the latitude too. So let's go over there, grab the latitude, and store that in this array too. Now on to the last point, and then we're done. Let me go here. Place a marker in the corner. Grab these coordinates. Also the latitude, of course. And now all the points are stored. So just to show you which area we now marked, well, essentially we got 3 points before. Let's start like this. We have the Conservatory of Flowers, roughly, so I'll just add a point there. We also took the Academy of Sciences, so I'll add a point there. And I have a point at the Golden Park tennis courts, so at this point. We also have one at Nopa, so let's move over there. And let's add a point there. So these are 4 points. Now, the area for which I just got the coordinates is essentially the area around the Golden Gate Park. And I can draw a shape around that with that shape tool here. So this is essentially the area for which I just got the corner coordinates. And what I now want to do is I want to run a query to find all the places that are inside of this shape. And the good thing is we can easily validate this because we can see which points are in there, right? This one should not be in there. So now that I got these coordinates, let's finally get to creating that query. So on the places, let me quickly clear the console. P1 and so on are still available. So on the places, I will now find something again. And again, I will find something with the help of the location field. But there, in the location field, I now don't want to find some nearest points, so near is wrong, but instead I'll use the GeoWithin operator, $GeoWithin. This is an operator provided by MongoDB that simply can help us find all elements within a certain shape, within a certain object, typically something like a polygon. GeoWithin takes a document as a value, and here we can add a geometry object, which is just a GeoJSON object. So the value here is a GeoJSON object. The type now is not a point, but a polygon. That's important. Coordinates need to be added, of course. And now I need to add the coordinates of a polygon. Now, how do I add a polygon? Obviously, a point was just a pair of coordinates. A polygon actually uses a bit more coordinates. To be precise, we need the 4 corners. For a polygon, we add a nested array. So an array in an array. And in that array, we then again add more arrays, where each array now describes one longitude-latitude pair of the corners of our polygon. So I already got these arrays, so to say, in my constants P1 to P4, which I created. So essentially what we add here is P1, P2, P3, P4 to describe the 4 corners of our polygon. There is one important thing though, I need to P1 again at the end, because a polygon has to end with the starting point so that it's treated as complete. Now with that, if I hit enter, I do get back results, and I can print them, and we see the California Academy of Sciences in there, we see the Golden Gate Tennis Park, and we see the Conservatory of Flowers. What we don't see is NOPA, which makes a lot of sense, because it is not within these boundaries. So this is how we can also check whether something is in a certain area, with the help of GeoWithin and the geometry operator, and then a polygon instead of a point. A polygon, as you learned, is in the end created with coordinates that hold a nested array with the different corner coordinates. Important here is that you also add the first corner as a last element to close the polygon. Now, another typical use case would be the opposite, that you have an application where you want to find out whether the user is in a certain area. So you don't want to find all places in an area, but you want to store a couple of different areas potentially in the database, let's say the neighborhoods of a city, and then your user sends some coordinates because he located himself, and you want to find out in which neighborhood the user is. So essentially the same query as before, just the other way around. Now, to keep things simple, I will work with the same area, but I will now store it in the database. And I then want to find out if a user, let's say, is here, if this user is inside this area. And we'll also check this with a point outside of the area then. So let's first of all store our nice polygon, which we used here, and therefore I will just copy this GeoJSON object. Let's store this in the database. For that, I'll add a new collection, areas. Of course, you can name this however you want, where I will insert one area, and that area will have a name of, let's say, Golden Gate Park, and then I'll add a field. I could name it polygon, but I'll just name it area. That name is totally up to you. The value will be my GeoJSON polygon object with the coordinates I stored before. So this added this object, and we can have a quick look into our areas to confirm that we have all the coordinates for the corners here. First and last coordinate pair have to match. Okay, nice. So we got that place in here. Now with that place added, let's find out if this user is inside of that area. Now how can we do that? First of all, we need to create an index again. So let's run db areas, create index, and then the index should be created on the area key which I added, and should be a 2D sphere index, of course. So with the index added, we can write our query. And there we want to find out basically if the user is inside of this area. We can do this by checking for geo intersects. Now what does geo intersects do? GeoWithin allowed us to find out which places are inside of an area. Geo intersects simply returns all areas that have a common point or a common area. Now why don't I use GeoWithin? Because I can't find areas that are within the point where the user is. The user is just a point, and the area will never be within that point. The other way around is what I want to see, and I get this by simply checking, does this point intersect with the area? If the answer is yes, so if I do get an area returned, I know that the user is, well, in that area which is returned, because that is what I'm trying to find out, in which area is the user. So geo intersects is what I need to use there. And as before, we can now simply pass a geometry here with $geometry, which is now again a GeoJSON object. This is now just a point, the coordinates of the user. And the coordinates here are a simple array of the longitude and the latitude. Let's grab the longitude of that user here, like this. And let's grab the latitude, so this first value here. If I hit enter, I get an error because, of course, geointersects is generally all right, but the field for which I'm looking is the area field. And then this geointersects operator gets used on the area field. So my mistake. Just as before, this doesn't change. We need to let MongoDB know, hey, in which field is the data I want to compare. And that, of course, is the area field in our database, because the area field is where I do store the area I'm looking for. And then I use geointersects. So with this fixed, now we do get a place here. And that is looking good. I'm getting the only place I have in that database, but I'm getting the place with which my point intersects. And if my point would be in multiple areas, I would of course get all these areas which intersect with my point. You can also not just intersect points with areas, you could also intersect areas with areas and see if two areas touch. Let's say you want to find out which neighborhood contains the Golden Gate Park. The Golden Gate Park could be a polygon and the neighborhood around it could be one too, and you could find out if they intersect and if yes, which neighborhood intersects with the Golden Gate Park. Here we just looked at a point, and now to complete this, let's also look at a point which is not inside the Golden Gate Park. So I'll add a new point outside of it here, and definitely feel free to pause the video at this point and do this on your own. I will do it together with you. Here are the coordinates, and in the end we just have to repeat the last query. This time add the new coordinates, so the new coordinates of this new point for the point we want to see if it intersects with the Golden Gate Park. And hit enter. And we don't get back a result, because in our areas collection, we have no areas that would contain this point. This is the answer this gives us. Now, to conclude the geospatial queries we can run, let's find all places in a certain radius around the user. We kind of did this before with the near command. Now I also want to give you a different way. The near command also sorted the results. That is the important difference, and I'll come back to that. Let's now place the user here, and let's check for a certain radius and all the points in that radius. So for that, we'll need the coordinates of the user, of course, and I'll write a new query, again against my places collection, not the areas collection, because the places collection is the collection with these 4 places we added, right? So this is the collection I'm interested in now. And there, I want to find all elements in an unsorted order that are within a certain radius. So here, the location field is the field which stores the coordinates. So this is the field which I will now use with the geowithin operator again. Why geowithin and not geointersects? Because now I want to find all places that are within a place or an area, which I'll define here in the query. Previously, we had the opposite. We had a point in the query and wanted to find the area that surrounds the point. So geowithin normally takes a geometry operator which describes a GeoJSON object. But there is a special operator you can use in MongoDB, and that is the center sphere operator, $center sphere. This is a helpful operator that allows you to quickly get a circle around a point. So essentially, it uses a radius and a center and gives you the whole circle around that center, therefore. Center sphere takes an array as a value, and that array has 2 elements. The first element is another array which holds your coordinates. Again, longitude and then latitude. And with coordinates, I mean the coordinates of the center of the circle you want to draw. The second element in this array is the radius then. And now this radius needs to be translated manually from meters or miles to radians. Now this conversion is relatively easy to do, and you'll find an article in the MongoDB docs too. you'll find an article which mentions how to translate miles to radians or kilometers. Now I will work with kilometers here, so this is the value which is interesting to me. And now I want to look in a radius of, let's say, 1 kilometer. So 1 divided by this value without the comma is my radius here. If I hit enter, I find 2 points. Let me pretty print this. I find the Conservatory of Flowers and the Golden Gate Tennis Park. What I don't find is the California Academy of Sciences. Let's quickly measure the distance of this point to this point. Now it looks like this should be in there. So my assumption would be that it's simply not in there because I have the wrong coordinates stored. Let's quickly look into our database for the California Academy of Sciences. And indeed, the coordinates here don't match mine. That is because previously I didn't have my browser perfectly centered on them. So let's quickly update that to be really sure that our query here works correctly. So I'll update by simply searching for that object ID here, places, and you know how to update. I hope you still know it. First of all, you filter for underscore ID being equal to my object ID here. And the second value is then the value where you describe the update. With $set, I will set my location to a new value. The type will still be a point, that hasn't changed. But the coordinates, that will now be a new array with new values. First, the longitude here, and second, the latitude. So let's grab this, and this is now the exact point, the exact location of that institute. So with this updated, let's run our query again. And now the California Academy of Sciences is included too. But please note that NOPA is not included. And that makes sense because NOPA should definitely not be inside of our circle. If I measure the distance of this point to this point, it's above 2 kilometers, so it makes sense that this is not included. So this is how we can run such queries as well. The important difference to the near query, which also allowed us to find places within a certain min and max distance, is that with this query, we get back an unsorted list. This keeps the order of the elements in the database, or we could of course manually sort them with the sort method. The near method did give us the elements in a certain radius and did sort them by proximity. And it really depends on your requirements what you need. Do you need sorted results with the nearest result first? Or do you need unsorted results and you just want to get a list of the elements in an area in general? This is what GWithin can do. Near is otherwise your solution for the sorted list. That's it for this module. In this module, we first of all had a look at how you can store geospatial data. You store it next to your other data in your documents. The special thing about geospatial data is that you use the GeoJSON format. And there you need to follow that exact format of having a type with one of the supported types. MongoDB, well, does support. You can find that in the official docs. And the coordinates, which are an array where the first element is the longitude and the second element is the latitude. This is how you store geospatial data. Now, you can also create geospatial indexes. Some operations do require one. You store them by adding an index of type to the sphere with create index. And again, as I mentioned, the near operation does require such an index. Other operations like GeoWithin don't. Still, it will probably speed up your queries. Speaking of queries, we saw 3 important operators, near, GeoWithin, and GeoIntersects. And these 3 get you very far, because they allow you to find elements that are near you, restrict the radius, sort them by distance, and also do other things like find out if something is in an area and so on. These geospatial queries also all work with GeoJSON data. So really make sure you understand that format and you use that format for both the data you store and the data you then use in your queries. And that's it with the geospatial data. A very powerful feature of MongoDB that makes working with locations and areas really simple. Sometimes you need a bit more power for retrieving your data. Now, we already extensively use the find and find one methods, and these are your default methods for retrieving data indeed. But sometimes you want to do more complex transformations to your data. Now, of course, we talked about the fact that you want to store the data in your database in the format you need it in your application. But this is not always possible. You might have an online shop where the sellers can also generate detailed reports on their sales data. Now, it will probably be hard to store the data in exactly that format because these reports might be customizable by the sellers. Or let's say you have a customer-facing application on which your data scientists in your company also work. Of course, you will gear your data towards your customers, and you will store it in a way that allows your customers to quickly interact with your application. And your data scientists might not be that important for you from a data modeling perspective, therefore. Hence, you also need more complex data transformation capabilities. And in this module, we will have a look at the aggregation framework, which gives you just that. You'll learn what exactly the aggregation framework is in MongoDB and how you can use it to retrieve data in exactly the format you need it in your application. So, what is the aggregation framework? The aggregation framework in its core is just an alternative to the find method, you could say. You have your collection, and now the aggregation framework is all about building a pipeline of steps that runs on the data that is retrieved from your collection and then gives you the output in the form you need it. And these steps are sometimes related to what you know from find. Match, for example, here is the equivalent to filtering in the find method. It allows you to filter down your results. And you got a lot of different steps you can combine as you want. You can reuse certain stages. For example, you could match again later too to filter your already transformed data a bit more. And therefore, you have a very powerful way of modeling your data transformation. Every stage here in this pipeline receives the output of the previous stage, and therefore you can have a very structured way of having some input data and then slowly modifying it in the way you need it in the end. Now, in this module, we'll have a look at a lot of stages of the aggregation pipeline. And that is just what this aggregation framework gives you, this pipeline you will build. Now, we'll build this pipeline together, no worries. I'll show you in detail how it works. And as you can see in the official docs, there are loads of different stages you can have. So these are basically all stages you can combine in the pipeline. Now, I'll dive into a lot of them in this module, but it's impossible to cover all of them. So I strongly encourage you to also go ahead and dive into these docs on your own and play around with these steps. Take some dummy data and simply see how you can transform it. This is the best way of then learning more about the aggregation framework. But of course, let's now first get started and let's understand how exactly the aggregation pipeline works. Now, to get started with the aggregation pipeline, we need some data. And I will use our persons data again. You'll find it attached to this video one more time. We'll import it with Mongo import. And you should make sure that you run this command in the folder where you stored your persons.json file so that you can simply enter the file name and you're good to go. And then I'll store it in a database, which I'll name analytics. The name is, of course, up to you. And then a collection, which I'll name persons. I will also add the JSON array flag here. That is required because the persons.json file has an array of documents. With that, I can now hit enter, and this should import 5,000 documents into the database. Now let's connect to the database with our shell, and there let's use our analytics database where we should see our persons collection. Now, just to bring this back in memory, a person looks like this. We got quite a lot of data on a person, including things like some dummy location, and this is all random data, just to stress this again. So some dummy location, the age, and some other data, as you can see here. Now let's see how we can use the aggregate framework on this. So I'm still in that same database I was in the end of the last video, and let's now use that aggregate framework. We use it in a very simple way. Instead of running find on persons or find one, we now run aggregate. And we already saw this one time in this course already with lookup in the schemas and relations module. The aggregate method takes an array, and it takes an array because we define a series of steps that should be run on our data. The first step will receive the entire data right from the collection, you could say, and the next step can then do something with the data returned by the first step, and so on. Now, one important piece of information: aggregate does not go ahead, fetch all the data from the database, and then give it to you and then do something on it. Of course, the first step runs on the database and can take advantage of indexes. So if you filter in the first step or you sort there, you can take advantage of your indexes. So you don't have to fetch all the documents just because you're using aggregate. Aggregate, as find, executes on the MongoDB server and therefore can take advantages of things like indexes, and it will. So what could be a first step that we run? Now, to make this a bit easier to read, I will type this in multiple lines by not closing that expression immediately. And the first step is then a document. Every step is a document, I should say. Now, the first step here could be a match phase. And match essentially is just a filtering step. So you define some criteria on which you want to filter your data in that person's collection. Now you can filter here in the same way you can filter in find. So all the things you learned there on how you can query documents, how you can match for greater than values, and so on applies here too. So what we could do here is we could, for example, and if we have a look at our data structure again, we could, for example, look at females only. So to do that, let's simply add a condition here where we say gender should be equal to female. Now we can already finish our pipeline at this point if we want to. We can close the square brackets around our stages and close the parentheses of aggregate. And I get back a cursor here. You can tell by the fact that I see type IT here too. So just like the find method, the aggregate method returns a cursor. So you have to use it as you use the cursor returned by the find method in your application. Besides that, we can also pretty print that. And now see, well, some results at least, of the results we fetched, and we should only see females in there. This was, of course, only one step, the match step. And the match step is not that exciting because there we, as I said, query in exactly the same way we can query in the find method, or we filter in the same way, I should say. More interesting is the group stage. So let's take a look at that in the next lecture. Now, to make this a bit easier to follow, I will write my queries in a JavaScript helper file for now, and then just copy them over into the console, since I believe this is a bit easier to see than if I directly type them in there, as we will add more and more lines or stages. And adding stages is easier here too, because I can enter them in between without sending everything by hitting enter. So we saw the match stage in the last lecture, and match is essentially just taking a filter as you define it as an argument to the find method. More interesting is the group stage. The group stage allows you to, well, group your data by a certain field or by multiple fields. For that, let's have a look at our data again. We got our persons there, only females right now. And now by what could we group them? Now let's say we want to group by this state here. And we want to see the sum of persons living in that state. With the aggregate method and the aggregation framework, this is easy to do. In group here, we need to define a couple of parameters. The first one always is _ID. Now, _ID defines by which fields you want to group. And now we will use _ID in a way you haven't seen it before. The value for _ID will be a document. Thus far, we always used an object ID, a string, or maybe a number, but we never used a document. But just as with any other field, you can assign a document to _ID. It's just not that common, to be honest, but for the group method here, for the group stage, you often see that syntax, because that will be interpreted in a special way, and it will basically allow you to define multiple fields by which you want to group. So in my case, I want to group by location, state. And I can do this by assigning a key here, which I give any name I want. state, for example, and then $ location.state. The $ is important here because it tells MongoDB that I'm referring to a field of our document, which is passed into the group stage. So I'm referring to a field of this document, the location field. And then I can access a nested field just with a dot. Here, no $ is required. So this should now group our results by the state. Now we can add a new key to each document, and you can name this key however you want, like total persons. Now here, you would pass a document where you now describe the kind of aggregation function you want to execute. Now, these aggregation functions can also be found in the official docs, of course. There, if you go to the group stage, you see all the aggregation or accumulator operators that are supported. And for us, the sum operator is interesting. Now, as always, read through all these docs and all these examples to learn all about the niche and edge cases of each stage or each operator. We will use the sum here by using $sum and then a value you want to add for every document that is grouped together. So if we have 3 people from the same location state, sum would be incremented by 1 times 3. And the interesting thing here is that MongoDB will basically do this summing up for us. It will keep the aggregated sum in memory until it's done with a group and then writes the total sum into this field. It's also important to understand that group does accumulate data. Now that simply means that you might have multiple documents with the same state and group will only output 1. So 3 documents with the same state will be merged into 1 because you're aggregating, you're building a sum in this case. Okay, so enough of the talking. Let's now run this function. Let's simply copy it here, move over into the console, and then paste it in. And you see, I get back some results. And I should move pretty 1 line higher so that pretty is also understood. So now I can execute this and I get back some results. Now, what we see is we still have a lot of different states here in our data, but we can already see the aggregation seemed to work. We get a totally different output. We no longer have any person data because we changed it. We used group to merge our documents into new documents with totally different data, with the total persons and that ID. That ID, as you can tell, is that object we defined with the state on which it's grouped. And even though most states only have 1 person, which is simply related to the structure of our demo data set here, we see there are some states which seem to have more persons, like synop. And we can simply prove that our aggregation is working correctly here by manually reaching out to our persons and finding all persons where the location state is equal to synop. So if I add pretty here, I should find 3 females. Important. I might find more persons, but 3 females. So if I scroll up, get 1 female. Here's a male, so we can't count him in because we filtered for females in our aggregation pipeline. Here's another female, and this is the last record and also female. So we get 3 females in this state. And this is the group stage in action. Now let's play around with that a bit more. This is the aggregation function as we executed it in the last lecture with group. Now, as you saw there, we lost all the existing data, but that made sense because we grouped together our data. And if you do such a grouping, you will typically be fine with losing the data. Now, of course, when we ran that method here, when we ran our pipeline like this, what we got was a bunch of outputs in a totally unsorted order. Of course, we can also sort. And now here is already something where you see the advantage of the aggregation pipeline. You can sort at any place here, of course, but we probably want to sort by total persons now. So this is something which we only can do after having grouped. We can't run the sort on our input data because that will just be the person documents. And there we can sort on things like the age and so on, but we can't sort on the amount of persons in a state because that is a result we only derived here. So what we can do here is we can of course add a new pipeline stage, the sort stage. And the sort stage also takes a document as an input to define how the sorting should happen. And you can simply sort as you also sorted before. So you can say, I now want to sort by, and now of course we can say total persons, referring to that field which we introduced in the last pipeline stage. This is not a field existing in our input dataset, but this does not matter because as you learned, each pipeline stage passes some output data to the next stage. And that output data is the only data that next stage has. So this sort stage does not have access to the original data as we fetched it from the collection. It only has access to the output data of our group stage. So there we will have a total persons field, and we can now sort by this in descending order to have the highest values first. If we now copy that over into our shell, we indeed see that we have some sorted results here. So you see we got a bunch of results. That is the first one with 33 persons in this state. Then we got 22 persons in this state. Here we got a bit of a longer state name, hence the different output, but there we got 24 persons. So this looks all right to me. We see the sorting works. And the interesting thing here really is that the sorting was done on the output of our previous stage. So on the output of the group stage. And I hope this already shows you that you have a lot of power with these tools already, because this is essentially a kind of operation we couldn't do with the normal find method, because there we can't group and then sort on the result of our group. We would have to do that in the client-side code with just find. Well, with aggregate, we can run it on the MongoDB server and then simply get back the data in the client that we need in our client to work with. Now here is the data as we have it in our data set again. Now let's have a look at a different pipeline stage that allows us to transform every document instead of grouping multiple together. And that will be the project stage. Now we already know projection from the find method. Well, as an aggregate stage, project became more powerful. So what can project do for us? Let's now start simple and not have any other stage. Let's say we don't do any filtering. We just want to transform every document. Then we can use the project stage, and as all stages, the value for $project here is simply a document where you, well, configure that stage, so to say. And in its most simple form, project works in the same way as the projection works in the find method. So you can, for example, say, I don't want to have the ID by setting it to 0 here. You could say, I only want to have the gender, I want to have the name field and location and email, but I want to reformat some of these fields. So including gender is simple, we just add a 1. But let's say the name should be different now. Let's say the name should be one field instead of this embedded document. And this is something we can easily do with this project stage. We can add new fields here, which is a cool feature. And we could add the full name field, and that full name field could then simply be created on the fly based on the nested name first and name last fields. Now, how would that work? There is a special operator we can use, and you find that in the official docs. A full list to all the operators can be found in an article after this lecture. So you can use a special operator. So you pass an object, first of all, to full name, because we're going to perform an operation. And then here we'll use concat. Concat, $concat allows you to concatenate two strings. And you simply pass an array here which contains the two strings. Now you could hard code some values in here, like hello world. That is also possible. You can work with hard coded data. If I now copy that, you see every person is named hello world concatenated together like this. Also note that there is no white space in between. This is, of course, something you can do, but most likely this is not the result you want to have. So instead, what we want to do is we want to refer to the first and last keys here in the name field. So what we can do for that is we can use a special syntax again. In a string, and the quotation marks are important, with a $, we can refer to name first. Now, the $sign here simply tells MongoDB that this is no hard-coded text, which it should take like this, but that this refers to a field of the incoming document, and that it should take the value of that field instead. And in this case, it's just an embedded field. It could also be a normal field, a non-embedded one. So we can have the first name. Then let's say we add a white space in between. And then here we use name last to refer to this name here. If we now take this code and we run that, we indeed get back documents, the same amount of documents as before, by the way, because unlike group, project does not group multiple documents together. It just transforms every single document. And therefore, we get the same amount of documents, but with a totally different data. And the interesting part, of course, is that we can not just include and exclude data, but that we can even add new fields with hard-coded values if we wanted to, or in our case, with a derived value derived from data that was in the document before. Now, let's say we also want to make sure that the first and last names start with uppercase characters. And we can do that too with the projection phase. I'll just restructure this real quick to make it a bit easier to read. We'll have to make sure to move these up later. So right now we just concatenate our first and last names. But of course we could transform these first and last names too before we concatenate them. So we can pass more complex expressions to concatenate essentially. The first name can be an expression described in a document, and so can the last name. So in the first name here, we can use $toUpper, which is another operator offered by MongoDB. And toUpper can simply receive the field which it should turn into uppercase. So name first. Now it's the same syntax I need for the last element, which we concatenate together, just that it's name last here. Now toUpper, this expression here and this expression, these will return strings. So concatenate will still work on 3 strings, just that the first and the last one are also, well, transformed by us. Let me now move these 2 methods up and let's copy that. If we now run our aggregation, well, everything is uppercase now. Certainly a change, but what if we only want to work with the first characters? Well, then we drill into that further. Now we don't just run toUpper on the entire first name or entire last name. Instead, we want to run it on just the first character of these names. And then we want to append the rest of the word in, well, the normal casing. For this, the thing which I transform with toUpper is the result of yet another expression wrapped into a document. You see a pattern here. All these expressions are always wrapped into documents. Now there I use another operator, the substr CP operator, which returns the substring of, well, a string, so a part of a string. Substring CP takes an array. The first argument is the string. So here I now use name first. The second argument is the starting character of your substring. This will be 0 because strings are 0 indexed. So this is the first character of the string. And then it asks you for how many characters should be included in the substring. And that should be 1 here. So just the first character. Now this will turn the first character of the name into an uppercase character. Of course, we don't just want to have the first character of the name. We also want to have the other characters, just not converted to uppercase. So I will add an additional element to the concat array, and that should now be the rest of the first name. Because here we're extracting the first character and we're converting it to uppercase. Now we need the rest of that name. For that, I'll again use my substring CP operator here. Because I need a substring of name first, I just need the other, well, half or, well, the rest of it. And therefore I start at character 1. But now, of course, I need to find out how many elements I need. And for that, I need to dynamically derive how long the name is. And we can do this with another expression. And it's not uncommon to have nested and more complex stages like this one. So don't worry if this looks very frightening. Obviously, this is a more complex transformation we're doing here, but I find it super important for you to understand how you can work with all these expressions and operators, especially in the project phase where you do a lot of transformations typically. So now here, what I want to do is I want to use another operator, the subtract operator, which simply returns the difference of two numbers. Now, why do I need that? Because the numbers are passed in an array here, because I need to find out the length of my name and then subtract 1 off that, because we start after the first character in this substring. So here, I will now use another operator, strlen_cp, which calculates the length of a string, and there I point at name first again, and then I subtract 1 from that. So this is the second element in the subtract array. Okay, so this is quite a complex operation, but in the end what I do here is I simply retrieve the rest of the name by starting after the first character, and then I find out how long that name is if I, well, reduce it by that one character. So if I subtract that one starting character. Now, previously we had Gideon van Drongelen. Let's now repeat this for the last name and see if we have Gideon van Drongelen where only the first character is the uppercase character. So let me grab this entire code and let's replace this code with it. And now we just need to replace name first with name last in all 3 places. And that should be it. Let's now move pretty up and aggregate up and copy that entire command. Let's move over and execute it. And this looks much better. Now we have only the first characters of each name converted to uppercase characters, and you learned a lot about operators and how you typically work with them and combine them, especially in the project phase, which is all about transforming data. So you learned a lot about projection and that there are many operators you can use for that in the last lectures, which is super important because that is one of the core things the aggregation pipeline is all about. Now let's project a bit more, because this really is an important step of almost any pipeline you're going to build. And for that, let's first of all have a look at our input data one more time. Thus far, we basically only included the gender and our transformed name here. Now, what else could we include? Well, for example, the location. We could already prepare the location so that we can later work with it. So what we could do is we could basically turn the location into a GeoJSON object where we have a type, which will be a point because we have 2 coordinates. And then we have coordinates, but that should then be an array of 2 numbers instead of an object of latitude and longitude, which also are strings and not numbers. So this will again be quite a complex transformation, but one which makes sense here and which we will need. I also want to include my email in the output, and I want to include my date of birth data, but I also want to transform this to basically flatten it, to not have a nested document, but simply have a birth date, which is this, and then an age field as a top level field. Now, definitely feel free to pause and do this on your own, but we will need a couple of operators we haven't touched on yet. So also feel free to follow along with me, depending on whether you feel like diving into the official docs or not. So, let's start with the location. Now, what I will do to keep this a bit more manageable, I will add an extra project stage, and this already also shows you something else which is important. You can have the same stage multiple times, and that's not that uncommon, to be honest. Often you also do some matching, sorting, grouping, and then you project, and then maybe you sort again. So often you have some in-between stages. Here, I split it across 2 stages to make it easier to read. So we'll exclude my ID here already, and therefore I don't have to do it here, because remember, this stage will receive the output of this stage, so if I exclude the ID here, it will not be available in the next stage. I should put this between curly braces though. Now I will add the name here that should be included because the name is something I need in the next stage. So we have to make sure that we pass this embedded document. And then I want to work on the location and so on. Now, first of all, I'll pass on the email because that will also just be in the next stage without any changes. And therefore, in the next stage, I'll also keep that email and, well, output it as a result of this stage too. And now let's work on the location. Now, the location at the moment is an embedded document with a lot of data that I'm currently not interested in for this operation, and where I also, well, have it in the wrong format. I want to have a type and then coordinates, which should be an array. So location should be a document. This is the case. And in that document, I want to have a type field, which will be point. And that is something we can do. We can add hard-coded values like this. So now I added this. Now I also need to add my coordinates. The coordinates right now are a nested document like this. I need an array of coordinates though. And this is relatively simple to achieve. I simply set coordinates to an array. And now the first value here will be $. And now I need to access location, coordinates, longitude, because remember, for a GeoJSON object, the first value has to be a longitude. So I access location, coordinates, longitude here. So this field is getting accessed here. The $ is important to tell MongoDB that this is not a hard-coded string value, but instead the value stored in this path here in our document. And the second element of the coordinates array is almost the same, but of course here I refer to latitude. So now this is my project phase as it is currently written. So now our location should be such a GeoJSON object. Let's give this a try. For this, let's also include location, which is this location because we get the output of the last stage as an input to this stage. So we will have that location key, which is the result of this location transformation. And let's include that in our new output. Now, again, aggregate has to go on this line and pretty has to go on this line. And now let's copy that entire stage here. And let's run it. And what we can see is that for every person, we indeed have the full name, we have the email, and location indeed is a point or is a GeoJSON object with type point and coordinates. Now, one thing you might also see is that this, however, is a string and not a number, which it should be. Now, to change that, we have to convert this string. Converting data is something you often have to do. We'll have to do it later again for the birth date, but now let's do it for our coordinates here. Of course, MongoDB also has a convert operator we can use. So we want to convert our coordinates here. So the value I store as a longitude will be the result of an expression using the $convert operator. The $convert operator takes a document where you configure it, so where you configure its inputs and so on. Now, convert needs a couple of fields. The first field is input, and there you simply define which value should be converted. This, of course, is the value which is stored in a longitude field in our case. The second field, and this is the last field that you need to pass, is the to field. The to field defines the type you want to convert to. Now, which types are available? This is, of course, also something you find in the official docs of the convert method. There you find that the to field takes these string identifiers to convert it to a double or to a decimal, which is simply a construct with higher precision than a normal double, and so on. You also can define on error and on null values, so default values that should be returned in case the transformation fails. So here I want to convert this to a double, which is a floating point value. And on error will be 0, on null will also be 0, or 0.0. So we store or we return just 0 if we fail to convert this. Now I can take this entire step here and replace my latitude step with it. Of course, replacing longitude with latitude down there again. So now these coordinates should be transformed. So let's now bring aggregate and pretty back into line. And let's copy the entire stage or the entire pipeline and execute it. And now we see that the coordinates indeed are numbers. They are no longer wrapped in quotation marks. Okay, so I'm back to the original data format we had by using find1. And what else did we want to transform? Well, I mentioned that I also want to transform the date of birth field. I want to keep the birth date, but in a separate top-level field, and I want to keep the age in a separate top-level field. Now, definitely feel free to try this on your own, because this is a great practice. So here's your chance to pause the video. Thereafter, we'll do this together. Were you successful? Let's transform the birth data together. For this, in our existing aggregation pipeline here, I will add a new field which I want to change. I'll add it here above location. You could also add a new project stage if you wanted to have multiple project stages to keep this a bit cleaner. This is totally up to you. Now I will add a new birth date field. Again, adding new fields is no problem. The birth date field will in general hold the value of DOB date. So we could simply say $DOB date, $ to tell MongoDB that we refer to a field in the input document. This is something we could generally do. However, this will of course keep the birth date as a string because it is stored as a string here. Now, thankfully, this string already is in a great format that can easily be converted by MongoDB. So we should convert it. For that, we can of course use the convert method or the convert operator again. So on the birth date here, I will instead say convert. The input will be my DOB date. I need to close two curly braces. And I want to convert to the date type. And you find that type in the official docs as I showed you in the last lecture. We can also specify on error and on null, but I'll omit this here. I should be fine. I should have a birth date on every record. And I will also now pull out the age. Now that will be simple. The age is a number. I want to keep it as a number. I will just pull it out of DOB age. So I will simply say age is now a top-level field. I add it as a top-level field here. And of course, I could name it differently, just as I named it birth date here and not date. So here I will refer to DOB age, and I will keep the type as it is. Now, one important thing, since I got two project stages and I added two new fields in the first one, I need to go to the second one and take these new fields with me. So I need to add the two new fields here too, and just make sure that they are included in the output of this project stage. So now with that, let's again move aggregate up, and let's move pretty up. Let's copy the entire content here and execute it. And we can see we got a birth date, which is now this special ISO date object or type provided by MongoDB, and we got our age as a top-level field. And now I really transformed my documents quite a lot already. I got some key information in every document here, and this is looking really great and really helpful. Now, let's see what else we can do and which other nice pipeline stages we might have. Well, there's one more thing about convert though. We convert quite a bit in our dataset, and that is of course all right. However, if you just need a simple conversion like this one, where you don't specify on error and on null, then you can also use a shortcut. There are some special operators in MongoDB, and of course you find them in the official docs under aggregation pipeline operators. There you find, if you scroll down to T, to date, to decimal, to double, to int, to long, and so on operators. So these are shortcuts if you need to do a specific transformation. So in my case here, where I don't have onError and onNull, I could just say toDate here and simply pass in the field which holds the date value I want to transform, just like that. And this will yield the same output as we had before. If I execute this, you see we still have our ISO date, but now it's a bit shorter. So be aware of these shortcuts for simple transformations. If you do want to specify your own onError and onNull fallback, because you might have incomplete data in your dataset, then using these shortcuts is a bit more difficult. You at least have to check their docs to see if the default values they will then assume are alright for you. Now, with all the projections we did thus far, let's now add another stage again after all our projections. So here, I'll add another group stage, because this is another common scenario that you first want to restructure your data, recalculate some fields as we are doing it. We're adding brand new fields which didn't exist before, and then you want to group on these derived fields. In my case here, I want to group on the birth date, and yes, this was available before, but not as a date at least. We converted it, and I will now take advantage of this conversion. So we'll take advantage of my birth date, which is now stored as a date, in the group stage here. We saw the group stage before. We add _ID here, and then we define by which value we want to group. Now here, I want to group by birth date, but not by the date, but let's say by the year. So birth year is by which I want to group. Therefore, we add a document here, and then the operator is the ISO year operator, which basically retrieves the year out of a date. So the date then is stored in $birthdate, pointing at my birthdate field, of course. And now what do I want to do when grouping these documents? Well, I want to calculate how many persons were born in this year. So num persons is what I calculate here, and I use sum1 to basically add 1 for every document that goes into that group. And since one document represents one person, I will have the number of persons per birth year here at the end. So now with that, whoops, this is ISO week year, by the way. Should be week year. So now let's copy that, paste it in here, and you see I got my years extracted here as a long number. This is what MongoDB did for me. And I see how many persons were born in there. Obviously, my other projection phases are now rendered a bit useless, since I don't take advantage of all the other fields I added here. This is just temporarily. I just wanted to show you that you can group on the results of projections. So here I have the group stage. Let's now maybe even sort. And let's sort on the num persons in descending order to start with the most persons first. If I now enter this here, now we see most persons in the example dataset were born in 1955. Now we worked a lot with group and project, and it's really important for you to understand the difference. Group is for grouping multiple documents into one document, whereas project is a one-to-one relation. You get one document in and you will return one document. That one document will just have changed. So for a group, you have multiple documents and you return one, grouped by one or more categories of your choice, and then also with any new fields with some summary, statistics or summary calculations. In projection, you have a one-to-one relation. So in grouping, you do things like summing, counting, averaging, and so on. In projection phases, you transform a single document, you add new fields, and so on. This is the difference, and this is really important to understand and to get right. We already had a look at a couple of pipeline stages and operators. Now I want to dive into some stages and operators that help you with working with arrays. And therefore, I prepared some new data, which you can either import with Mongo import, or you just go into your Mongo shell, create a new collection on the fly. I'll name it friends, and I'll insert many documents and then add an opening parentheses, no closing parentheses, copy in the values and then close it and hit enter. And this should now also add the 3 elements. So in the friends collection, I now have these 3 documents, 3 persons with name, age, and hobbies, and then some exam scores. And I just need some arrays here because you can do quite a lot of things with arrays in the aggregation framework. Now, what can we do with these arrays? Well, one thing you often want to do is that you want to kind of merge or combine arrays in a grouping stage. So let's start with that. So for that, I prepared a brand new aggregation pipeline, and we'll start with grouping our results. I will group by age, let's say. And by the way, you can also group if you just group by one field, like this. But I'm a fan of the document syntax because there you can assign your own names and make it clearer by what you grouped. So I will group by age. And of course, I do have age on my documents. I only got 3, so we'll only have, well, not that many groups, but still, let's do that. Let's group by age. And let's then say we want to combine the hobby arrays so that we know which hobbies exist for this age group and for that age group. And we can do that. We can add an array, we can name it hobbies, or you give it a brand new name, like all hobbies, whatever you want. And now there are 2 operators mainly that help you with combining array values. Because you have to keep in mind that in the group stage, multiple documents are merged into one. So we also need a way of handling multiple array values in one array. And we can do that here with the push operator. The push operator allows you to push a new element into the all hobbies array for every incoming document. Now, every incoming document here will have a hobbies array. This one, this hobbies field, and you could push any field value into the array, not just existing arrays. So what I will do is I will now push $hobbies. Now let's give this a try. Let's take this aggregation pipeline and run it. However, not on persons, but on friends. So let's rerun it like this. Now what you see is that we have 2 groups, age 30 and age 29, and all hobbies is an array of arrays because we push hobbies into our array, and hobbies happens to be an array itself. Here, hobbies is an array, and we just push that value into our all hobbies array here. That is what I meant. You can push any value, of course, not just existing arrays. But what if you wanted to push the values of existing arrays in there, but not as one array, but you want to pull these values out of this array and then add them to all hobbies? Well, that is also something you can do, and I will show you how it works in the next lecture. So in the last lecture, you saw how you can push elements into newly created arrays, and I will emphasize this again, that the values you push don't have to be arrays themselves. We could have pushed the age or the name. That would have worked too. And then we would have all hobbies, or a different name then, which would be an array of all the ages that are in the group, or all the names that are in the group. So this would have worked too. I, however, want to have these values in all hobbies, but not in their nested arrays. And for that, I will add a new pipeline stage, which we haven't seen before. And that is the unwind stage. The unwind stage is always a great stage when you have an array of which you want to pull out the elements. Now, to understand what unwind does, I'll temporarily move my grouping out of there so that I can just copy that later, and I'll complete the unwind stage. Unwind has 2 different syntaxes, and you can check the official docs for all the details as always. In its most common usage, you just pass the name of a field that holds an array, so hobbies. Remember, we get our initial documents as an input to this stage, and now we just unwind on hobbies. Now what does unwind do? Well, let's take that stage and let's see. If I execute this, you see what I get back are a couple of documents, more than we originally had, because now we have a document max with hobby sports, and we have Max again with hobbies cooking. So what unwind does is it basically flattens the array by repeating the document that held the array as often as needed to merge it with the array elements. So the original array of Max simply had sports and cooking. Therefore, Max was repeated twice. We get two new documents, Max with sports and Max with cooking. And the same is true for all other elements. So where a group merges multiple documents into one, unwind takes one document and spits out multiple documents. And now with that, we can group again, but now we can simply take hobbies, which is no longer an array, but a single value. So if I now bring back my group stage, I can leave it as it is, but now you will see, if I repeat this, I still only have two groups because the ages haven't changed, but now you see all hobbies holds just my array values and not the embedded arrays. However, you can also see that we can have duplicate values. So what can we do about that? You might not want duplicate values. And to avoid that, you can use an alternative to push. Instead of push, you can use add to set. Add to set does almost the same, but if I run it, you see now we have no duplicate values. Because add to set essentially also pushes, but avoids duplicate values. If it finds that an entry already exists, it just doesn't push the new value. This is what add to set does. So with that, with unwind, with push in the group stage, and with add to set in the group stage, you get powerful features that should help you manage your array data efficiently and transform it into whichever format you require. Time for more interesting projections, but now projections that work with arrays or are related to arrays. I'll stick to my friends data set for this. So let's quickly peek into it and let's work with the exam scores now. Let's say you only want to output the first value of that array instead of all the exam scores. So it's time for a projection, of course. So let's add a project phase here. And in projection, I'm not interested in the ID, but I'm very interested in my exam score, and I'll name it exam score and not scores because I'll only output one. Now, to output one, there's a helpful operator, and this is of course the main thing I want to show you here, the slice operator. The slice operator allows you to get back the slice of an array. So how does the slice operator work? It takes an array itself. The first value is the array you want to slice, and you could hard-code an array in here. That would be possible. But of course, I will point onto a field with $, and then exam scores. So I'm essentially pointing at this field. And now I only want to get the first element, and for this I pass 1 as the second argument. Because slice takes, in its basic form, two arguments, the array and the amount of elements you want to get out of the array seen from the start. So here, with this, if I take this command and I execute it, you see now I only have my exam score, or one exam score per user, and that is the first exam score. We can validate this with the last user. The first one should be difficulty free and score is 75.1, and that is the case here too. Now, sometimes you want to have, let's say, the last two. For this, you can actually use a negative value here, -2, because then we'll start at the end. If I now paste this in, you see I get the last two scores per user, so this also works. Or you want to get one element, but starting at the second element, then you could also use a different syntax with 3 elements in the array, 2 and then 1. This means start at position 2 and then give me one element. And if I now execute this, you see I get back some exam scores. And which scores are that? Well, these are the last scores because indexes are 0 based. So if I start at 2, I will skip 0 and 1. So the first two elements, I start at the last element therefore, and then I take one element so I get back the last element. So these are the different ways of using slice, and that can be very helpful for transforming an array or getting just the values of an array you need. Maybe I'm not interested in the scores, I just want to know how many exams a friend here took. This is also something you can easily find out in the project phase. We could add num scores here, and then we can use a helpful operator, the size operator, which calculates the length of an array. And here we can simply input the, name of the field which holds the array, or again, hard-code an array in here if you wanted to, for whatever reason. So here I will point at exam scores, and it will calculate the size for that array and store it in num scores. So if I now copy that entire command here, you see we get 3 for every user because every user happens to have 3 exams in our data set here. But this is how you can get the length of an array with the $size operator and then a pointer to the field which holds the array for which you want to calculate the length, and then this gets stored in a new field. Let's look into our friends in their raw form again. And let's now say we want to transform exam scores to be an array where we only see scores higher than 60. Now, this can also be done in the projection phase, because I want to transform every single friend record. I don't want to group by anything. I just want to transform the array in there. And to achieve this, I'll add exam scores again. You could name this differently though. This is up to you. And in there, you can now use the special filter operator. Now, how does filter work? Filter allows you to filter out certain elements in an array and only return these that fulfill a certain condition. So here I would want to filter for the score being greater than 60. Now, how does this work? First of all, you need to add an input here. And that is the array which you want to filter. In our case, we could say it's obvious that I want to filter on exam scores because I will store the result in a field name exam scores, but keep in mind you can name this field however you want. So therefore, filter needs to know where is the input array. And the input array is exam scores with a $sign because I'm pointing at a field in my document. Then we assign a temporary name. This is a so-called local variable which will be used inside our filter expression, which we'll write in a second. You can name this however you want. I'll name it SC to not repeat scores all the time, but you can name this however you want. The last element we need, or the last field, is the condition, COND, cond. Now, the condition here can take a bunch of expression operators, to which you also find a link in the last lecture of this module. And I'll just bring this into a new line to make it easier to read. The expression operator I want to use here is greater than. Now, greater than here works a bit different than when we used it in match or find. Here, greater than simply takes an array of values it should compare. And this makes sense because we are now in the context of another operator. So we can't compare exam scores, the whole array, or anything like that. Instead here, what I want to compare inside of my filter expression is, of course, the value of this temporary variable, which will refer to the different values in my exam scores. So you can imagine this being a function that gets executed for every exam score in my exam scores array. And then every value will temporarily be stored in here so that we can compare it. So here in greater than, I will check if my SC variable is greater than 60. This is how this works. However, SC like this would be treated as a string. We need to tell MongoDB that we're referring to this variable. Now, $sign would look for a field named SC. We add $2 in this case. You don't see it that often because you don't have that many operators of this kind, but filter, which essentially executes a function over and over again on all the fields in exam scores, or all the elements in there, I should say. Filter needs such a temporary variable for every step it executes for us, and we can refer to this temporary variable with the $sign syntax then. Now, with this approach, we would not get the result we want though, because you have to keep in mind that exam scores is in the end, and I can show this to you again, is in the end an array of embedded documents where you have a difficulty and score. Now, as C here would refer to the overall embedded document. Now I'm interested in the score though. So I have to check sc.score here in my greater than condition. And with that, I can take that aggregate function, execute it, and we should get arrays with only scores greater than 60. So you can see that here. I get one document with scores greater than 60. Then we got another document with scores greater than 60. There we only got one exam, hence we only got one object in there. And then this last one. So this is how filter works. Filter allows you to filter arrays in documents inside of the projection phase. So we're coming closer to the end of this array section, but it's really important that you understand how you can work with these different array stages like unwind and operators that you can then use within the project phase or the group phase. So let's say we now wanted to transform our friend objects such that we only output the highest exam score for every person. So we no longer have the exam scores array. We still only get 3 person results, but we have no exam scores in there, but only the highest exam score. Now, there probably are multiple ways of achieving this. Definitely feel free to pause the video and try it on your own. Thereafter, I will show you one solution I came up with. So, were you successful? This is definitely a challenging task. Now, to get the highest possible score, what we need to do is we will need to unwind this array to get multiple documents per person, with the scores being a top level element, so that we can then sort the documents by the scores and then group them together by person and take the first score that we find for that person. So let's do that step by step. The first phase I'll add here is the unwind phase. And I want to unwind on the exam scores like this. Now this will give me many new documents where we have many pairs of persons and their scores. In the next stage thereafter, I want to sort. And I want to sort on exam scores, which will not be an array anymore at this point because of unwind, but a single value. And I want to sort in descending order. By the way, you don't use $ exam scores here because I'm referring to the field name and not to the value of the field here. So let's try this. So now what I get is a bunch of documents, and the document at the top has the lowest score because what went wrong? Well, I basically forgot that in exam scores we have nested objects, of course. And we don't have the value itself stored in exam score after unwinding, but the embedded document. So what can we do? Well, of course, we can sort by exam scores dot score here. Or let's try an alternative. What if we unwind on exam scores score here? Well, this does not work because the score is not an array. So this is not something we can do. We can, of course, do what I just mentioned and sort on a different field, or we add a projection stage in between where we maybe omit the ID, where we do include the name and the age, and let's say also, let's say we leave out the hobbies. And I do add a score field here, which is exam scores score with a $ here, so that I take the value of this field. And then here I could sort by score, which is now the newly stored value. If I take this and I insert it here, now this looks better. Now we got our unwinded documents, and you see that we have sorted them with the highest scores first. Now we just need to add a group stage. So what we can do here is we can add group, And I want to group by my name, of course, so that the persons stay together. We could also group by ID if we kept this included. Maybe let's do that because names could be duplicated, IDs won't. So let's group by underscore ID. Now I'm using a slightly different syntax than before. I don't have curly braces, ID, like this. I could absolutely do that, but this just adds some extra readability. In this case, since I have the old ID and I keep it as an ID, I think it's readable enough. So I'm now grouping by ID. And if I now copy that, let's see what that gives us. Well, just gives us the ID like this. We should use a value here. So now I just get 3 objects with the ID. The other fields are lost, which makes sense because grouping, well, merges the documents together. So if we want to keep some information, we have to add it in the group stage. So let's go to the group stage here. And there, I'll add a max score field. And here, we can use the max operator, which you can find in the official docs. And I'll simply say that I want to get the maximum based on the score field. Now let's grab this and execute it. And now you see that I calculate max scores. Now let's quickly validate if this is correct by checking out all friends here. So what we have there is that for the first person, Max, the highest score is 88.5. And let's compare IDs. Yes, this is the ID of Max. This seems to be correct here. Now, for Manuel, the ID ends with a 5. The highest score is 74.3. And this looks good too. And I assume it's also correct for Maria. So this worked. We now have our max score. Now, it would also be nice to see the name here, right? And it would also be nice to not just see the max score like this, but to also sort these documents here in descending order. Now, regarding the name, I'll add a name field here. And there's another operator we can use here. It's the first operator, which simply tells MongoDB, hey, use the first value you encounter. And since the name is the same on all documents for this group, this is perfectly fine. So I can point at $name here, referring to the name which I had in the input documents. And now to also sort this, let's add another sort stage here. And there I will sort for my max score. So let's sort max score in a descending order. And now this is my finished pipeline. Let's try it out. This is looking good. We have the name in there and we have descending scores. So this shows you, hopefully, how you can work with arrays and how you can combine the different pipeline phases to split arrays up, to pull array values out of there, to then group them together, and so on. I'm back to the persons dataset we used earlier in the persons collection. Now, sometimes you want to get a feeling for the distribution of the data you have. And there is a useful command that can help you with that, the bucket stage. So let's prepare our pipeline for this, and let's add the $bucket stage. Now, what does bucket do? The bucket stage allows you to output your data in buckets for which you can calculate certain summary statistics. Bucket takes a group by parameter here, a group by field, where you define by which field do you want to put your data into buckets. And here I will go for the age, so dub age. So here I'll refer to $dub.age. This tells bucket, okay, where is my input data essentially, which I want to put into buckets. Then you define some boundaries, and these are essentially your categories. So you could say I'm interested in my ages 0 to 18, to 30, to 50, to 80, to 120, something like this. This would now create your buckets, so the different categories you have, you want to categorize your data into. Now the question is, what do you want to output for these buckets? And here you define the structure of what you get back. So I could say that in each bucket, I want to have an array of the names. This can be done like in the group phase with the push operator, and I simply push name in there. Now name is an object here, it's this object, so maybe we just take the first names to keep it a bit shorter. You could push objects too, I just want to keep it shorter. So now each bucket will have a document where I see the names of the people who are in the bucket. I also want to see the average age, let's say. We can do that with the average operator you saw before. And here I simply point at DOBH. And I also want to find out how many persons are in the bucket. So for this, we can use sum1. Just in the group stage, 1 will be added for every element in the bucket. Now, let's give this a try. For that, I'll move pretty and aggregate into their positions, copy that, and execute it. And now, well, we have a lot of names in there. It probably was not my best idea to put all the names into the buckets. Here we have a bucket border. Here we see basically for which category this bucket is. We see there are 2,300 people in there. We see the average age. Now, let me get rid of the names here because it's really hard to read that otherwise. So I'll just use the summary statistics now. And this is now easier to read. So now we see we got 3 buckets here, 3 categories essentially. And the reason for us having only 3 buckets is probably that we seem to have no persons younger than 18 or older than 80. So these buckets and this starting point seem to be redundant. Let's quickly check this by running a query on persons and finding all persons who are younger than 18. So we can, of course, do that by pointing at DOBH and then using the lower than operator to see who's lower than 18. And we got none. And now let's tweak this for greater than 80. And we got none there too. So this is correct. And if we sum this up, we would also get our 5,000 records, by the way. And this is the bucket command and how we can use it to get an idea of the distribution. Now we can, of course, fine-tune this. Since we know that we got no one who's younger than 18, we can get rid of that. And we want to keep our end bound so that everyone fits in there, but we could add more levels in between for 40 and 60. If I now run this, you see now we got more buckets for more granularity. This is 62 open end basically. And this gives us an idea for our distribution and the average age in every bucket and so on. Now, there also is an alternative to this. You can also run, let me quickly create a new aggregate pipeline. You can also run another stage, which is called bucket auto. Now, as the name suggests, bucket auto does the bucketing algorithm for you. What you do here is you simply define the group by key, because of course you need to tell by which field to bucket, so dob.h. You then also define the number of buckets you want to have, and they will then be derived automatically. So MongoDB will look at your data and see where it should draw the boundaries. So we could say we want 5 buckets. And then you also define the output, of course, because you still define what you want to see. And I'll just copy the output from above. So now, if I turn this into a usable format, I can copy that. And if I execute this now, you see, now I get this output. MongoDB tells me which boundaries it created for me. So I see that the youngest person seems to be 21 years old. And then I get these buckets with my summary statistics. Now, each bucket holds almost the same amount of values because MongoDB tried to derive an equal distribution. And bucket auto can be an even quicker way for getting a feeling for your data. We had a look at a lot of operators and a lot of pipeline stages. And of course, I encourage you to dive into the official docs. Now, I want to have a look at some stages which we saw before, but which you have to get right. And therefore, let's see how we work with these stages. Let's say we want to find the 10 users, the 10 persons with the oldest birth date. So the lowest birth date, so to say. And thereafter, we want to find the next 10. So like if we had pagination in place. Now for that, first of all, I will add a project phase to convert my date. I also could sort it whilst it's in string form, but I still want to convert it also to practice this again. I'm not interested in my ID. I will keep my name. And then I'll have my birth date field, which I will convert to a date. And the input for toDate is DOB date, of course, referring to this field here. Now let's try that out. If I run this command, I get persons where the name and the birth date is available. Now we can sort on this birth date. So let's add a new stage here. Sort. And let's sort by birth date, as I just said. So we can simply say birth date, referring to our newly added field here, in ascending order, so that the lowest birth date comes first. If I do that, well, then I have a bunch of birth dates here, which look pretty low. And keep in mind, we only see 20 results here because we get back a cursor. So we got pretty old persons or pretty old people there. Thanks to my date ordering, the very oldest person is Mrs. Victoria Hale because she's born on 7th September. And even though this person here, I'm sorry, I don't know how to pronounce this. Even though this person is equally old in terms of years, it's not the case in terms of days. So this is the oldest person in the dataset. Now I only want to see the top 10. And for this, we can add another stage, which we saw before with the find method, but haven't seen here yet, the limit stage. Now limit is pretty straightforward. We just define how many entries we want to see. 10, let's say. If I copy that and I print it out, we now see 10 records only. There is no type IT to see more anymore because we exhausted our cursor here because we only see 10 and therefore this is what we get back. So now we have the top 10 oldest people in our dataset. Now let me quickly change that name to make it a bit more readable. I will use concat here to build a name. I will not do the whole change with the uppercase starting characters to keep this a bit smaller, but I will point at name first, add a white space, and then use name last here, simply because now if I use this stage, we have single lines for the persons. So now I got my top 10 here, which is great, of course. Now let's say we want to see the next 10. We can do this with another stage, and that is the skip stage, which we have to add prior to limit. So now we skip the first 10 records and show the next 10. If I now copy this and I paste it in, we see different names because we simply skipped to the next page, you could say. Now what's really important here is the order of skip, limit, and sort. If I had skip after limit like this, and I copy that, I get back no results. Because what happens here is I do my projection, I sort, then I fetch 10 persons, and then I skip by 10 persons. So what's remaining? Well, 0. So that is why this order is important. The order did not matter on the find method. There you could chain the skip and limit methods onto your cursor as you wanted. Here, it does matter because your pipeline is processed step by step. The same, of course, is true for sorting. If I do sort after this, so after skipping and limiting, I get a totally different set of results Because if I now execute this, I have people who are not that old. They're born in the 1980s, even 1990s. The reason for that is that I simply skip the first 10 persons in my dataset as it's stored in the collection, and then I take the next 10 and I only sort these 10 persons. So this is really important to understand. The same, of course, would be the case if you have a match in there. If we want to find the oldest males, let's say, we should include a match phase, and we should include that early to limit the amount of data we have to work with in the other stages. So here, I can match for gender being equal to male, of course. And if I do that, everything will be fine and I get the 10 oldest men here. Well, not right now because the order is incorrect. We just broke that, right? But we do match. However, if I fix the order like this and I execute it then, now we do have the 10 oldest men. And as I mentioned, the order does matter because if I do match after sorting, which I can do, I can filter at any point of time. I don't have to do this at the beginning. But if I do match here, I get back no results at all. And the reason for that is that gender is not included in my projection phase. So I try to match something which is not there. If I do add gender here in my projection phase, then I will get results. But now I still have a suboptimal setup because I do match only after transforming all the elements in my collection. So I will have projected all the females here too, even though later I'm only interested in the males. So I should reverse this. Now, actually, MongoDB will do some optimizations for you. You'll find details in the next lecture, which is an article. MongoDB does some optimizations for you to optimize your pipeline. So it might very well have fixed this issue here for us. But you shouldn't rely too much on that, and you should try to build correct pipelines with the correct order that optimizes for performance and, of course, well, builds the kind of structure you want to have. I'm back to a pipeline we built earlier. You find it attached to this video. This pipeline here will return us persons in a restructured form where we also have the location. Now, if we want to use that location, we can't do that inside of our pipeline here. We do actually have a pipeline stage for working with geodata, but that has to always come first in order to take advantage of indexes. Now, what can we do? Well, the good thing is you can also take the result of a pipeline and write it into a new collection. Of course, not just if you have geodata in there. You can always do that. For that, you do specify another pipeline stage, the $out stage for output. And this will take the result of your operation and write it into a collection, either a new one, which is created on the fly, or an existing one. I'll name this transformed persons. So I only added this stage. If I now copy that and I run it, without pretty at the end, by the way, but it should have still worked. You see, I have my transformed persons there. And if I look into transformed persons, you see the structure in there is exactly the structure we created in the last pipeline. So the out operator is great if you have a pipeline where you want to funnel your results right into a new collection. Often you want to use it and just fetch it, but if you need to store it, you can do that with the out stage. Now that we have data stored in a new collection, let's use that new collection and let's create an index, a geo-index in there, so that we can actually use the geo-near stage, which also exists in the aggregation framework. For this, I'll create an index on the location field with db transform persons create index, as we did in the geospatial module. This is the field name, and we want to have a 2D sphere index on that. So now with that index created, we can use transform persons for geolocation queries and also for the geolocation or the geospatial aggregation pipeline step. I'll run the pipeline I'll build now against transformed persons. And I want to use a special stage which is built for working with geodata, the $geo_near stage. Now, geo_near takes a bunch of input to configure it. First of all, we need to define the point where we are for which we want to find close points, because geo_near allows us to simply find elements in our collection, documents in our collection, which are close to our current position. That is what geo_near does. Now, for this, I need to pick a location, and I will take the coordinates I have here to guarantee that I'm at least close to at least one document in my collection. Near is not just a pair of coordinates though, it's a GeoJSON object. So we have to define a point and then the coordinates, and these are now two coordinates, longitude and latitude. And I will slightly modify that so that I don't have exactly the same location. So now we have that near parameter filled out. Next, we can define a max distance in meters. Let's say we want to have like 10,000 meters, so 10 kilometers. You can also limit the amount of results you want to retrieve. And you can do this in this step instead of with a limit stage to do this more efficiently and just request this amount of documents instead of getting all and then limiting it in a new pipeline stage after you already fetched all. So let's say we want to limit it to 10. And we could also add a query here where we filter for other things. Now this is available because geo_near has to be the first element in a pipeline. If you want to use geo_near, it has to be the first element in the pipeline because it needs to use that index, and the first pipeline element is the only element with direct access to the collection. Other pipeline stages just get the output of the previous pipeline stage. This is the only element with direct access to the collection. So therefore, if you have any other filters which you want to run directly on the collection, you can add it here, and MongoDB will basically execute a very efficient query against the collection and not force you to then use a match stage as a next step, which might mean that you have to fetch all data in order to be able to match in the next step. So here we could look for persons who are male, for example, or female to mix it up. Now, with that, there's one more field we have to specify, and that is the distance field. Distance field, because geo_near will actually also give us back the distance it calculated between our point and the document it found. And we can tell MongoDB in which new field it should store that. And I'll just name it distance. This name is up to you. Now let's give it a try. The aggregate should be in the right positions. And I find no results, which is of course my fault, because if I have a look into transformed persons, we see there is no gender in there. Yeah. So let's fix this and let's maybe look for a different query. Let's look for age greater than 30. Okay, so let's try this again with the new query. Then I get no results. Well, maybe the distance is the problem. Let's improve that and let's go from 10 kilometers to 1,000 kilometers, so 1 million meters. And now this looks better. Now I have some results. And there, you can also see this new distance field was added to the output. This is the distance of this person to me. So you see 10 kilometers was a bit too optimistic. They're all like 600 kilometers away from me. And this is how you can use geo_near as a pipeline stage. One of the most important things to remember here is that it has to be the first stage. Thereafter, you can of course add all the other stages in the way I described it in the rest of this module. So that's it for this module. We had a detailed look at the aggregation framework and the stages and operators it offers. There are plenty of available stages and operators, as you saw, and I can only encourage you to dive into the official docs, which are awesome and have detailed examples for all of them, to explore them all and play around with them. Because playing around with them with some dummy data really is the best thing you can do here. Now, stages define the different steps through which your data is funneled. And each stage receives the output of the last stage as the input, except for the first stage, which interacts directly with your collection and which therefore can take advantage of indexes and so on. So the first stage has like a special role. Also keep in mind that MongoDB automatically optimizes your pipeline behind the scenes to, for example, match early. You should still try to write good code and a good setup of pipeline stages to efficiently query your data and query before you sort or project to avoid unnecessary sorting or projections on all the data if you planned to filter it down anyways. Now, operators can be used inside of stages, and which operator can be used where depends on the stage. And you can really just get a feeling for that over time as you do work with all these operators. The official docs again help you with that as they describe use cases for all operators. Now, there are a couple of important stages. The most common stages you will work with are probably match, group, project, sort, unwind. Now, of course, all the other stages are good too, and you should definitely use whatever is the right tool for the job you're trying to get done, but you'll work with these stages a lot. So you should definitely make sure that you got these set and that you understand what they do. There also are some common behaviors that are shared between find, filters and projection, and match and project, which are kind of the equivalents in the aggregation framework. But keep in mind that in the aggregation framework, especially project is way more flexible and can do way more things like add new fields, recalculate, a lot of stuff that you can't do in the projection in the find method. So with that, I really encourage you to dive into the docs, pick some dummy data, maybe the data we use here or some other data, and play around with these stages and these operators. This is the best way you can learn how to use the aggregation framework. When building applications with MongoDB, you will most likely also work with some numbers. Maybe you're building an online shop where you store products that obviously will have prices, and where you store orders, which will have order volumes or prices, or whether you're building a database for scientific data with which you or other people might run scientific calculations. Numbers are everywhere. And of course, you can store numbers in MongoDB too. And so far throughout this course, we heavily worked with numbers already. Now, actually, working with numbers can be more complex than you might think, or there is more to it than you might think. And therefore, in this module, we'll dive into the different number types MongoDB supports, how they differ, and when you might use which. So which important number types do we have to differentiate? And these are mostly integers, longs or long integers, and doubles, of which we also have different types. To be precise, we can work with these 4 types of numbers in MongoDB. We can have integers, so-called int32 integers in MongoDB to be precise. These are full numbers, so we have no decimal places here. For longs, it's the same. These are also full numbers, and I'll talk about the difference between int64 and int32 in a second. So we got 2 types of data, which are only about storing full numbers. And then we got doubles, also 64-bit, which do actually store numbers with decimal places. So 1.57 could be stored in a double. And actually that double, that 64-bit double, is the default value type MongoDB uses if you pass a number with no extra information. No matter, by the way, that is important, no matter if that number is theoretically an integer and has no decimal place or not. It will be stored as a 64-bit double when passing in the number through the shell. We also have a special type, high precision doubles in MongoDB. These are also numbers with decimal places, but there's one important difference to the normal doubles. So let's compare all these types then to find out what the differences are. int32 integers are full numbers in this range. Quite a big range, and a range that will suffice for a lot of things you might be doing in your application. Since you can store numbers up to 2.1 billion roughly, and the same in the negative range, you should have plenty of space for a lot of the things you do in a lot of applications. But sometimes this range is not big enough. Sometimes you simply work with bigger numbers. For that, you can use longs, long integers. Here, you can store way bigger numbers, which then definitely should suffice for the types of calculations or work you might be doing in your application. If you would store even bigger numbers, you would have to kind of split it up into two fields, which you then manually have to combine in, well, however you are processing these numbers. Now, these are the integers, so we're only talking about full numbers with no decimal places here. But of course, in a lot of applications, let's say product prices, you have decimal places. Your product might cost $9.99 and not $10. So for that, you got doubles. And there, that is important, the decimal values are approximated. And I will show you what this means in a second. But it's really important here to understand that for these normal 64-bit doubles, the decimal places are approximated, not guaranteed or not stored with high precision. And that's exactly the difference to the, well, high precision doubles or decimals, as they are also called. There, the decimal values are stored with high precision. Up to 34 decimal digits are stored with high precision. So you're guaranteed that if you enter 9.9999999, it will be stored as such and not stored differently. Now you might be wondering, why would a double store it with less precision? Well, that's not some bad will by the people who develop MongoDB or anything like that. These are limitations you face in computing due to the way numbers are stored or how computing works in general with bits and so on. Now, diving deeper into this would be way beyond the scope of this course, as it is a highly theoretical and mathematical topic. But in the last lecture of this module, you will find some links to discussions that might be interesting to you if you want to dive into all the theory here and want to learn way more. For now, we just take it as granted. Doubles, for some technical reasons, are not guaranteed, so the decimal places there are not guaranteed to be correct. They are approximated. For the decimals, so the 128-bit doubles, you have a guarantee for up to 34 decimal digits. The way this works is that essentially these 128-bit decimals have a lower range, so the part before the comma is lower there, but therefore you have more precision after the comma. For doubles, you have a higher range, so the integer part is bigger, but the increased size there is basically 1 by losing precision after the comma, you could say. So this is a rough overview, and we'll see all that in the shell and in practice in a second. As a first quick summary, the idea, of course, is that you use integers here for normal integers. If you know you store some value which is a number in that range here and which only is an integer, consider using an integer. And you should consider using that because it will simply take up less space than if you just enter it as a normal value, and therefore it automatically gets stored as a 64-bit double. Use a long if you need it. If your range for 32 integers is not enough, use a long if you only work with full numbers. You can use doubles for basically all values where you don't need high precision, you could say. So this is your quick and lazy approach to storing numbers, but it's also a valid approach for storing numbers that have digits, that have decimal places, where you just don't need high precision. And we, of course, have the high precision doubles here if you need that high precision for calculations with monetary data, let's say, or for scientific calculations. You will have noted that throughout the course, we always just used doubles, so just entered a value, and therefore we automatically used the 64-bit doubles here. And that was simply also to not focus on the numbers too much there and simply get the values into the database, focus on the different parts we explained, like the operators, how to query stuff, and so on. If you're building an application and you know you're storing something like a age, you should at least consider taking an int32 instead of the lazy route of using a double, because it will be smaller. But more on that in the next lectures now. Now, before exploring all these exciting types you saw on the previous slide, there is something important I need to highlight about numbers in the Mongo shell. The Mongo shell is based on JavaScript. It's basically implemented in JavaScript, you could say. And therefore, it follows some defaults JavaScript just has, well, inherit. And one of that is that a number like 64 by default in JavaScript is not stored as an integer or treated as an integer, but as a 64-bit float, so as a double. This is just a default in JavaScript. So this number and this number are essentially the same in JavaScript. Behind the scenes, they will be stored in something like this with some kind of imprecision at some point. Doesn't have to be a 2 at exactly this place, but it will have some imprecision because it's a 64-bit float. This is how it works in JavaScript. And therefore, if I just use a dummy collection, numTest, whatever you want to use, and I insert one value in there with A1, since I'm doing this from within the Mongo shell, this one will be inserted into MongoDB as a double, not as this 128-bit high precision decimal. We'll have a look at that in this module, but as a 64-bit float double. So this is how it will be inserted. It will not be inserted as a int32. And I highlight this because this is really just inherent to the Mongo shell because it's based on JavaScript. You would face the exact same behavior when working with Node.js and the Mongo driver there. But for other languages and their drivers, let's say for Python, this will differ. In Python, a value like this would be an integer, and a value like this would be a float. So Python does differentiate, and therefore there, this would be inserted as a double into MongoDB, so will be stored as a normal double in the database. This would be inserted as an int32. And this will be important to understand. Now, I will later in the from shell to driver module show you how to write code with a MongoDB driver in a real application. And it will show you how you can get a feeling for what is supported, which types do I have to convert. But you also always have to know the language you're working in, and you have to know the defaults for this language. Does it differentiate between integers and doubles? If yes, what is the default integer? Is it an int32? And then you will know, do I need to convert it? As we will do it in this module, because for the shell, which is based on JavaScript, we will have to explicitly create an int32, because this is not one, as I just explained. For other languages, this will not be required. And this is just one important thing you have to keep in mind for the language you're working with. The from shell to driver module should make it clearer how you can write code and how you can create, let's say, that 64-bit int in your driver code. So you will learn that later in the course, no worries. I just want to highlight that the default which gets written into MongoDB does not depend on MongoDB, but on the client you're using. In the shell, it's based on JavaScript, so the default is the 64-bit double. So let's play around with that a bit. And let's start with the int32 and why we might want to use that. So let's say we have a collection in our database, the persons collection. And there we insert one person. Now that person might have a name, Max, and might have an age. Now thus far, I always stored the person like this. And now generally there's nothing wrong about that. If I now retrieve my person here by finding it with find one, and I get my collection name right here, I see that the age seems to be stored like this. And that is the case because it's a 64-bit float or double, and therefore here the integer part is actually stored with full precision. Just the decimal part is not. And actually, even though we don't see it here, because in the shell, which is based on JavaScript, it's automatically kind of output as an integer, even though we don't see it here, the decimal places are stored for this number too. And behind the scenes, this will be stored as something like this, something like that. And there will be some imprecision at some point. So this 2 here at the end, which I just came up with, but we'll have something like this in there. We can't see it here, but this is actually how it's stored behind the scenes. And that is fine here. We just use the age. In our app, we would always use it as an integer, let's say, so we don't care about some imprecision here. But it's worth noting that we'll have that imprecision. It's also worth noting that if I now have a look at the stats of my persons collection, I get loads of data here. But if we scroll all the way to the top, we'll see that we have a size of 49. And that size is simply there because we have one entry, and that one entry has a name and has a age. Now, I showed this earlier in the course, but it's really important. Let me quickly delete all entries here in this collection. And let me add a person again with insert 1. And this time, I'll only add the age so that we really only can focus on the number here. So, age 29. If I do that, and I now have a look at the stats again, we scroll all the way to the top, we see a value we saw earlier in the course too, size 35. So this is the size of this one entry in our database. Now, let's use an int 32. And we can use that. First of all, I need to delete all entries. We can use that by using number int as a wrapper around 29. Now, important, you can pass number int like this or in quotation marks. So this is also possible. If I enter my integer like this, and I now have a look at the stats and I scroll all the way to the top, we see it's actually a bit smaller. And that is one reason why it might be worth considering using that integer 32, so this number int constructor here. And important, number int is what we use here in the shell to create such an int 32 value. If you're using a MongoDB driver in your application, you'll have to use a method provided or a type provided by that driver. And it also depends on the programming language you're working in, because you might be working in a programming language which, unlike JavaScript, does not use a 64-bit float as a default value, but let's say which does use a 32-bit integer as a default value. So the documentation of your MongoDB driver is then the way to go to find out how to create that integer there. But you will find it in there easily. And in the from shell to driver module towards the end of the course, I will also dive into some example driver docs and show you how we could create an integer there. And actually, just to show what I mean, here's a quick example from Stack Overflow where you see some dummy code or some demo code on how you would create an int64 in Python with the MongoDB driver. So this is using the official MongoDB driver. And there you see essentially you just import something from the MongoDB driver. So this is part of the MongoDB driver or of the dependencies it ships with. And you have this int64 constructor essentially, which you use to then create a number that is too big for a normal integer. And for int32, we don't really have that here because in Python, integer will by default be stored as an int32 in MongoDB. And that is what I meant. It depends on the programming language you're working and then on the driver. But in general, what I show you here with number int or with number long, as we will then also use it, this will also work in your drivers. It then just simply depends on the language and what the default values there are. Here in the shell, it's based on JavaScript. Therefore, the default is that 64-bit double, and therefore we can force integer value with number int wrapping our value. And we would do this because we save some space. It's a bit smaller, which of course is not too bad. And if we don't need the decimal places, we can of course also simply get rid of them. So in the last lecture, we had a look at the int32. Let's now clear our persons again. And let's now consider an example for a long value. Now, it's a bit hard to come up with such examples because it's such a very big value you have to store. But let's say we're talking about company values. So I have my companies collection. Let me quickly clear the screen to make it easier to read. So I have my companies collection, and there I insert one new company. Again, to keep this simple, I'll focus on the one field which is interesting to us here, and that's the company valuation, let's say. So the company valuation might be a very big number. And if you remember our slide, int32 integers could only be used for values up to 2 billion and something. Now, let's say we have a company which is worth more than that, which is certainly something that you find a lot in today's world. So we want to store such a big value. Now, let me first of all show what will not work. We could, of course, try storing a number int because maybe we forgot the maximum range. And now let's say we have a company which is worth $5 billion. So we need 9 zeros here. And if I hit enter here, this gets stored. Now let me find that company. And what we see is that actually a totally different value was stored here. So valuation is definitely not the value I entered. The reason for that is we don't get an error here, but actually we entered a too big value, and therefore it simply stored a different value because it basically exceeded the range of values we had available, and therefore now we end up with that value. Why do we get that value and not an error? Well, that has to do with how numbers are handled technically by computers, but this is in the end what we get here, a wrong result. Now, just to demonstrate that my range was correct, if I take that maximum value you saw on the slide and I insert that, so let's say our valuation is exactly that biggest value, which is 2147483,647. So if I had that in there and I find all my companies now because I have 2 in there, you see that value is exactly the value I stored. But if I only increase it by 1 digit, so we have an 8 instead of a 7 at the end, and I find all companies, now you see it's a negative value all of a sudden because it basically goes into the negative range here if we exceed our maximum value here. So this is what I'm talking about. This is what I mean. This is what will not work as you might expect if you enter a too big value here. And that is why you have to be aware of the ranges you face. Now, before we have a look at that long value, which will help us, let's also try something else. What if I enter this number, so the number which was too big here, too big by only 1, but still too big, if I enter it like this, so without any special MongoDB type. And therefore, keep in mind, the shell is based on JavaScript, so we enter this as a 64-bit double. If I now have a look at all my companies, we see this was actually stored correctly. And the reason for that is that a 64-bit double has a bigger range than a 32-bit int. So we could use that to store this value. But the 64-bit double will still not have the same range of integers as the 64-bit integer has. And the reason for that is obvious. The 64-bit double doesn't just store integers, it also has to handle decimal places. So it's not like the 64 bits are fully available for integer values. And therefore, if we have a big integer, the best way to really store it, to be guaranteed that we can store the biggest possible numbers that are supported by the int64 range, is that we use the number long wrapper here in the shell. Or, as you saw with the MongoDB Python example in the last lecture, if you're using a driver, which you will of course in the end, check out which programming language you're using, what your default values there are, and then in the driver docs, find out which conversion tools, which types, which wrappers, which constructors you have to create long integers or 64-bit integers and so on. So here we could create the integer like this. Well, we'll face an issue with that, but let's have a look at what got stored. Looks correct, right? Well, let me show you what the issue is if I add more values here. Let's store the biggest possible number we can store in a long value. And that is 9223, whoops, 223. So 9223, 372, 036, 854, 775, 807. Now if I try to store that, I get an error, even though I am in the range of accepted values. So I am in the range of values that are supported. The problem is that this value, which is still a number here, is simply too big because it's a double 64, which then, well, gets wrapped by a number long. So we should wrap this in quotation marks instead, and now it works. And this is really important to understand. Number int and number long can be used with a number passed as a value and with quotation marks. And you should always use quotation marks, so basically pass a string, because MongoDB will then internally kind of convert that string, you could say, or simply store it appropriately. But if you pass a number, well, the number you pass still faces the JavaScript limitations here in the shell, which is based on JavaScript. So this number which I tried to pass originally simply was too big for the shell for JavaScript and therefore couldn't be stored as a number long because we didn't even reach the MongoDB handles it stage. With a string is just a list of characters. It's not treated as a number internally, and therefore it doesn't face the limitations we have with numbers. So we can then store it like this or pass it to number long like this, and then MongoDB can take care about it. We had a look at number int and number long. Now, one obvious question you might have at this point is, especially with that string thing, which I mentioned at the end of the last lecture, why don't we just store all numbers as strings? Let's say we have a accounts collection with bank accounts or something like this. And in there, we could insert one bank account for one person. So for person Max, of course, we don't need that name. And the interesting part here is like what's in there, so amount. And now we could store it as a value like this, but let's say we only have integer values there. Unrealistic, of course, but let's say we only have full numbers. So we could, of course, store it as a number int or number long, depending on how big the number will be. I can tell you number int would suffice for me here, but why don't we just store it as text? If we face no problem here and we can store as big of a number as we want, like this, which is not my actual bank account, but let's say this could be stored. It's a valid text. The text can be as long as you want. So why don't we store it like this? If I now have a look at my bank accounts here, we see that value was, of course, stored exactly because it's just some text. Now let's delete this quickly. And insert this again a bit smaller so that we can see what's going on. Let's just store 10. Now, one reason why storing it as a text is a bad idea is because if I now need to do any calculations with it, it will just fail. So let's say I want to update my account here, and I only have one entry in here, so I don't need to filter and update one. And I do this by incrementing. You learned about the inc operator by incrementing amount by 10. If I hit enter here, we see that we cannot apply inc to a value of non-numeric type. So it essentially fails because amount is a string and not a number. And that is one problem we'll face. If we ever want to do calculations, it will not work with a string. It will work with number int and number long though. So if I clear my account again and I now insert my account, but not my amount, but not as a string, but let's say as number int 10 wrapped in quotation marks, which is the preferred way of passing a value here. If I do that and I repeat my update one operation, now this succeeded. And now there's one important thing. If I now output this, we see it's 20, but now it's not a number int anymore. It's a normal 64-bit float again. The reason for that is that I incremented by such a normal number and not by an int. And therefore, MongoDB automatically converts it to this type of number, so to the float 64. So if I wanted to keep it a number int, I'll quickly delete everything, reinsert my initial 10 bucks into my account, and then update. I would update by also wrapping this with number int. So I would update by passing a number int. And this, as you see, succeeds. So we're not working with strings here. We are working with these special number types provided by MongoDB. And therefore now, if I have a look at this, we see the amount 20. Now, unfortunately, this still looks like a normal 64-bit because it is received or automatically displayed as such by the shell here, but it will actually be stored as a number int behind the scenes because we only work with number ints for both inserting the document and updating it. Now the same does work for longs. If we go back to the companies example, and I first of all delete everything in there so that we can start from scratch, let me then insert one document into companies. Let's say there we have the funding, or not the funding, let's say the valuation, and let's add number long here. Now let's enter a big number, like this, which is too big for int 32, but which is okay as a number long. Let's first of all look into our companies here. So companies, find one. This is the company I entered. The value was stored in there. It was stored in exactly the value I added. By the way, just because I haven't mentioned it yet, but of course you can also store negative numbers. So I'm using positive numbers here, but the same is possible for the same range as you saw on the slide with negative numbers. So I stored this, and now let's update this to show that we again can do calculations, mathematical calculations on number longs too. If I update one document, the only one I have in there, I can do this with the inc operator, and I want to update my valuation by, let's first of all say 100, or let's say only 1, because that will be easier to check. So by 1, it succeeds, but if I find my value, we actually see we got a problem now. The value we get back is incorrect. And the reason for that is simply by changing it by 1, this was converted to a 64-bit float, which can't store a number this big, and therefore simply, well, rounds it in the end. So this is of course not what we wanted. So let's reset this, delete everything, insert our value with the number long, and now update again, but now I'll update with number long, and that will be my value of 1. But now, again, create it as a long number with that special constructor provided by the MongoDB shell. This succeeds, and if I now have a look at my element here, we see this is indeed the correct number now. Previously we had 8, 9 at the end, now it's 9, 0 because we incremented by 1. So this is how we can do math with these number longs and number ints, and that is of course a crucial part of using them. So you can use them. You can also filter by them, by the way. You can use them with greater than filters and sort by them. So they really work like normal numbers, just with the benefits of well, this enhanced range or this bigger range you have available. So we talked a lot about int32 and int64, and these are super important topics. Let me really highlight again that we can sort with these types of numbers, that we can query for them with greater than, and all the things you could do with the normal numbers, these things are possible with number int and number long too, or with int32 and int64, as I should say, because number int and number long are really just the constructors we use in the shell to create these number types. But let's now move towards our high precision double, because that will also be interesting to understand. To understand what it does, let's say we have some database which we use for scientific calculations. So I have my collection science in there, and I insert one new document, and let's say we have two values, A, which is .3, and B, which is .1. And please note, these are the normal numbers as I use them in the shell, and therefore, because the shell is based on JavaScript, these are 64-bit floating point numbers. So they are not these high precision decimals. If I insert this, this will work. If I then find all my elements in there, this looks good, right? The values look the way I stored them. Now keep in mind what I mentioned earlier in this module. Behind the scenes, they will actually be stored with something like this. So there will be more decimal places than you see here, and there will be some imprecision. It's simply approximated to this, and JavaScript, so the shell here, simply outputs it in this approximated value, which of course looks all right here. But we can see the difference if we do a calculation with the help of the aggregate functions of the aggregation framework. Here, I only want to pass one stage, one step in my pipeline, and that is the projection stage. So I will find all elements and project them into something new. And there I will add a new field, and let's name this result, whatever you want. And the value for this field has to be a document, as you learned in the aggregation framework module. And here, I will subtract. I will subtract two values which are passed to this array, and I will subtract A and B. And they have to be referenced with $signs here so that MongoDB will look for these fields. If I hit enter here, you see something strange. The result of A minus B is not 0.2 as you would have expected, but this value. And this shows you the imprecision I'm talking about. These values are not stored exactly. And in some use cases, in a lot of use cases, this might not matter. Even if you're building an online shop with products where you store the price, where you would say, of course, I don't want to lose some fraction of a cent. Even in such a case, you could be fine with these values here, because you might only use that price to display it on your web page, where the approximation will be all right because you don't have that many digits you approximate. You only show 2 decimal places and these will be correct. And even for you, then kind of charging this, you might be fine because you sent this to some third-party service. You send your value as it is returned by the database, so something like this. You send that to the provider, and you then rely on the provider charging exactly that and not some incrementally lower amount. So you might be fine using these values. But if you do calculations with them, if you work with them on the server here, because Aggregate, of course, executes this on the MongoDB server. So if you do something like this, where you extract data, return value from the database, and you end up with a result like this, you might, of course, have a problem, because that is probably not acceptable for your application then. And this is exactly where this high precision double, the 128-bit double, can help you. So let's have a look at that in the next lecture. So let's try this high precision double. And for that, I'll first of all delete that entry I have in my science collection here. And now I'll again insert one document into my science collection. And that one document will be a high precision double, or will be using high precision doubles. So I still have A, but now I will use number decimal, which is the MongoDB shell constructor for this value. Now again, if you're using a driver for Python, for Node, for C++, for Java, you will find help in the driver docs. There you will find the constructor you use to create this 128-bit decimal. In the shell, the constructor is named number decimal. And then again, we use quotation marks to pass the value. You don't have to use them. You could pass something like this, but then you face that issue of imprecision, because that value is not precise. So at the point of time MongoDB tries to store it precisely, it still has the, well, imprecision baked in. So we should pass it as a string. And the same, of course, for B. So there I also have my number decimal, 0.1, stored like this. Now, if we query our database here, we see it's stored as such a decimal, 128-bit decimal in the database. Now let's repeat that aggregation command from before, where we project into that result field by subtracting B from A. If I hit enter here, we see now the result is actually an exact number decimal. So now we indeed have the exact value we need. And just as with long and integer, we can use the number decimal for all kinds of calculations, like subtract here. We could also sort by it. We can increment it in an update operation. You have to be aware, though, just as with the long value, that if you do update, for example, so we update our one value here, and you do that with increment. If you do increment A by .1, let's say, that will work. But if you have a look into your database, you, of course, now face the issue of having an imprecision. It actually did not convert it to a float 64. It kept the 128-bit decimal, but you could introduce imprecision here if you add a float like this, because that float could be unprecise. So a better way for updating is, of course, just as before, to use number decimal in this case and pass that value. And if you do this, you're guaranteed that you don't suddenly introduce some imprecision into your otherwise precise data on the backend. But then, besides that, you can use it in your normal sorting, querying, just like a normal number, but with more precision. Of course, that precision comes at a price. That's also worth noting. If I quickly add a new collection, nums, and I insert one value here, let's say A, which is .1. If I now have a look at the stats of my nums collection with only that one document with that one field in there. We see that is the size that it happens to be stored. And if I now remove that, so I delete many in nums, all elements that are in there, and I now insert a again, but now I use number decimal for this value, then you will see that if I have a look at the stats again, it's actually bigger. So here you see it has a bigger size now because more space is reserved for this high precision decimal. So that is a downsize. So using it for all decimal values might not be optimal, but for cases where you need the high precision, this is your solution, which allows you to do high precision math without losing any precision. Now, one additional resource I want to draw your attention to, which you also find a link to in the last lecture of this module, is this article in the official MongoDB documentation. It talks about how to model monetary data. And that is essentially about the things we talked about in this module. So how you can get that precision you need and so on. There you also find an alternative approach to using that decimal 128-bit value we used in the last lectures, and that is using a scale factor, which is not the recommended method anymore. That is why I showed using the decimal type, because that is preferable now. But this scale factor method is essentially a way of using or working with numbers by multiplying them with the precision you need. So if you need, for example, here in this example, 1/10 of a cent of precision, you could multiply your price value with 1000 to get that precision. So you essentially only work with integers there and never with floating point numbers. And that is an alternative to the 128-bit decimal, though, just to highlight this again, using the decimal is preferable now, but you can of course go for this approach too if you want to. So checking out this article is also worth your time. If you're working with monetary data, you find a bit more information there, but I hope that with this module, it became clearer why we have these different number types, what you use them for, what their limitations and advantages are, and therefore what you could choose in your next application you build. We already covered a lot of important things that you will need to work efficiently with MongoDB. Now, this MongoDB course is built for developers. Therefore, the things we're going to cover in this section are only partly important to you, but, well, they are at least partly important to you. And security always matters. So in this module, we'll take a look at something which is mainly the job of your database administrator and not of you, the developer. But since you will play one important role in the overall picture of security and user authentication, I find it important to guide you through the most important parts that are related to securing a MongoDB database. There is kind of a security checklist, which you also find in the official docs when it comes to hardening your MongoDB environment and making sure that it's safe and can't be intruded from outside. One of the most important things is authentication and authorization. And this is already one of the things where you as a developer come into play, where you will have to worry about. And I will show you how you do authorize and so on throughout this module and also later in the from shell to driver module. So authentication and authorization will be one important part. And this part here, or this topic, mainly means that the database, so I'm not talking about the application you're building, but the database you're using to store data will know users. And you will have to authenticate, so you means you as a developer, so your code, will have to authenticate with that database in order to insert data, get data, or do all kinds of stuff. So authentication and authorization is one super important building block when it comes to securing your MongoDB environment. Another important building block is transport encryption. This means that data that is sent from your app to the server should be encrypted so that no one can sit in the middle and spoof your connection and read that data. Additionally, encryption at rest is an important topic, and that means that the data in the database also should be encrypted. Otherwise, if someone somehow gets access to your database servers, well, they can read plain text information, and that will make getting the data out of there easier. If you do encrypt your data in the database, you are still protected a bit, even if people get access to your database server, because then they might have access, but the data is unreadable. These are three very important building blocks. Additional important building blocks are auditing. We'll not dive into this in this module or in this course, because this is a pure server admin task. But of course, MongoDB does provide features to audit your servers, so to see who did what, which actions occurred. And you can do a lot of stuff there to make sure that you always control what's happening and you always are aware of what's happening in your database. Additionally, the server on which you run your database server, and now I'm talking about the physical machine which is running somewhere, or if you're using a cloud provider like AWS, I'm talking about the instances you booked there. The network you are using to host your MongoDB environment, of course, also should be secured. And now that is also far beyond the scope of this course and far beyond what you as a developer have to do. But if you are administrating and setting up the entire MongoDB environment, this is also something you will have to take care about. And last but not least, backups and software updates also matter. You, and now again, I don't mean you as a developer, but you as the owner of a MongoDB environment, you should regularly back up your data. And of course, you should make sure that all the software you're running is up to date to fix any security holes that might be in there. So these are important things. In this module, we'll have a look at these three blocks, because these three blocks kind of affect your work as a developer. And you will see how they affect your work in this module and later, as I mentioned, in the From Shell to Driver module. So let's dive in and let's start with authentication and authorization and learn what exactly that is and how you use it. So what is authentication and authorization? These are actually two concepts which are closely related. Authentication is all about identifying users in your database. Authorization, on the other hand, is all about identifying what these users may then actually do in the database. So if we want to use a real-world analogy, you could kind of say that you might be employed and therefore you are able to access the office because you got a key card to the office building, let's say. So you are an employee, you are authenticated to access the office. But the things you may do in the office depend on your role. So let's say you are an accountant, and then therefore you might be allowed to access the internal systems to process orders or billings or anything like that. So you describe that you are allowed to access, and then you describe what you are allowed to do. That is authentication and authorization. And MongoDB uses these two concepts to control who is able to connect to the database server and then what these people who are able to connect can do. And when I say people here, that's important. I don't just mean people, I also absolutely mean things like the app you're writing. You as a developer will then write code so that your app can connect automatically to the database server. It's also important to understand that when I talk about users here, I don't mean users of your app. So if you're building a shop, I don't mean the users who can sign up to buy things in your shop. You might manage these users in your database, but with your own logic. But with users here, I mean the users of the MongoDB server. So the people who are allowed to directly interact with it in some way. And that, of course, are not the users of your shop. They may not directly insert documents or read documents or delete a database. This is very important to understand. I'm talking about users who are allowed to connect to the database, not users you might know in your application. Now, before we actually write some commands to actually create users and authenticate, it's important to fully understand the authentication system MongoDB uses. MongoDB employs a role-based access control system, and this works like this. Let's say we have a MongoDB server with 3 databases, and the admin database is one you already saw in previous modules. It's a special database which exists out of the box, and I'll come back to why it's special throughout this module. So let's say we have that admin database. Obviously, we would also have that config and local database we start with, but we also have our own databases here, let's say shop and blog. Now, in the shop database, we have 2 collections, and in the blog database, 2. Now, we enable authentication, and that is something we'll do in the next lectures. Authentication can be enabled in a very easy way, and suddenly our MongoDB server only allows authenticated users to interact with it, with the collections and the documents, and with the overall server. So let's say we have a user, and now here important, again, user here means either a real person, like a data analyst, who directly connects to the database through the shell, so like we are doing it in this course, or you could also talk about an application here, so the user would then kind of be the MongoDB driver or your overall application code using the driver to connect to your database. So this is not the user of your application, not the user of the online shop you're building. It's really your application, or if it's a real person, then we're talking about a person who directly connects like we are doing it in this course. So we got a user who wants to interact with the Mongo database. And we now need to log in with a username and password because authentication was enabled. And MongoDB automatically has a process in place where we then have to enter a username and password. Now that of course means that the user needs to exist on the MongoDB server, otherwise logging in will be impossible. And that is exactly what we will do in the next lectures. We will create such users. So let's say the user exists and we log in. So now suddenly we are logged in as a user. Let's say our app is logged in, or we as a data analyst are logged in. But with that information only, so only with the information that we are logged in, we're not allowed to do anything. Instead, users in MongoDB are not just entities that are made up of a username and a password, but they also are assigned some roles. And these roles are essentially groups of privileges. Now, what's a privilege? A privilege is a combination of a resource and an action. And that sounds very cryptic, but it becomes clear with a concrete example. A resource would be something like the products collection in our shop database, and an action would be an insert command. So actions are essentially the kinds of tasks, the commands we can execute, we can do in our Mongo database. And the resource is on, well, which resource can we execute this command? So for example, this little example here would mean that we can insert documents into the products collection in the shop database. And this now allows us to do something as a logged in user. And as I mentioned, this is a privilege. Typically, you don't just have one privilege, but instead multiple privileges are grouped into so-called roles. And therefore, a user has a role, and that role includes all the privileges, so actions and resources, that make sense for this user. And this is the model MongoDB uses, and we'll see that in action in the next lectures. This is a very flexible model because it allows us to create multiple users where we, as a database owner or administrator, can give every user exactly the rights the user needs. And that's important. We don't want to give every user all the rights, because if someone, let's say the data analyst, has all the rights, this person or this app, it could be an app too, is suddenly able to start deleting databases or insert documents, even though, in the case of the data analyst, we only want this person to be able to read data. And it's not necessarily required that the person wants to do anything bad. This could even happen on accident. So only granting what a person really needs, or what an app, a user in general, really needs, is a common approach, not just in MongoDB, but it exists here too. It makes a lot of sense, and it's therefore the approach we will use in this module too. Now, just to come back to what I ended with in the previous lecture, we use roles because we typically, of course, have more than one type of database user. If we are building an online shop application, even then we have more than one database user. We will probably have some administrator, so a real person who actually needs to be able to manage the database configuration, create other users maybe, create new databases, create new collections, stuff like that. And you could even split that up into different roles. But we might have such a super administrator who does all that heavy lifting. But this administrator will not be required to actually work with the data in the database. The administrator will not be required to insert or fetch data. So this would be one role we typically have. Then we would have the developer, so the app. And I'm putting this into one role because you are the developer, you are a real person, but of course you are writing some code where the code is in the end what will insert or fetch data. So in the end, the app is the user, you could say. And the app, and therefore you as a developer, you need to be able to insert, update, delete, or fetch data. So all these CRUD operations, which is why we heavily focus on these in this course, because this is a developer's course. But you will not need to create users or manage database configuration. This is not your job. And the app code shouldn't be able to do that. Because if someone is able to access this code somehow, suddenly this person can start changing your code and do bad things to your database. So again, we'll focus on that developer part in this course, but for the big picture, it's important that you understand how authentication and roles and security in general work in MongoDB. Now, last but not least, to complete that picture, in that same app we're building, let's say a shop, we might also have a data scientist who analyzes our sales. Now, this real person needs to be able to fetch data, but certainly not to do any database configuration or start editing, inserting, or deleting data. So this is why we have this role-based concept in MongoDB. Now, after all the theory, let's finally start working with some users to get a feeling for how that works, how we can create and edit users, and most importantly, how we can then, well, work as a user. Because right now we always worked with we have all rights mode turned on. Now we will shrink that down to be in a more realistic environment. Users are created by a user with sufficient permissions with the create user command. You then create a user with a username and a password. And as I mentioned, this user will have a couple of roles, or one role. So at least one role. And then each role will typically contain a bunch of privileges. Now, a user is created on a database. So a user is attached to a database. Now, this does not actually limit the access of the user to that database, even though you might think it does. But this is the database against which the user will have to authenticate. The exact rights the user then has depend on the roles you assign to that user. And even if a user authenticates against the shop database, the user might still have the role to work with all databases that exist in your MongoDB environment. And whilst this sounds strange right now, it is something which will become clearer over the next lectures. And there you will understand why we can assign users to different databases if that doesn't lock down their access. Now, of course, we cannot just create users. If we ever need to, we can also update users. Now, keep in mind, update user here basically means that the administrator updates the user. So, of course, you can use that to, for example, change the password, but you should then tell your user too. So, this is how we create and edit users. Now, let's see that in practice. To see that in practice, let's bring up our Mongo server again with the same command we used in the past, but now I will add --off here. And --off simply means that now you need to authenticate in order to work with that database. Previously, we did not have that setting, and that meant that everyone who connects is allowed to do everything. Well, now this ends. Now if we start a server with that, we have a server that will require users to authenticate. Now, with that server up and running, I switched to a new terminal window. And now if I type Mongo, you might have expected that this fails, but actually we're still able to connect here. Because there are two different ways of signing in. You can now either sign in with dboff, this is a command, which takes a username and a password. But of course I haven't created any users yet, so this won't work. Or you can indeed also sign in during the connection process. So now I quit my Mongo process. You can add the -u key here or flag, and then add your username and -p for the password, and then try connecting like this. Now I will show a couple of times throughout the lecture. For now, let's connect to Mongo like this. And there is one problem we'll of course face. Do you know which one it is? The problem we initially face, of course, is that now we connected to a database that requires authentication, and we got no user yet. And indeed, if I type show DBs right now, I see nothing. The same for show collections. I get an error, which basically is a cryptic way of telling me you're not allowed to do that. Now, we got no user, And MongoDB has a special solution for that called the localhost exception. When connecting to your database in this state where you haven't added any users, you are allowed to add one user. And that one user should, of course, be a user who is then allowed to create more users. And to do this, you first of all should switch to the admin database and then run db create user. Now, a user is created by passing a document into this function. The first argument should be user. The value here will be the username, and I will use Max. You can type any name you want. Then, separate by a comma, because it's a new key in that document, you add the pwd, so the password, and that also is a string up to you. Now you also need to add the roles, and for that you add a roles key which holds an array of roles. Now you can add multiple roles in different ways. For now, there's one role you should add, and I'll talk more about the available roles in a second. And the role you should add is the user admin any database role. This is a special built-in role which will grant this user the right to administrate any database in this MongoDB environment. Now, if you hit enter, you should have successfully created that user. Now, if you type show DBs, you will suddenly see a different kind of error. Now, what you will need to do is you now need to authenticate, and you can do this with the auth command. So type max here if that were your credentials or whatever you did use, and hit enter. Make sure you are in the admin database. So use admin first in case you switch to a different database in between. So then you should be authenticated. And now, after being authenticated, you should be able to run show DBs and show collections, but I got none. But I also get no error anymore. So now we created one user, and we created that user with this special role. Now, before we create more users, let's talk about this special role and which built-in roles exist in general. In the last lecture, we created our first user with this special localhost exception, and we assigned a role to the user. Now, we did never create that role. Instead, MongoDB ships with a bunch of built-in roles that basically cover all the typical use cases you have. You can also create your own roles, but that is beyond the scope of this course because this will be a pure admin task. You find a link in the last lecture of this module though, which links you to the official docs where you can learn how to create such roles. It's actually pretty simple. So let's talk about the built-in roles though. We got a bunch of built-in roles in MongoDB. For example, we got typical roles for users of a database. So the people who work with the data in there. And there we got two roles, a read and a read-write role. And these roles are pretty self-explanatory. You either got a role for users who only need to find data, so who can run all these queries, use the aggregation framework, but will not be able to insert or update or delete data, well, or you got full access. You also got typical database admin roles, like the user admin or the DB admin. Now, the DB admin is, for example, a role where people who have that role are able to manage the database, obviously, to create collections. User admin is more geared towards creating and managing users, as the name suggests. Now, these roles will grant the user access to, for example, read-write data, but only inside the database to which you assigned that role. And I will show you how you can assign roles to databases in the next lecture. We also have special roles, of which we used one in the last lecture. All database roles. You can assign all these roles on the left to users for multiple databases. So you could give one user the read role for two different databases. But of course, sometimes you will have a case where you want to give a user rights to do something in all databases and also in all future databases. And you don't want to manually add like the read role to a user for every database manually. And therefore you have these all database roles. So we also have read, read-write, user admin, and DB admin. So all the roles we already saw in the left two boxes here, but now in a special setup that will always give the user access to all databases. And that is why we use the user admin any database role in the last lecture, because we want to have a user who is allowed to create users for any database and in any database, no matter if the database already exists or is created in the future, and so on. Now, besides these roles, we also have cluster administration roles. Now, we haven't talked about clusters at this point. Clusters are essentially constructs where you have multiple MongoDB servers working together. This is used for scaling so that you can actually, well, have multiple machines running MongoDB servers and storing your data, which then work together. And managing these clusters of servers is, of course, a meaningful task. It is performed by people who know what they're doing, and they have their own rights, and you can assign their own rights to let them do their job. You also have special backup and restore roles in case you have some users who are only responsible for that. So these really are roles that just allow you to do that, back up the database or restore it. And then there are super user roles. Now, these are all the roles we saw before, except for root. Now, the idea here is, if you assign the DB owner or the user admin role to the admin database, and I will show you how to assign roles to a database, so to a user and then to a specific database. If you assign them to the admin database, this will kind of be a special case because the admin database is a special database. And these users are then able to create new users and also change their own role. And that's why it's a super user. All these roles here basically allow a user to create new users and change users. So these users can create whatever they need. And therefore, these are very powerful roles. The root role is basically the most powerful role. If you assign this to a user, this user can do everything. So basically, that will then be a user who has the same rights we had previously in this course before we started locking down the database with --off. So these are the built-in roles. Now, you can learn way more about them in the official docs, of course. The quickest way to get there is to just Google for MongoDB built-in roles, and then there is a whole article in the official docs which talks about the official roles, also grouped in different categories as I did it on the slide. And there, you do not only see a description of the role, you also see which actions this role unlocks. Because remember, a role is just a group of privileges. So these are essentially the privileges. So here you see the read role gives you access to the find command, but also to the command to list collections, which you do in the shell with show collections. So you can read through all the roles here and see what people who have that role are actually allowed to do, which is of course a very powerful feature. Now, with that, we know which roles exist. But one thing I could imagine that is still unclear is how exactly you assign a role to a user and you control to which database this role then applies. So let's have a look at this in the next lectures. So back in the shell, where I did create one user already, let's create another user. And please remember, I am logged in with my user we created earlier. Now I will log out or simply quit the Mongo server because I want to show you an alternative way of logging in. And that is that you type Mongo, then -u, then your username, -p and your password. And now don't hit enter because this would actually fail. And the reason for this is this: you create a user in a database part I mentioned. And we created our single user we have right now in the admin database. Now, we need to specify which database we did create a user in. And we can do this with the help of, let's see, with --help, with this command, with the authentication database here. So we need to add this command. So let's repeat this. I have -umax, -pmax, and then --authentication database, and now it's admin. And now if you hit enter, this should succeed, and you are now already logged in, so you don't need to run dbauth again. So now this is another way of authenticating, and the authentication database part here is really important. Now we want to create more users, and I will first of all switch to the shop database and create a new user on this shop database with create user, then pass a document, define a username, I'll name it appdev, define a password with pwd, and I'll name that dev. Of course, these values are totally up to you. And then add roles. And you can add multiple roles. I'll only add one, and that will be read write. Now, please note I'm in the shop database because I switched to it. Now, if I hit enter, this works, and I have a new user. We can now authenticate into that user with dbauth. Appdev is the username, and dev is the password. If I hit enter, the one signals that this works, And now let's try working with a collection. So here in the products collection, let's try to insert one element with the name of book. If I hit enter, I get an error that too many users are authenticated, because actually I did authenticate into my new user, but I was still authenticated in my old user. Now to mitigate this, we should have run logout before switching the user. Now one of the quickest ways to fix this is simply to quit the Mongo shell and then restart the Mongo shell. Now important though, I want to log in with a different user right from the start, and I can do this by of course switching my username here, appdev, and also here the password. And now the authentication database also has to change because we created the new user on the shop. So I have to authenticate against shop. If I would try admin here, it would actually fail. Against shop, it will succeed. So now in there, let's try accessing our products and insert one new product with name a book. If I hit enter, I get an error. And do you know why? Well, I'm in the wrong database. I did not switch to my shop database first. So we need to use the shop first before we try this command. And now it will actually work, as you can see. So this is important. The read-write role was assigned to this user, but since the user is part or was created on the shop database, the read-write role by default also only gave us a read-write access to that shop database. Now this is one thing that assigning a user to a database does to you out of the box. Any role you assign just like that to the user is then scoped to that database, except for these any database roles you saw on the previous slides. And this of course gives us as an administrator a lot of flexibility. We can really create users who are assigned to the databases they need to work with, and we can assign them the roles they need so that the users have to log in against the databases they should work with, and they only have the role to work with that database then. And this is often exactly what you want. And the users don't even know the other databases even. And in a big corporation with a lot of databases, this is typically the setup you want to have. Now, of course, you can still have the scenario that a user needs to be able to work with two databases and not just the one he authenticates against. And let's see how we can do this in the next lecture. So we want to change our user's roles here a bit, because right now our user here, appdev, is only able to read and write in the shop database. And that is generally all right. But let's say we have another database, and that would be a blog that belongs to the shop. So it's also part of our shop application that we have a blog where we post about the latest new products. And the same kind of app, and therefore the same developer, should be able to work with that. How do we do that? Well, we can update a user with the db update user command. Now, the db update user command takes as a first argument the name of the user you want to update. So appdev in my example. And then the second argument is the document where you describe the change to the user. Now, this does not work like the update on the database with set or so, but instead you now have a couple of key value pairs you can set. And the full details can be found in the official docs, of course. A link, as always, can be found in the last lecture of this module. So what you can do here is you can, for example, change the password if you want to, but I don't want to. So what I will do here is I will simply assign new roles. And now these roles will not be added to the old roles, but will replace them. That's important. So of course I can add read-write again to give that user the read-write access to the database he's in. But I want to do more than that. I also want to give the user read-write access to the blog database. And to do that, I add a second element to my roles array, and that will be a document. Because if I just add a string like this, it will always just give the user read-write access to the database the user was registered in. Now, if I want to give access to a different database, I can do that by adding a document where I set the role to read-write. I could also use a different role, of course, but I want to give read-write access here. And then I set the DB explicitly. And there, I could set this to blog. Now, what do you think will happen if I hit enter? Well, let's try out. We actually get an error that we are not authorized on shop to execute this command. And the reason, of course, is that I'm still logged in with AppDev, and AppDev is allowed to read-write data, but not to change users. So what I actually need to do is I need to log out and switch to the other user, the first user we created. We can do this with dboff, and their username and password was Max, but this will fail in the shop database because we created that user in the admin database. So we need to switch to the admin database, and then we can sign into this user. And this now succeeded. And now we can repeat that update command, and I will just copy it from up there. It fails because now we are not finding that user in the admin database, because remember, that user exists on the shop database. So let's actually quickly switch to shop and then execute this again. And now this should have worked. And we can check this with the get user command and get our appdev user. And we actually see the roles here. And we see that now this user has still read-write on the shop, but also read-write on the blog. Now with this added, we can log out again. So now we're logged out of our Max user who is allowed to create and edit users. And we can switch to shop where we have our other user. And now authenticate with appdev and dev. Now with this, we can switch to blog, and we should be able to go to the post collection and insert one new post here with the title of "This Works." If I hit enter, I seem to have messed up with logging out and logging back in. So what I will quickly do is I will just restart my Mongo shell with appdev dev against shop. And after this succeeded, I'll use my blog database and retry my insert command, and now this works. So now we can insert a post into the blog database even though the user exists on the shop database, because we assigned two roles, actually the same role, but to different databases. Now this is certainly something you have to grasp, but it's actually not that complex. The database does not per se lock down the access the user has, the roles do. But if you assign a role to a user, by default, it is assigned to that user for the database the user was registered in. But as I showed in this lecture, you can change that or extend that to other databases too if you explicitly specify the database a role should apply to. And this gives you, as an administrator or as a user administrator, a lot of power and a lot of flexibility, of course. So we had a detailed look at how we can create and manage users and how users are generally set up and how we work with them. As a developer, we don't have to worry too much about this whole creation process, but it's still nice to know how this works behind the scenes, which is why it was important to me to show this to you. So now that our database is locked down, let's make sure that data that is transferred from our app to the database also is secure. Because this is a typical setup we will have when creating an application that uses MongoDB in the backend. We have our application, and this could be a Node or PHP, Python, C++, whatever it is application, that uses the MongoDB driver to then communicate to the MongoDB server and store data. And of course, it's important that the data is encrypted whilst it is in transport, so that someone who's spoofing our connection cannot read our data. And MongoDB has everything we need for that built in. So let me now show you how you can easily secure your data whilst it's on its way from client to server. To encrypt our data in transport, MongoDB uses SSL, or actually TLS, which is the successor of SSL. But I'll just say SSL here, I mean the same though. So SSL is the more common thing you know. And SSL, in the end, is just a way of encrypting our data whilst it's on its way, and we'll use a public-private key pair to decrypt this information on the server and to prove that we as a client are who we will make the server think we are. So essentially, it's a secure way of encrypting our data and decrypting it on the server. And whilst it's on its way, it's consistently encrypted. Now, if you want to learn more about SSL and how it works, you'll find a link with detailed instructions in the last lecture of this module. I will not focus on the underlying technology, but how we can make it work. Now, if you Google for MongoDB SSL, you'll find an article that also describes the steps you need to take. And I'm simply showing you this because we will need a command from there, which we execute together. This is essentially a command that will create us the files we need to enable SSL encryption. So basically this public-private key pair. And we can just copy that. And on Linux and Mac, you can just run this command in the terminal. On Windows, this will not work. But the good thing is, on Windows, if you Google for Windows OpenSSL, you will find that binaries OpenSSL wiki link. And there, you will find OpenSSL implementations for Windows. Now you can take the top one here, and you should be forwarded to this page. And there, if you scroll to the bottom, you should find download links. And here for this Win64 OpenSSL Lite version, you can just download the executable, and then once it is downloaded, just execute that to install OpenSSL on Windows. This will then ask you for a folder where it should install it. And once you did install it into that folder, you can navigate into that folder in your command prompt on Windows, into the bin folder of that installed folder. And from in there, you will be able to run the same command as I do here on Mac and Linux. So on Mac and Linux, we can simply paste in this command, and again, you paste that exact same command on Windows then after you navigated into that bin folder and hit enter. And now you will be asked a couple of questions. Now, the first questions are not that important, and you could enter a dot and hit enter, but you can also fill them out with your right information. But the information here doesn't really matter. You could fill in anything. Now, the important part is that common name here. And there, you must fill in localhost during development, so whilst we are running this on localhost. If you were to deploy your Mongo database onto a server in the web, you need to fill in the address of that web server. And that will be important, otherwise the connection will fail. Because this will later be validated that if you are connecting to a server, that the server you are connecting to is the server that is mentioned in your certificate. So we will be connecting to localhost, so we need to put localhost in here. So hit enter then. You can enter any email address there. And now you're done. And you'll now have two files, the MongoDB cert key file and the MongoDB cert.crt file. We now need to concatenate these two into one file. And that is also a step you find described in the official docs. On Mac and Linux, you can execute this command. On Windows, it's almost the same, but you replace cat with type there. The rest is the same. So you just replace cat with type on Windows. On Mac and Linux, it's cat. So after this, you'll have a mongodb.pem file. And that is the file you will need to enable SSL encryption. Now, how does that work? In that folder where you stored that PEM file, and of course you can now copy and move it around in your file system, but in that folder where that file lives, you can now start your MongoDB server with SSL enabled. Let's quickly check the options with --help to see how that works. You see a bunch of SSL options here. One option we need to set is the mode. The SSL mode defines whether SSL is disabled, so we connect as before. If we want to allow clients to connect via SSL, but they could still connect without SSL. If we want to prefer this, which is only important if you are using replica sets, or if we want to require this, which means any connection that does not use SSL will be denied. And that is actually what I want to use. So we will need to set SSL mode to require SSL. We will then also need to point at our PEM file with the SSL PEM key file argument. Now, theoretically, you could even create such a certificate or such a PEM file with a password, which you then also would have to enter. And this is important, you could also have a CA file, a certificate authority file. Now, you will get this if you get your SSL certificate through an official authority. You can get those on the internet, free ones and paid ones. And this is actually a file which you pass in addition to your PEM file. We have that PEM file, but we have no CA file right now. That CA file would then be an extra layer of security that basically ensures that man-in-the-middle attacks can be prevented. So if you do deploy your MongoDB database in production, you would get your SSL certificate from a certificate authority, and they would give you a PEM file and a CA file, and you would basically add both arguments and point at the respective files when launching your server. Now, in our case here, we will just launch the server, MongoDB, with SSL mode set to, if we scroll up, require SSL. So require SSL. And then I'll add my SSL PEM key file. And now I need to point at my MongoDB.pem file. And for that, you should navigate into that folder where that file lies or specify the full path to that file. If you now hit enter, and on Mac, you might also need to add sudo as before. If you now hit enter, it should start your server. You see a warning that we have no SSL certificate validation in place because we are missing that SSL CA file I just talked about. But besides that, we got a server which is now waiting for connections on port 27017 SSL. So now to connect to the server, we should navigate in a new terminal window into that same folder where we have that PEM file. And now we'll launch our Mongo client. But launching it like this will fail. And if it succeeds, you connect it to a different MongoDB instance, which you can shut down with db shutdown server, of course, which you saw earlier in the course. But for me, it fails here because indeed I got no MongoDB server running, which would allow connections from non-SSL clients. Now let's check out the help options for the Mongo client to see what we can do with SSL there. And indeed here we need to set two things. We need to enable SSL, and we will need to pass our PEM file as a SSL CA file here. So I simply type mongo --SSL followed by --SSL CA file. And that CA file is my MongoDB PEM file. Now this might actually fail. And for this case you need to add --host localhost. So that host you specified during your certificate creation. With that, it should succeed. Now, you needed to specify that because otherwise it tried to connect to the IP address 127.0.0.1, which is localhost, but technically is a different word. It therefore was not considered equal to localhost. So with specifying --host localhost, we made it really clear that this is the host we expect to see as a name on the backend. This is the host which was part of our certificate, and therefore this works. Now, obviously, you can have more elaborate setups, and of course you should mean a non-self-signed certificate, but one you got from an authority for production use cases. But this will do for now, and this shows you how you can generally connect with SSL turned on. And now all data we send from the client, so from the Mongo shell to the Mongo server, will be encrypted. Now that we did add encryption during transportation, let's talk about encryption at rest. What is that? Well, encryption at rest simply means that the data we store, so the data which is stored on our MongoDB server in a file, that this of course might also be encrypted. So all the documents we have in there. And there we can encrypt two different things. We can encrypt the overall storage, so the files themselves. And this is a feature which is built into MongoDB for Enterprise. There you can easily enable it, and you find instructions on how to enable it in the last lecture of this module. The thing you as a developer can and should always do is that you encrypt at least certain values in your code. So for example, if you're storing a user password, you should hash that password and not store the plain text. And that is a good pattern for any sensible data. You could even go so far to do it for all data, so that you always have a way of encrypting that. So you can encrypt and hash both your data as well as the overall file to have most security possible. Again, the file encryption is built into MongoDB for Enterprise and can be found in a separate article. That hashing of a password is something you'll see in the From Shell to Driver module of this course. That's it for this module. Now, in this module, we talked about security. And obviously, security is more than what I talked about in this module. But this course is also for you as a developer. And therefore, I want to touch on the things that are important for you to understand as a developer. Other things are important for database administrators. And these things go beyond the scope of MongoDB even. Securing something like the network itself is something where MongoDB can't really help you. Now, for MongoDB developers, it's important to understand that you work with users and roles in MongoDB. And I can't stress this enough, that users here does not mean the users, the customers of your application, but instead it means the application itself, or data scientists, or the database administrators. So the different users or parties that do interact directly with your database. And there, MongoDB uses a role-based access control approach to control who's able to do what. You create users on databases, and you can then log in with your credentials as a user against those databases. And you can use the admin database for generally global users, you could say, or you can even say this user should log in against the shop database to make it really clear that this user is meant to mostly work or only work with the shop database. And talking about that, users by default have no rights to do anything. You need to add roles to allow certain operations. And the permissions that are granted by those roles, also called privileges, are only granted for the database the user was added to unless, and you saw that in this module too, unless you explicitly grant access to other databases with this more verbose approach of describing a role, where you had the role name and the database to which it applies. Then a user that was added to a database can even work on a different database. You can also use these any database roles you saw for cross-database access, which you typically do for your global user manager or anything like that. Now, we also had a brief look at encryption, and there we can encrypt both data during transportation, so whilst it's on its way over the wire, and at rest. During transportation, we use TLS SSL to encrypt that data with the help of that SSL certificate. And for production, you should not use a self-signed certificate as we did in this module, but you should get one, buy one most likely, from a SSL certificate authority, and then use that along with that CA file you get to lock down your server and connect to it safely. Now, for encryption at rest, you can encrypt both the files that hold your data, and that is made simple with MongoDB Enterprise, and the values inside your documents. This is also possible. So you can encrypt both. The values inside your document is something you have to do on your own as a developer, and we will see that in the From Shell to Driver module of this course. The other part is something you can easily add with the MongoDB Enterprise Edition, and again, as I mentioned, you find a link to that in the last lecture of this module. So with that, I hope you feel a bit more secure now. You learned a lot about MongoDB and how to use it as a developer. Now it's time to talk a bit about the things that are not directly your job as a developer, but still important for you to understand, and especially important to you if you're working alone on a project. You need to understand what impacts performance of your MongoDB server or your MongoDB solution, how you can improve the fault tolerancy of it, and how you can deploy your local MongoDB database and server, which we used thus far in this course, into the web. So on a cloud machine or on a server in the web and not on your local host, of course, because your web application, your mobile application, or whatever you're building will most likely also run, well, on some server or on some smart device, whatever it is, and will communicate to your server in the web and not to your local machine you're developing on. So what's inside this module? We'll have a look at some factors that influence performance, some important factors, and how you can control them or what you have to know about them. We'll have a look at a special kind of collection, capped collections, that can be helpful in certain situations and that you should at least be aware of. We'll then have a look at replica sets, and I will explain what this is. And we'll have a look at sharding. I'll also explain what this is. These two things will be related to both performance and fault tolerancy. And last but not least, I will talk about what it takes to deploy a local MongoDB database and server into the web and which solutions I would recommend there to get your MongoDB solution up and running in the web. So with that, let's dive in. So what influences performance? On one hand, there are things which you directly or indirectly control as a developer. You should write efficient queries or operations in general, so inserting, finding, and so on. All of that should be done in a careful way, that you only retrieve data you need, that you insert data in the right format with the right write concerns, and so on. You should use indexes, and either you have access to the database and you can create them on your own, or you need to communicate with your database admin so that you can ensure that for the queries your application does, you got the right indexes to support these queries to run efficiently. Of course, a fitting data schema also is important. If you always need to transform your data, either on the client side or when fetching it through the aggregation framework, for example, if you need to do a lot of transformation for common queries there, then your data format as it is stored in your collections might not be optimal. And you should, of course, try to reach a data schema in your database that fits your application or your use case needs. So this is a block of factors which you can influence as a developer and as a database admin. Now, this course is for developers, of course, but still you should be aware of these things and talk to your admin for things like the indexes or for the data schema to make sure that you and your admin, work together to deliver the best possible application. Now, there also is another part of performance, and that is mainly the part I'll talk about in this module. The hardware and network on which you deploy your MongoDB server and database matters. Sharding is an important concept, and so are replica sets. Now, I will explain what sharding and replica sets are in this module. They're basically about distributing data and the workload or the incoming requests, but again, I will explain them in detail. And these tasks here on the right, the orange tasks, are not really tasks you as a developer need to be involved in too much. They are typical admin and system admin tasks. So we'll not dive too deep into that because these are very complex matters and complex matters for separate courses on administrating servers and databases if you want to. And not really something you as a developer have to do. Still something you have to understand the big picture of MongoDB and what it's all about. So with that, let's dive into capped collections first, which is a little bit more on the purple side of this slide. But thereafter, I'll explain what sharding is, what replica sets are, and how you can efficiently deploy your MongoDB solution into the web. Back I am in the shell, still connected to my locally running MongoDB process. Now, I want to introduce you to capped collections and explain what capped collections are. Capped collections are a special type of collection which you have to create explicitly, where you limit the amount of data or documents that can be stored in there. And old documents will simply be deleted when, this size is exceeded. So it's basically a store where oldest data is automatically deleted when new data comes in. This can be efficient for high throughput application logs, where you only need the most recent logs, or as a caching service, where you cache some data, and if the data then was deleted because it hasn't been used in a while, then you're fine with that and you can just re-add it. To create such a collection, first of all, you need to use a database, of course. I'll use a new database, performance, and then you create it with the create collection command. We saw that when we added validation earlier in the course. Now, first of all, you define a name, and I'll just name it capped, but of course, the name is totally up to you. This collection can be anything. Can also be users, whatever you like. So I'll name it capped. The important part here are now the options. So the document you pass as a second argument to create collection. Here, the option you want to set is capped to true. And this will turn this into a capped collection. Now, by default, it will have a size limit of 4 bytes. But you can set size to any other value, and it will then automatically be turned into a multiple of 256 bytes. So you could, for example, set this to 10,000 bytes. It will be converted a bit, and that would be your size. And you can also add a max key. The size is required, max is optional. And max allows you to also define the amount of data that can be stored in there, measured in documents. So I could cap this to 3 documents at most. With that, I hit enter and I get this collection. And now I can access capped as a collection. And in that capped collection, we can now, of course, insert a document, just as before. We can insert a document, name max. This worked. I can now also add menu, and this worked. And I can also add Anna, and this worked. Now I have 3 documents in there, which is our max size. I can now, of course, also find my documents like this, and I get back max, menu, and Anna. The important thing is, for a capped collection, the order in which we retrieve the documents is always the order in which they were inserted. For a normal collection, that may be the case, but it's not guaranteed. So for a normal collection, you always need to sort if you want to sort, for example, by ID. You can do that, and then you'll sort by that index. But by default, in a capped collection, you always get the insertion order. If you want to change the order and sort in reverse, there is a special key you can use, and that is $natural, the natural order by which it is sorted, and then, for example, use -1, and then it's sorted the other way around. Just as a little side note, this is important to understand or to keep in mind. You also can create indexes in there, and you got an index on ID by default, but of course you don't have to. Now, with that, I found my documents. Now let's insert another document. Let's insert Maria. And keep in mind that our size limit was 3. Now, if I insert Maria, I don't get an error, because the idea of a capped collection is not that it gives me an error when I insert too many documents, but that it clears the oldest document, which in my case should be max, because that was the first document I added. So if I now output all entries again, indeed, we see max is gone. There's only menu, Anna, and Maria. So this is a capped collection, and there are some use cases where this can be a good idea. Why would you use a capped collection instead of a normal collection then? Well, because of the automatic clear up. You can keep this collection fairly small and therefore efficient to work with, and you don't have to worry about manually deleting old data. So for use cases where you need to get rid of old data anyways with new data coming in, or where you need high throughput and it's okay if you lose old data at some point, like for caching, then the capped collection is something you should keep in mind as a tool to improve performance. Obviously, this is not a solution for storing anything like products or users or blog posts. That would be horrible because you would simply lose some users, some products, or some blog posts. Now with capped collections out of the way, let's turn towards replica sets. Replica sets are something you would create and manage as a database or system administrator. But what are replica sets? Let's say we have our client, either the Mongo shell we're using or some native driver for Node, PHP, C++, whatever it is. Now we want to write some data to our database, and hence we send our write, our insert operation to the MongoDB server, which in the end talks to the primary node, you could say. Now, important is, a node here simply is a MongoDB server. So what we used thus far with this MongoD command gave us a node, the only node we had. So the MongoDB server is technically attached to that node. But it's a bit easier to understand it like this, I believe. So we have that primary node, and that is basically the setup we used for this entire course. We have our server, which is one node. Now you can add more nodes, so-called secondary nodes. So these are additional database servers, you could say, you start up, which are all tied together though in a so-called replica set. Now the idea here is that you always communicate with your primary node automatically. You don't need to do that manually. This happens automatically. If you send the insert command to your connected Mongo server, it will automatically talk to the primary node. But behind the scenes, the primary node will asynchronously replicate the data on the secondary nodes. And asynchronously simply means that if you insert data, it's not immediately written to the secondary nodes, but relatively soon. So you have this replication of data. Now, why do we replicate data? Well, we do replicate data so that in this setup here, that if we read data and for some reason our primary node should be offline, that we can reach out to a secondary node that will be then the elected new primary node. The secondary nodes in a replica set hold a so-called election when the primary node goes down to elect and select a new primary node. And then we talk to that new primary node until our entire replica set is restored. So we get some fault tolerance here, because even if one of our servers, you could say, goes down, we can talk to another instance, another node in that server network, in that cluster, so to say, to still read data. And as a new primary, we can then also not just read, but also write data. So this is why we use replica sets. We have the backup and fault tolerancy, and we get better read performance as well. And that is something I haven't talked about yet. We talked about the backup of data and therefore the possibility to read data and also then to write to a new primary. Well, if we have this setup, this is of course fine if the primary node is online, but even if it does not go offline, you can configure everything such that your backend will automatically distribute incoming read requests across all nodes. And now we're talking just about read requests. The writes will always go to the primary node, but read requests can be, if the server is configured appropriately, and that is a task of your system or database admin, and that the reads can also talk to secondary nodes. And the idea here is of course clear. You want to ensure that you can read your data as fast as possible. And if you have an application where you have thousands of read requests per second, then it is awesome if you can read not just from one node, which is still one computer who has to handle all of that, but if you can read from multiple computers, and therefore you kind of split the load evenly. So that's the idea behind replica sets. We get the backup, the fault tolerancy, and we can even use the nodes in the replica set for improved read performance. Now, how do you create such a replica set? Again, this is a administrative task. We'll not go through that in this course since it's, well, a bit more advanced, not really something you'll have to worry about as a developer. But when we deploy a MongoDB solution, I will also show you a way of easily getting such a replica set up and running. So there I will cover that too. Now we talked about replica sets. Now let's talk about sharding. Sometimes the two things are, kind of confused with each other. They are actually different things. Sharding is all about horizontal scaling. Now, a quick word about scaling. If you have a MongoDB server, here it is, and with that, I really mean a computer which runs your MongoDB server and where your database files are then stored on. If you have that server and you need more power because your application started and everything's going good and you got more requests coming in, you got more users, you got more read and write operations, what can you do? Well, you can upgrade your server. You can buy more CPU, more memory, and put that into the server. And if you use a cloud provider, you can typically upgrade this with a single click. Now, that is of course a solution, but it only gets you so far because at some point you can't squeeze more CPU and more memory into a single machine. And at that point, you need horizontal scaling, which means you need more servers. The issue here, of course, is this might sound logical, but these servers now don't duplicate the data. They are not backups. They split the data. So server A, the one on the left, let's say, stores data for the same application as the other servers, but a different chunk of it. And that is really important to understand. With sharding, you have multiple computers who all run MongoDB servers, but these servers don't work standalone, but work together and split up the available data. So the data is distributed across your shards, not replicated. And queries, so queries where you find data, but also insert, update, and delete operations, therefore have to be run against all servers or the write server, because each chunk manages its data and its range of the data. Yeah, you can kind of say if you would store alphabetical data, then the first server would store A to F, the next server would store F to L, and so on. So you could split it like this, and therefore the operations have to be forwarded to the right servers. Now, how does this work? Well, if you got your different MongoDB instances, so your different servers, your different shards, and each shard here, by the way, can and will typically be a replica set. That's also important. So you have multiple replica sets because each shard is also a replica set. It's this set of nodes. So if you have these servers and you have your client, you then have a new middleman, which we haven't used in this course. Mongoose is then the executable, and that's the router MongoDB offers. This router is responsible for forwarding your operations, inserts, reads, and so on, to the right shards. So the router has to find out which shard is responsible for the data you're inserting, so where this should be stored, and which shard will hold the data you want to retrieve. For this splitting, you'll use a so-called shard key. Now, a shard key is essentially just a field that's added to every document, which kind of is important for the server to understand where this document belongs to. Now, this shard key configuration is actually something which is not trivial, because you want to ensure that you have a shard key that is evenly distributed. You can assign your own values here. You could say the shard key is the name of my user, but then you should ensure that your usernames are roughly evenly distributed and not are all clunked at, let's say, names starting with A, and then you got no names starting with M, N, O, P, Q, R, S, and so on, because then you would put them all on one server, which is not great. So choosing the shard key wisely is important, and also something where you can read a lot in the official docs, which is a job of your admin. But this is then an important part of Mongo's, of the router, finding out where an operation should go. So which server is responsible for storing the incoming data and so on. Now, how does querying work with sharding then? You got all your shards, and then let's say you're issuing a find query on your client. Now that reaches Mongo's, that server, and now there are two options. The first option is that your find did not specify a value for the shard key. Maybe you're looking for a user named Max, but your shard key is some other value, so not the name. Well, then in your find filter, there's no information about the shard key, and Mongo's can't know which shard is responsible for handling this find request. Mongo's does not know which shard contains your data. In such a case, Mongo's has to broadcast your request to all shards, and then each shard has to check, am I responsible? Do I have that data? And then each shard returns its response, which is either the data or no data, and then Mongo's has to merge all that data together and return it. Option 2 is that your find does contain the shard key. Let's say now your shard key is the username and you are searching for the username in your find filter. And then Mongo's can directly forward this to the right shard and fetch the data from there, which is of course more efficient. And that is the part that then matters for you as a developer again. If you know you're using sharding, you should sit together with your administrator and choose a wise shard key based on your application needs that is evenly distributed, so that you can write queries that use that shard key as often as possible. This is sharding. It's all about distributing data across servers and then setting up everything such that it can be queried and used efficiently. Now, setting up sharding is also an advanced topic, and that is then a task you'll not have to worry about. Still, just as with replica sets, when we dive into deploying a MongoDB server, I will show you a solution that allows you to easily add sharding. Now, I talked a lot about replica sets sharding, and that we'll see something about that when we deploy our MongoDB server. Now it's finally time to do this. We want to get our localhost MongoDB instance into the web. So we want to get it on a server that we can reach from anywhere and not only from, well, inside our computer. Now, deploying a MongoDB server is a complex task. It's definitely more complex than just deploying a website, because you need to do a lot of things, a lot of configuration. You need to manage shards if you want to have sharding. You need to manage your replica sets. You have to set up user authentication. And with that, I mean authentication to the database, not users your application, your website might be using. You need to protect the web server and the network, which is now totally unrelated to MongoDB, but a general web hosting task. You need to ensure that software stays up to date, general server software, but also, of course, all the MongoDB related software, that security patches are applied. You want to set up regular backups for your data. You might have replica sets, and still backing up data to a disk might be an additional good idea in case that everything goes down. And you also want to worry about encryption, both during transportation and at rest. So there are a lot of complex tasks that you have to manage when deploying this. And I'll be very honest with you, this is beyond the scope of most developers and beyond my scope too. I'm not a system administrator. Therefore, in this module, I'll show you a managed solution. MongoDB Atlas is a service provided by MongoDB, by the company behind MongoDB, that gives you a scalable and best practice MongoDB server running in the cloud, which you can configure through a convenient interface and which you can scale up, scale down. There is a free tier available, so you can start for free even, and it gives you all these things I mentioned on the last slide automatically. So it does all of that for you so that you don't have to worry about that. So let's now take a look at MongoDB Atlas and let's see how we can deploy a MongoDB server there and how we then can connect to it. Now, if you visit mongodb.com, there is a chance you automatically see MongoDB Atlas there on the front page, and then you can just click on Get Started Free. If you don't see it, you can click on Solutions and then there choose MongoDB Atlas. And if you are on that page, you should at least have a Get Started Free button. Now, if you click on that button, you are required to sign up. And as you see, there is no credit card required. So you can absolutely start for free without any danger of getting charged. So make sure you do sign up here. I already do have an account, so I'll just sign in. And once you are signed in, you should end up on a page like this, or maybe you have to create a project first. So simply fill out the project details, give it a name, and then you should end up on this clusters page here. Now, clusters simply describe a MongoDB environment. A cluster contains all your shards, all your replica sets. It's basically what you deploy. It's your deployed MongoDB server. So here on the clusters page, I can click Build a New Cluster. And this is the page where you can now configure your MongoDB environment as it will be deployed for you. Now let me walk you through that page. The things you see here might change slightly, but in general, you have a global cluster configuration, which is not available for free. You actually have to choose the M30 tier, to which I'll come back once we dive into the tiers, which is a bit more expensive. But there, what you can efficiently do is you can choose different parts on the world where you want to deploy different clusters or shards, you could say, that then talk to each other, which is not a trivial setup, but you can do it with a couple of clicks. The idea, of course, is, you can also choose from a couple of templates here, that your data is distributed across the world so that your users have the shortest way to the data possible. So that if a user in Europe requests something from your app, you can reach out and will automatically reach out to the closest MongoDB server in Europe. And if the user sits in the US, well, then the US MongoDB distribution is used. And this happens automatically then. So this is something you can enable, but not something I will enable here. As a next step, you have to choose the underlying cloud provider. Now, you don't have to sign up with these cloud providers, but MongoDB, the company, does not host its own data centers. Instead, the MongoDB solution you configure here will be deployed in data centers of one of these three providers here. Now, I'll stick to AWS, and there you can then choose the region where you want to deploy, in case you're not using that global cluster configuration. Now, make sure to choose a region where free tier available is added, so that you can get started for free. But of course, if you're willing to pay, you can choose from all these regions and from the different providers too. The next important thing is the cluster tier. This defines the power you have and what you can do. Now, for the free tier, you have to choose the M0 instance. And you can follow along with that. I will choose a slightly different instance because I want to configure something else which is not available for free, but which you also don't need to do as part of this course. So you can absolutely continue for free. I will choose the M10 instance here because that allows me to show you something else. So I'll take the paid one, and I added a credit card. you should of course use the free one. Now you can see how these different instances differ, or how the tiers differ, I should say. You get more power basically the more you pay, and you got solutions for basically any kind of application you could build. And this will only be one server. Now I'll come back to how you can add sharding in a second. You can also customize the available storage, so how much data can be stored overall in gigabytes, and well, you can use that slider to change it. You can also check that to automatically expand the storage before you exceed it. And now under additional settings, you can choose the version you want to use. And if you're using the free tier, you can't choose that. I want to show you something in the next module which requires version 4, and therefore I chose the paid version. You don't have to do this on your own in the next section though. You can follow along by watching my videos, so you can go with the older version for now and not follow along. I will need 4.0 or higher, so I chose the paid solution, and now I can switch to that version of MongoDB. Wired Tiger is the storage engine, and you see only that is available, and that's also a pretty good storage engine. You can also configure backups, and there you got the choice between two types of backup. Continuous means that, well, your data is basically backed up all the time. Whenever you write something and so on, you got a continuous backup history. So it's not once every 24 hours. Basically, you can always back up to almost the latest state you were in. The alternative is a snapshot approach, where you do have a 24-hour period. So you have the danger of losing data for the last 24 hours, or for the last 23 hours if the last backup is that long ago. So I'll go with continuous, but of course you can choose either of the two. That is also only available when you pay, I guess. Yeah, you can't set up a backup otherwise, so I will go with paid. But of course, if you deploy a production solution, you will probably also pay, so that should be fine. And then you can set up sharding. Okay, for sharding, I need an even bigger instance, so I'll quickly switch to that, and 30, so I can show it to you for now. You can set up sharding, and then you can choose how many shards do you want. And that is how you then add even more power besides the tier you chose here. Now, I don't need sharding here, so I'll go back to M10 for now. You can also add a couple of other options, like encryption at rest, which is pretty self-explanatory here. You should check the official docs in case you want to enable those, so that you get everything right. The additional options is something you can pretty much ignore. You could say that you want to only allow index queries that run against queried data. You should know what you're doing here, because again, creating too many indexes is not a good idea. You can enforce the index key limit so that your index keys can't get too long, and the default is that this is turned on. And last but not least, you assign a cluster name. And then with all these things configured, you can click Create Cluster. And now MongoDB will deploy this solution into the web, so onto a couple of servers. And this will take a couple of minutes, but thereafter you'll have a fully functional MongoDB environment running in the cloud, automatically secured, automatically configured according to best practices. It automatically also will be a replica set here, as you see. You automatically get a free nodes replica set here. So this is already included. You could add sharding and all these things, and you can also reconfigure it after it's running. Check the official Atlas docs for all the details. Now, whilst this is being created, which can take a couple of minutes, as I mentioned, you can also dive into the security tab. And there you can now secure access to your MongoDB database. Now, as you see, I already got a couple of users, and you definitely should add a user here. You can add as many users as you want. Give them a username and assign a password. And I'll just auto-generate one and copy that. I'll need it later. You can always regenerate it if you forget it though. So I'll just save it. You can then set up the privileges for this user. Get generally, is the user admin? Should he just be able to read and write to any database? And check out the security module if you want to learn more about that. You can also configure more and assign detailed roles to the user if you need to. But I will turn Max into an Atlas admin here and click Add User. Now I got my user added. Another important thing is the IP whitelist. Now here I got a bunch of IPs in there which I required in the past. Now one thing you should do here is you should add an IP address, and in the end, what you'll add here will be the IP address of the server that is running your application, or during development, your current IP address, which you can automatically fetch here. You can also allow access from anywhere, but this is generally discouraged because, of course, it opens up your database to everyone. People will still need to log in, so you still got the MongoDB user as a security mechanism, but it's still more secure to lock it down to your IP address or the IP address of your application. So now I add my local IP address. You can also turn up on some enterprise security features like a different kind of authentication. That is all beyond the scope of this course though. So let's go back to the overview and wait for this to finish. And let me just quickly talk about other things you can do in Atlas in the next lecture. So my Atlas cluster is starting. Now, Atlas is a powerful tool for getting your MongoDB environment up and running. Important for you is, if you got backups turned on, you can restore them here once they are available, of course. You can also configure alerts. Alerts allow you to see what happened. It also allows you to create new alerts here with add new alert, where you can get an email when something happens. Like for example, when a user logs in, or when the average execution time for reads is above a certain millisecond value. So somehow your reads are taking too long and you want to check in if something is going on. So you can set a bunch of alerts here for all kinds of things to always keep track of what's happening in your cluster, which is of course super useful. And in general, I encourage you to, of course, check out the Atlas docs to learn everything about Atlas when you plan using it in production. It is my strong recommendation to use Atlas as a managed solution for getting your MongoDB environment up and running, unless you are a system admin and you absolutely know what you're doing when you want to configure everything on your own, which you also can do, but which was not covered in this course, as this course, of course, is for developers. Now let me wait for this to finish, and then we'll see how we can connect to our cluster. With my cluster up and running, we can now work with the cluster. On the cluster here, you got a couple of options to migrate data into the cluster, for example, to pause it, to terminate it. You can check out general metrics about your cluster and see all kinds of information of what happened on your cluster, how many reads you had, and so on. You can also dive into the collections your cluster has. So you see databases and collections in the cluster. And some of these options might only be available outside of the free tier, by the way. So I'll not dive too deep into that. Definitely just click around there and play around. For now, the interesting part is how can we connect to the cluster? And for this, we can click on the overview page, we can click on Connect here. Now, there you see the IP addresses that will be able to connect, and you can also add an entry from here, but that's the same list we had on the IP whitelist page earlier. And then you should choose your way of connecting. Now, I will go with the shell in another module in this course later. We'll, of course, also connect from an application so that we can really use that in an app as it could run on a real server. So I'll connect with MongoDB shell. Now, you can follow the instructions here for your operating system. Download the shell. Of course, we already have it, so you can skip that step. And then connect with this command here. So you should be able to just copy that command. You'll need your password, so make sure you also have that saved somewhere. Copy that command here. And now let's switch to the shell again. Now, first of all, you need to quit a running shell. You can also quit a running MongoDB instance on your computer. You don't need to run a server anymore. We have one in the web now. And now to connect to the MongoDB cluster, you can insert the command you just copied. And the important thing here is that we have now Mongo still, but then we have this path here. And this ensures that Mongo does not try to connect to a locally running MongoDB server, which would be its default behavior, but that it instead tries to reach a server at this address. /test here, by the way, defines the default database to which you connect. So you can change this if you want. So you can also set, I want to connect to, let's say, /products here. You then need to add your username with -- username, and you can hit enter and should be prompted for your password then. Now make sure you now enter the password you chose when creating the user with which you're trying to log in. And it should then connect to your MongoDB server running in the cloud. So I'm now connected to this cloud. If I show my DBs, we again see admin config local there. And now, of course, I should already be in products, but we can also use that again, or use shop maybe. And then there, use DB products, insert one, and there I can enter a book and a price. If I hit enter, this is now inserted, and everything here works as you learned it in the course. This does not differ. It's a normal MongoDB server in the end, just one running in the cloud and not running on your computer. And you can interact with it as you did with your local server. But now you got a perfectly configured, highly performant MongoDB server deployed in the cloud. And since it's in the cloud now, so on a server and not on your local host, you can now use it from anywhere and not just your local machine. So that's it for this module. You learned about performance and fault tolerancy. For performance, there's one thing you could consider, and that are capped collections for cases where you automatically want to clear old data or you're fine with old data being cleared. So for example, for a short-term caching mechanism. Performance in general is all about having efficient queries and operations, fitting data formats, and of course, best practice MongoDB server configuration. You should be aware of replica sets now, which is basically a mechanism or a feature of MongoDB that provides fault tolerancy with automatic recovery with the election of a new primary node and improved read performance as well. You also have sharding at your disposal, which is a way of scaling your MongoDB server horizontally, so across multiple servers instead of running everything on just one machine. Now, at some point, you want to get your MongoDB server from localhost up into the web or onto a real server. And that is called deployment. Now, deployment is a complex matter since it involves many tasks, some of them, like setting up the machine and securing the network, some of them are not even directly related to MongoDB. Therefore, unless you are an experienced admin, or you got one, you work in a corporation, you should consider a managed solution like MongoDB Atlas. Atlas is a managed service where you can configure a MongoDB environment and you pay on a by usage, on a per usage basis. You can always shut it down, you can always reconfigure, you can upgrade, downgrade. So you got all that available. You got a best practice MongoDB server running in the cloud. And especially when you're working on a project on your own, you should definitely consider that as a solution to deploying everything on your own, which, well, as I said, is a very complex task. Now that we have a MongoDB solution up and running in the web with replica sets, we can dive into a certain topic that was added with MongoDB 4.0, transactions. And you need a replica set environment for transactions to work. And therefore, I couldn't show this earlier in the course. But now with the MongoDB Atlas deployment up and running, you can dive into transactions. Now, important, for this module, you need MongoDB 4.0. And currently, if you deploy MongoDB Atlas and you are in the free tier, you can only use 3.6 there. So if you use that free tier, chances are high you're doing that. You don't need to upgrade. You can just follow along with the videos and then try this out on your own once you eventually make the step into building a real app and you therefore are willing to pay something for that, or until the free tier also supports 4.0, of course. So in this module, we'll dive into transactions, and that of course poses one important question: what are transactions, and then how will we use them? Both will be covered here. So what are transactions? Well, let's consider this use case. We have a users and we have a posts collection, and we got a couple of documents in there, and let's say each user, or most users, have a couple of posts. So the posts are related to users because the user is the person who created the post. So we have that stored relation, maybe stored with a reference, so with a key stored in a user or in the post document. Doesn't really matter. Now we delete the user account, and therefore we want to delete the documents here together, so in two collections. Now, this can be done without transactions. We can simply delete a user And right before we do that, we save the ID of that user, we find out the user ID, and then we reach out to the posts collection, find all posts who are linking to that user ID, and delete these posts. That is perfectly possible without transactions. Now, the thing just is, what happens when we actually have a use case where deleting the user succeeds, but during deleting the posts, somehow something goes wrong? We have a temporary server outage, we have a network issue, whatever it is. So then we end up in a state where the user was deleted, but the posts are still there. But the user they're pointing at doesn't exist anymore. This is exactly the use case where transactions help us. With a transaction, we can basically tell MongoDB, hey, these operations, as many as you want, either succeed together or they fail together, and you roll back. So you restore the database in the state it was in before the transaction, regarding the documents that were affected in the transaction. That is the idea behind transactions. Let's now try that out. And again, for that, you need MongoDB 4 and a replica set. So that is why I will use the MongoDB Atlas deployment we created in the last module. So here I am connected to that MongoDB Atlas server in the web, and I will use a new database block. And in there, let's quickly insert some dummy data. Let's insert a users collection, and I'll insert one user here. I'll make this really simple. I'll have a user with a name of Max. That is my one user. Now I got a user ID, and I will copy that ID, because now I'll add a posts collection where I insert many posts. Therefore, I need an array here. And then the first post has a title of first post, and important, a user ID at which it points. So here I'll use a relation with references. Check out the relations module in this course if you want to learn more about data, schemas, and relations. So here I'll just store that ID. And then I'll add a second post here with the title of second post, and that post will have been created by the same user, so I store the same ID as a value here. If I hit enter, these two posts are also created. Now, if we want to delete the user, we would obviously find out the user ID, and that is probably something you know in the application where the user clicked on delete my account. So in the end, you would do something like db users, delete one, and then search for _ID equal to that user ID, which you know. Now, you would do that, and then with that user ID, which you do know, you would of course also go ahead and also execute db products delete many, and delete all products where the user ID, so that field which I added to each post where we point at the user, is equal to the user ID too. I won't execute these commands because I don't want to delete the data right now, but this is how we could clear all the data. And this would work in 99.9% of cases. The problem just is the cases where it doesn't work, because something goes wrong and we end up in a state where suddenly, well, we deleted the user but not the posts, or the other way around. And for that, we can work with transactions. Now, how does a transaction work? Let's dive into that in the next lecture. So how does a transaction work? Now, for a transaction, we need a so-called session. We haven't worked with sessions before, but a session basically means that all our requests are grouped together logically, you could say. You create a session and you store it in a constant, let's say here, with db get Mongo. This gives you access to the Mongo server, basically. Start session. Now I have a session stored in there. Now that session, again, basically is just an object that now allows me to group all requests that I send based on that session together. That is how you can think about it. Now you can use that session to start a transaction. So start transaction is something you can do. Now, important, that session is required because technically every command I issue here is sent to the server, and then normally the server would forget me. And therefore we need that session so that when I send something based on that session, the server remembers, oh, that session, which behind the scenes is managed through a session key and so on, I know that one, that command you just sent me should be considered in the context of the other commands you sent me based on that session. That is how you can think about that. So now we started a transaction, we can now get access to a collection. So let's say to users and products. So I'll create a new constant, users C for collection, and we use that session again, get our database on which this session was created, get a database for that session now, or for this operation. And here the database is blog. That is the database I created earlier, if you remember. Here, use blog. And then we get access to a collection, the users collection. And get database definitely runs if you type it correctly. And now I have that user C. So then let's name it users call now. Okay, so now I got the users collection saved here with the right command. Now let's repeat that for the posts call. Here we get access to the blog database, but now to the posts collection. Okay, so now we started the transaction and we get access to our collections. Now we can write all the commands we want to execute against these collections here. So now, first of all, what I'll quickly do without session is I'll execute db users find pretty. Now important, since I don't run this against the session, this executes as normal and I get my object ID and the object in general, which I need. So this is now not included in the transaction because it's not included in the session on which I started the transaction. I just needed to get the ID right now. So now I can go back and use my users call, which is this object, which is basically a pointer at my collection, but also mapped to this session, you could say. So now I'm using the collection in the context of my session through that constant. And there, I can now use my normal operations. Inserting, finding, updating, that all works. So here I can now basically run delete one, and search for ID equal to object ID. If I now hit enter, this was acknowledged and deleted, but if I repeat db users find, you see the user still is in the database, so it hasn't been deleted yet. It was just saved as a to-do, you could say. Now I will use my posts collection, so posts call, which I created here. And I will use that to then delete many items in there based on the user ID, which of course is that same object ID as I used for deleting the user. Now this was also acknowledged, and it says deleted too, but it didn't yet write this to the database, as I can prove by looking into my posts with DB, not with the session. Now you see the posts are still there. Because to really make this work, or to really commit these changes to the real database, so to say, I have to run session commit transaction. There also would be abort transaction. So in case you don't want to continue, you can abort it. You should do that to cleanly close it though, but now if you do that, the changes will not be applied to the database. With commit, they will. So if I run this, it failed initially. Now I repeated it without all these DB in-between queries, which seem to have messed it up. If you just execute the steps basically as I explained them, but now simply creating a session, then getting access to your collections, then starting the transaction, and then just specifying the two commands that belong to that transaction, and then committing it, then it works. And now if I dive into my database and find my users, you see the user is gone, the one user I had. So this is how transactions work. You get access to a session, you then, based on that session, that's always important, you use that session to then store a reference to your collections in some variables or constants, and you do that from your native drivers for Node and so on, of course, too. Then you start a transaction on the session, and then you execute your manipulating queries. Finding doesn't make much sense in here because, well, what would you find in there in the transaction? The transaction is all about safely changing data. Like here, I delete the user, I delete the posts, and then you commit the transaction. You could also abort it with abort transaction in case you don't want to continue, but if you want to continue, well, you can just commit it. Now, also important to understand here is that for this transaction, if it somehow would fail, if something would go wrong, let's say the user was deleted but posts weren't, then it will roll back these operations in commit transaction, and thereafter your database will be in the same state as before. So these actions either succeed together or they fail together. That is the idea behind transactions. Now you might remember this atomicity topic I talked about way earlier in the course. There I explained that MongoDB is atomic on a document level. So if you write a document, it either is written entirely or not written at all. This basically gives you atomicity across multiple operations, so across multiple steps, or even something like delete many. Normally, each operation on its own would be guaranteed to work, but if you delete 2 posts here, you're not guaranteed that both deletes will work. So with a session, you could even just wrap delete many or insert many to guarantee that either all documents are deleted or inserted or none at all. So you get atomicity on a operation level, so to say, and not just on a document level. That is the idea behind transactions, and that is a useful feature for situations where you know that some operations depend on each other. You should definitely not overuse it though. If you don't need it, don't use it, because obviously this takes a bit more performance than a normal delete or insert. So only use it if you know you need that cross-operation consistency. Throughout this course, we always worked with the Mongo shell, for a good reason, because it's a neutral instrument which we can use to practice the different aspects of MongoDB, the different operations you can execute, and all that stuff in a way that is, well, independent from the application you're building. No matter if you're building a Python, a C++, or a JavaScript Node.js application, you can work with the Mongo shell to practice MongoDB. Now, obviously, it's important for you to be able to transition from the knowledge you learned here with the shell to your drivers. And therefore, in this module, I will show you how to generally find out how to use the drivers for the different languages you might be using for your application. And we will actually work on an entire project built with JavaScript and Node.js and implement the official MongoDB driver there so that you can see how that would work, how you then connect to your MongoDB instance, and how you then, well, write operations or execute operations from inside your, in this case, JavaScript application. Now, important for this module, we will build an application with React, Node, and MongoDB. But even if you're not a Node.js or React developer, you should still go through this module because you'll still be able to follow along and understand the general philosophy behind connecting MongoDB to an application. And you'll still be able to understand how you use a driver with MongoDB. So you'll still get all the important information out of this module. So in this module, I'll show you how shell commands can be translated to driver commands and how you find out how to use the driver of your choice. I will also show you how you can then connect to MongoDB servers from inside your driver, and we'll use MongoDB Atlas for this in this module. And I will also show you how to perform CRUD operations from inside your driver, so from inside the application you're building via the driver, I should say. That is what's inside the module. So with that, let's get started. Before we dive into the actual code, there's one important thing you have to know. And that is that you have to understand how the work between management of the database, probably through the shell, and interacting with the database through the driver, how these two parts are separated or split up, how you split the work. Now, for the shell, so what we used in this course, you'll typically stay to the shell for things like configuring the database, creating collections, or creating indexes. Because these are tasks which you typically do up front, so when you set up the backend for your application. You don't really do that right from inside the driver because the driver is tightly coupled to your application logic. And if you're building an online shop, for example, your code will basically be responsible for handling products, users, for working with orders, and things like that. The initial database setup is not something your application deals with. It assumes that the database is there and that you can then communicate with the database. So this whole setup stuff will be done from inside a shell or basically up front. From inside the driver, so from inside your application, so to say, you typically perform these different CRUD operations to store new data in the database or retrieve or update or delete it. And you might also work with the aggregation pipeline to, well, fetch data in a more structured way if your application requires that and the data format in the database doesn't fit the format you need it in. So this is how you can roughly split the responsibilities. Now, technically, you can absolutely create collections and indexes from inside the driver. So that is possible. But with that, why don't we just have a look at all of that in an example application which I prepared and where we can now continue to work on. Now let's prepare for this application. I will use a deployed MongoDB Atlas cluster as my backend. Because for your application, when you then ship it into the web, you of course need a database that's also reachable from everywhere, and you want to have a database setup that follows best practices and so on. And as I explained in the last module, Atlas is a great solution for that. So I'm just bringing up another free cluster here. If you already got one up and running, you don't need to do that again. You can continue with the last one. And under security, you should make sure that you have at least one user with read and write access in your database. And that is important. In your application, in your front-end applications on, you only need that. At least in the app we're building, we'll only need read and write access. Because the entire administration and setup we want to do is done up front. Basically here, when we set up that server here, there is no additional configuration I need to do right now, but if we need to do something, we'll do it by connecting to the server in the shell. So anything related to setting up collections, collection validation, or indexes, we would do that through the shell. Now, for the cluster, also make sure that your local IP is on the whitelist here. So make sure you add your IP to the whitelist in case you haven't already. Now, I did this in advance, but you should make sure that your IP is there. And with that, I'll wait for this to finish, but we can already continue with something else. In this module, we'll work on a Node.js, or to be precise, on a React Node.js application. We'll have a single-page application built with React.js, which is basically our UI, our user interface. And that single-page application will talk to a Node.js RESTful API. And attached to this video, you find the fully prepared project where no MongoDB interaction was added yet. We'll do that together. But you find the entire Node React app attached to this video. Now, to run it and to install all the dependencies and run the React development server too, you need Node.js. So visit nodejs.org and download the latest version. In my case, 10.10, but whatever the latest version is in your case. Download that version. The download link here will give you a convenient installer through which you can walk. And once you downloaded it, you should navigate into the extracted folder. So the folder you find attached, simply unzip it, store it anywhere in your machine, and then in the terminal, not in the MongoDB shell, but in the normal terminal, navigate into that extracted folder. And with Node.js installed, which is important, you can now run npm install in here. And this will install all the dependencies of this project, which you need in order to be able to work with it. So this can take a short while, but shouldn't take super long. You can ignore any warnings you might see here. And once it is finished, you can start two things. The first thing you can start with npm start, so with this command, is the React frontend. So the user interface, which I built as a React single-page application. With npm start, this will start the application. It will start a development server, which basically serves up our React application. And you should end up on a page like this. And it's okay if you see an error initially, because it fails to fetch data from the backend right now, because we only started our React frontend server. Now, I also need to start up my Node REST API. For that, simply create a new terminal window and navigate into the same extracted folder. And in there, you can now run npm run start : server. And you need to run this and keep the other process, npm start, which hosts the React app, up and running too. So this process, the npm start process, needs to keep running. And this process now also should be started and also needs to keep running. With both up and running, you can reload your app, and now you should fetch some dummy product data. And this is not fetched from a database. This is really just stored locally. It's some dummy data, and we'll replace all of that with data from the database so that we can add new products and see them here. So this is a little dummy application I prepared here. And with that prepared and up and running, we now got everything to work on the code and then use MongoDB as a backend. In the meantime, my cluster creation here also finished, so we're good to go here too. Now, you might already have installed it because we used it throughout the course from time to time. You now will also need an IDE, an integrated development environment, to work on the code to add MongoDB. So to download Visual Studio Code, simply choose your operating system if it's not selected correctly anyways. Click download and walk through the installer, which this will start. Now you can also use other editors and IDEs if you got your favorite editor or IDE. That will of course all work. But if you don't know which to use, this is a great free way of working on a Node React application. Now once you installed Visual Studio Code and you opened it, you can adjust it to your requirements. For example, under Code, Preferences, you can choose your color theme. I'm using the Dark Plus theme. I also installed a special extension to have the material style icons. But that is it. Besides that, I got the default setup basically. And with the Visual Studio Code open, you should simply open that folder which you extracted, where you also ran these commands in the terminal. Well, that folder is what you should open here, and you'll get this setup or this file directory. Now, this is the setup we'll work in. This holds the source code we'll work in. And there you basically have the top level folders, which are related to your React application. So source and public, these are important for React. In the backend, you find the code files related to our simple Node RESTful API. There I also have the images folder with the dummy images I'm using. So with all of that set up, we can now get started, work on that code, connect it to MongoDB, and so on. So we got our application, and now we want to integrate MongoDB into Node.js. Now to do that, you can dive into the official docs, and there choose MongoDB drivers. There you'll find instructions on how to install and use the driver for the language, the programming language your application uses. You see, there are a bunch of languages, and for us, Node.js, this one, is the relevant driver. So you can click on that, and we are forwarded to the docs of that specific driver. Now there, you can simply choose the latest documentation, and now learn more on how to use that driver. And you see, you learn how to install the driver, and then you have a quick start and some instructions on how to do CRUD operations and how to connect and so on. And you should find this for every driver. The documentation might look different, but you should find similar guides for every driver so that you can learn how to use that driver with your language. And that already gives you like most of the knowledge you need. You also can dive into the API documentation to see a list of all methods or all objects that are part of this driver. For example, here you also see the constructors for decimal 128-bit objects in case you want to store such a decimal, if you remember the numbers module of this course, because Node.js is based on JavaScript. And as you as a JavaScript developer should know, every number in JavaScript by default is a 64-bit float. So if you want to store it as a bigger decimal, you will need to convert it, or not convert it, but create such an object with that constructor. The same exists for 32-bit integers and for longs, which are 64-bit integers. So this is also useful if you want to find out what's in there. How could I possibly get such a decimal? Well, the API reference should help you. But we don't need to dive into that right now. We just need to install the driver. And as you can see with Node.js, this is the command we have to execute in our project folder to install the official MongoDB driver. So we can just comment this, and then in here, in our project, I'll open the integrated terminal, which is integrated into Visual Studio Code. You find it under terminal here, new terminal. And this is simply the normal command prompt or terminal you have on your operating system, just already navigated into this project folder, which is great, of course. So I'll paste this command in here, and this will now install MongoDB in this project so that I can use it from inside this project. Now with that installed, we will be able to use it. Now one important note, it's the Node.js driver. And if you remember our documentation, there was no React.js driver. The reason for that is that you never connect to MongoDB through the official drivers directly in your client-side applications. So in your Angular, React, or Vue user interfaces, you never put your database connection code in there because you will expose your credentials there to the user, which you don't want. On Node, which runs on a server and is inaccessible by the user, these credentials are secure. And I will show you what I mean real quick. If we have a look at our running application, and you have a look at the developer tools, which you can open by right-clicking and inspecting in Chrome. In these developer tools here, this is the HTML code, but if you click on sources here, you will actually be able to access the entire JavaScript source code that makes up the front-end part of this application, so the React application's code. You can access it here under source, and here we have our React code. And if you had the logic to connect to MongoDB in here, well then every user using your website can see that. And that's not a security issue, that's just how front-end JavaScript works. It's readable by your users. Therefore, the connection logic and the entire interaction logic has to live in the Node.js part, so on the server. Now, there is an alternative, which we'll learn about in the Stitch module, which gives you a different way of working with MongoDB, but there in the end, it'll still be such that no credentials are exposed in the code. And for now, we don't have to worry about that other alternative. Here, this is how it is. You must not put your MongoDB data, your credentials, into this front-end code. So that is why there is no React.js driver and no Angular and Vue, or in general, front-end JavaScript driver, but why we use the Node.js driver. And with all that out of the way, in the next lecture, let's finally connect our backend here to MongoDB. So let's connect to MongoDB. And for that, make sure you are on your clusters page so that you can click on connect there and find out how to connect to this cluster. Now we did connect through the shell in the past. Now we can also connect our application. And for that, yes, we are using the latest driver. And then you can just copy that address if you want. You can also see the driver examples if you click on it down there. So if you click on Node here, you are basically forwarded to some part of the Atlas documentation in this case, where you see a code snippet on how you can connect to your address, and you'll have to replace some data there through the official driver. But we'll do this step by step. So let's go back to the cluster, copy that here, and then head over to your code. And in there, let's start in the app.js file. This is the file where basically all requests end up in, which are sent to your Node backend. So whenever the front-end React sends some request to the backend, like get me all products, first of all, we start in this file. Then in Node Express, the request is basically funneled through some middleware, as it is called, so some functions that can interact on the incoming requests, like set some headers here. And then here, I forward the requests to different routes, so different handlers, you could say, depending on whether I'm requesting something related to products or just /nothing. The routes are stored in the routes folder, and for products in here, I have some dummy data, but there I have a route for get requests. If it's just sent to /products, I just have slash here because the products filter is in the app.js file. So if it's targeting /products, then this function is executed essentially. And there, what I do is I have some pagination logic in there, which we can ignore for now. I basically parse my dummy data and I return my data here. So this is what I'm doing here. Now, app.js is also the file where the code is executed when we start up our server, which we did with this npm run start server command. This basically just used Node.js. Basically, we executed this script where we used Node.js to execute the app.js file. And the app.js file does some general setup, like setting up all that middleware which will handle incoming requests. And therefore, we can connect to MongoDB here in this file to automatically connect our app to the database whenever we start the app server. And we want to have a running connection, so to say, which can then do something for incoming requests right from the start. So here, the first thing we have to do is we have to import our Mongo client. For this, I'll create a new constant, so a new value which will never change. And then this is the import syntax in Node.js, and I will require MongoDB, that is the package name of the package we installed, and there the Mongo client. So this gives us access to the client, which we need to establish a connection and so on. And what we can do now, at any point you want, maybe down there, you can use that MongoDB constant and call connect. And this is also what you saw in that snippet here. There you also see that constant or variable here was just named differently, but then I called connect. And to connect, you pass that connection URL, and then you have a function which is executed after the connection completed. So here we can paste in that connection URL, which we got from the cluster page. Now important, you will need a username, and for that user, you will also need a password. So I'll just use that one. By the time you're viewing that, this will be offline, so using mine won't make much sense. Then I'll use the Maximilian user. So I'll use that read and write user here. And for this user, I just updated the password, and I'll paste the password in here too. So now this is a URL which allows the client to connect to the cluster. I don't want to use the test database, but I'll use a shop database, which will be created on the fly. And with that, the connection will be established. And now we could pass a function as a second argument, which will be executed when the connection finished. Or we use a feature called promises, where we basically have a then method to which we pass a function that will be executed once this connection finished. Or we have a catch block that catches any potential errors. Now here in the catch block, I'll simply output the error so that we can see it. Console log basically logs it to this console, so we could see error messages here. And then I basically have an anonymous function, and this is just how you create an anonymous function in JavaScript that will execute once we are connected. So here I can say connected, and here as an argument, I will actually get access to the client. So a client which then allows me to execute a database method, which then in turn allows me to, for example, work with collections and so on. So we'll do this later. For now, we can instantly close the client to remove the connection. We'll, of course, later reuse it, but for now, I'll immediately close it and just log connected in between. Now, after saving this and after changing your server-side code, you have to go to the terminal where you ran npm start server and quit that process with Ctrl-C and simply restart it because you changed something in your application. Now you need to restart it. And after restarting, you should be able to connect to your MongoDB database server, to the Atlas cluster. Now, with being connected, we took our first step, but of course, we're not doing anything useful here. So in the next lectures, we'll of course start writing some code so that, for example, when we add new products here, we store them in the database. That sounds like a good start, so that we later are also able to fetch them, doesn't it? So we have our dummy connection here, because we're not really using it usefully here. Now I want to use that connection and actually do something useful with it. I want to be able to store products in the database for now. So what we can do is we can cut that code from the app.js file for now and go to products.js. And here in products.js, if we scroll down, you should find a post route, which is the route that handles the creation of a new product. Here I got some code that extracts all the product data from the incoming request. And then right now I don't do anything with it except for returning a response. Now here I want to take that new product data and store it to the database. And as you can see, I also made an annotation that I want to take that data and store the price as a 128-bit decimal so that we can practice that transformation of the type 2. So what I'll do here is I'll paste in my MongoDB connection code because I'll need a connection. And if we just establish a connection here, this connection will by default not be reusable. So we always have to connect from scratch if we want to do something with the database, something I'll change soon too. But for now, let's do it like this. So here I'll then connect to the database. And once the connection is established, before I close it, I can do something with it, except for logging some useless message. Here, I can use my client and call DB to get access to the database. The database I have access to is this database, by the way, the shop database. And then call collection here, right? We have collection as a method. Now, MongoDB, by the way, won't work here because one thing is I also need to grab that import and copy that over into products, because whenever you're using some feature in a file, you need to make sure that feature, like the client in this case, is available in that file. And I'll also change it slightly and import MongoDB like this, and then create a new constant here, Mongo client, and basically use MongoDB Mongo client like this, and you'll see why in a second. So now Mongo client is the constant which I use for connecting, so that there we use Mongo client connect. And now we got that client with the collection method, and then we can access a collection. And I'll use products. Now this collection doesn't exist. If we wanted to create it ahead of time, because we want to add schema validation or anything like that, we would create it from inside the shell. So in the shell, we can of course also connect to our Atlas cluster. There, if I click on connect and we click on connect with the shell, the latest shell, you can copy this command, and here you want to use your admin user. In my case, that is Max. Max is an admin. So you then can connect to your cluster on that username, who is the admin. You'll need the password. And since I forgot it, I will regenerate it. And then you can create collections and so on from inside that shell. So inside of that shell, you want to interact with your shop database and then, for example, create a collection with whatever setting you have. Now here, I don't want any special settings, so I can use the on-the-fly approach. And here I will simply use a CRUD operation to insert something into the collection, and the collection and the database will then get created. Now, how can I insert something here? Well, with the same methods I showed you in the shell. For example, here we also have insert many and insert one. So this works in exactly the same way. And that will be the case for all the drivers of all the languages. The syntax, of course, differs. In PHP, you obviously use PHP syntax for accessing methods and so on. But the general methods you have available, the operations you can do, are the same. And they are equivalent also in the way of how you use them and how you configure them to the operations I taught you in this course in the shell, which of course was the idea of this course. So we can use insert one here, and I want to insert my new product. New product refers to this object, this JavaScript object which is created here. And these are my keys here, and these are my fields. This already looks a lot like the JSON document format we use throughout this course. Now, important here, this should also be converted as or stored as a 128-bit decimal. So let's see how that works in the next lecture. So we want to be able to store a new product, and the price should be stored as a 128-bit decimal. Now, to find out how that works, it's always a good idea to dive into the official docs, of course. So here I'm in the Node.js driver docs, and one way of finding out how this works is to go into the driver API and look for something related to decimal. And indeed, here's a decimal 128 object. Now, this is a constructor, as we can tell by the new keyword, and we could pass some bytes in to create a decimal, but even more useful is probably this static method, which creates a decimal 128 instance from a string representation, and that's exactly what I want. So now, we just have to go back and import that object from MongoDB, which is why I now import this separately. Because now I can use my decimal, or can create a constant named decimal 128. That name is up to you though. And you import it from MongoDB here, decimal 128. So now I can use this constant as a reference to that decimal 128 object. And here, instead of using the native JavaScript function parse float, I can use decimal 128 from string. And with that, we hopefully can extract the price and convert it to a decimal 128 object. That will then be sent to MongoDB, and MongoDB will know how to store it. That was a lot of talking, but with that, we just have to do one more thing. We can call then and catch here after insert1, because insert1 also returns a so-called promise, so that we can either react to any errors we might be facing, but even in the case of an error, I want to close the connection, but I want to do that inside of catch so that I don't close it too early. Because the way JavaScript works, this line and the line thereafter will be executed right after each other. JavaScript doesn't wait for this operation to finish. So anything that relies on it being finished should go in these we're done handlers. And then I also get back the result, which I can log to the console so that we can see what I get back. And then I also want to close the client. So with that, I now restructured my code. I'm now connecting inside of that post route, and I'm sending data to the database, to the products collection, and then hopefully we have some working code here. So if I now save this, save all files, and I go back to that window where I ran npm run start server, we can run this again because we changed the code. And now let's go back to our React app, and here you can enter any product data you want, any price you want, try adding some decimals, and any image URL you want. For example, you can use localhost 3100 because that is the temporary host the backend runs on. And then you can pick /images and then any of these image names like product-backpack.jpg. And then here we can enter a description. Does this work? Click create product. And I got an error. So let's see what's wrong. Now, the error we got here, string trim is not a function, is related to the decimal 128 from string method. And the problem is that this price here is not a string by default. So we first of all can convert it to a string by calling toString on the price here. And now if we save this and we quit our server and restart it because we changed the code, now here we can simply click OK and click create product again. And now this looks better. And now here on the backend, we actually see something that does not look like an error. Indeed, we get back a command result, and you see a lot of information about the operation that was executed. The host it sent the data to, and at the bottom, also the inserted count, so one document was added, and the ID. Not an object ID, because in JavaScript, object ID is not an object that would exist, but basically the string, which is wrapped by object ID. And if I go to my other terminal, where I'm connected to that same server through the shell, if I show collections, we do see the products collection now. And here, if I look into it with find pretty, we do see that one product I just added. We see the price is a number decimal. We see the image link here, and we see the object ID. And this part here in the middle is just what we got back here. So this is now a working insert through the client. Now that we are able to insert data, let's also fetch data in the next lecture. Now, before we are done inserting though, there's one thing I want to change. When we send a response here, I want to send that inside of the then block or of the catch block. Here in the catch block, I'll send an error response where I maybe say something like an error occurred in case I don't have a more detailed error message. And here, if we did successfully enter it, well then here I will say product added, but I'll not return dummy ID. Instead, I can simply use result inserted ID to return that. And this is now better because we should return the response once we are done with this asynchronous task and not outside of our promise, because then we actually send the response before we are done with that. And therefore, we send it before we know if it succeeded or not. So this is better. With that, let's move on to getting data. Now that we are able to insert data, let's also get data. And for that, I will grab this entire Mongo client code here, copy it, and we'll soon find a better solution, and move over to my get/slash method, which is the method that is triggered by requests that want to fetch all product data. Now here we will use MongoDB. I'll comment out this code for now, and here I'll then paste in my code for, well, interacting with MongoDB. Now, I still want to connect and use that client to reach out to the products collection, but I don't want to insert anything. Instead, I'll now use find, because I want to get all products here. So find gives me all products, right? Well, almost. What does find give us in detail? If you remember the read module, find gives us a cursor. So we should use that cursor here to traverse through our data. And just as before, you'll learn more about the cursor in the official driver docs by searching for the cursor object here. And you'll see all the methods you can execute on the cursor and how they work and how you can interact with the cursor. So we get back such a cursor, and I simply want to go through all the documents I get back and then do something with them. So I will chain a method here. I'll chain the for each method. For each simply goes through all the documents inside of my cursor. So it basically fetches all the data. And in for each, I should get access to my product document one at a time. And then here in this anonymous method, which I pass to for each, I can do something with that. So here I will simply log the product document for now. And then can then be chained, but it's chained after for each. Because this still is an asynchronous task. It will take all the documents one at a time and fetch that from my database server. So this is now looping for all the documents. And here I know that I'm done with that operation and all the documents that I wanted to process have been processed. Let me also return the product doc here to see if that does something. So then here I have my result. Now, I don't want to say product added here in the response. Indeed, I have a response here which I want to use. I'll use a response with my result products, which is my old dummy data here. For now, I'll just return an empty array until I have some real data. We can also set the status code to 200 here. And down there in catch, I still say an error occurred. Also makes sense to do this on the general connections catch block here, I guess. Also for inserting. So with all that added and with the cursor being used, let's see what we got here. So let's go back to our backend server, quit the process and restart it because we changed something on the code. And then in the React app, simply reload that starting page. Now you won't find products here because I'm returning an empty array. But what I do see is that I do console log some data here. And that console log is stemming from this line. However, in the then block, I then console log null, as you can see. So I get my data here, but I'm not really able to use it here. So what can we do now? Well, what we can do is, we don't need that line, but we can now create a new constant here, which we can name products, which is an empty array initially. I create this right after the connection was established. In for each, I can then use products and push product into that array. Now I also need to transform the price though, because that will be a decimal 128-bit object which can't be handled by JavaScript. So I'll set product's price equal to product's price toString. ToString is a method provided by the MongoDB driver for the decimal 128-bit object. And I basically take the old value, convert it to a string, and overwrite the value with that result of that operation. And then I push that changed product onto my products array. And since I defined that array outside of this chain of methods, I can use it everywhere inside of this anonymous function. And therefore, in this then block, where I return a response, I can also return my products array. So this array. I can get rid of this console log here. And now if I save that, I have to restart my backend server again. And now if I reload that front page here, I get an error. Let's quickly check what's wrong. Yeah, product's price is wrong. Of course, here I should use product data, product doc, and also push the product doc, because I'm of course interacting with the product document here. So this was simply a typo. Now let's restart our backend server and let's try this again here. Let's reload the page. And here is the product we added, now fetched from our database. Please note that the image, of course, never was stored in the database, and it never should be. Images should be stored on a file storage. Here I simply have some dummy images I'm using. You can use any URL when saving a new product. If you also have a web application with upload and so on, you would store the uploaded image in a file storage and then only store the path to the image in the database, not the image itself, because this simply bloats your database, is pretty inefficient, a lot of data to transfer, and just not what a database is built for. But with that, we got all the code we need to insert products and to get them. But we're also repeating ourselves regarding how we connect to the database. So that is something I want to change next, how we connect to the database and then interact with it. Now with our basic interactions set up, we have to optimize our code a bit and move it into a more realistic setup. Now, for that more realistic setup, I'll create a new file next to app.js and I'll name it database or db.js. Now in this file, I will import MongoDB here, and then I'll write some code here, which gives me a nice utility script to set up a connection to the database and then get access to the established connection. For this, I'll first of all create a new constant initDB, which simply points at a function which receives a callback, so another function it can execute as an argument. And here, additionally, in that file, I'll add a variable with let underscore db. It has no initial value. Inside of initDB, I'll check if db is uninitialized. And if it is not uninitialized, so if this returns true, which only happens if it is initialized, then I'll simply log database is already initialized, and I'll just return my callback. So I basically call the callback. I expect to get a function as an argument, so to say, and I'll execute that function here. And I pass null as a first argument because my callback will receive an error as a first argument, and I don't want to throw an error here. It's fine that we already are connected, so I just return the existing database. But of course, this is a case we can't reach right now because we have no code to actually store something in underscore db. So this is what happens now. I will create my constant Mongo client here and use MongoDB, Mongo client to, well, get access to the client. I'll also create a new constant MongoDB URL, and that will be my connection URL. So basically the URL I'm using in the products.js file right now here for the connect method. This string, that is what I copy, and that is what I move into the db.js file and which I store here as a string as well. Now back in initDB, I will use the Mongo client here and call connect and use that MongoDB URL. So basically the same code I have in products.js. Now, by the way, you can also, that should have a lowercase l, you can also pass a second argument where you configure this connection here. Now, this is a bit more advanced and you should check out the official driver docs to learn what you can configure here. The default settings should be fine, and they are fine for us here. So I will just connect like this. And then here, of course, we have a promise, then, and catch are therefore functions we can use here. Now in catch, we'll get any error that occurs during the connection. And therefore here, in the error case, I will execute my callback and pass that error as the first argument. Because I mentioned that the callback, the function I receive here, will be a function I call, and I expect whoever who passes this function to me to implement this function in a way that it is able to handle the first argument as a potential error. So that's the bad case. The good case is that we are successful, so that we do successfully connect. And in this case, I get access to the client here in the then block. So the logic is the same as in the products.js file. So this client here allows me to then simply store the database. So db is then equal to client db. So this gives me access to the database, which was created. So now I have some method which I can execute to establish a connection. I'll now create a second constant in the same file, which I'll name getDB, to get access to this established database connection. Should be written like this. Will also be an arrow function. And here I simply return _db. However, first of all, I'll quickly add a if check. If not _db, so if this is uninitialized, then I'll throw an error where I say database not initialized. So now I have two functions in here, initDB to establish a connection and getDB to get access to an existing connection. How do I use these now? Well, in app.js, which is the first file that gets executed when we start up our server, I can remove that MongoDB import I have there, and instead I can add an import to my database utility file. So I'll just name it db, and I do import my own file by typing require ./db, and you can omit the .js. Now here, before I call listen, I will call db, and then what? Well, I need to call the functions that are in that file. And to make these functions callable, I add module exports at the end, and I'll export an object here, and that object will receive initDB and getDB. And this syntax simply creates keys called initDB and getDB, which receive their respective constants, which are functions in the end, as values. So now with that, in app.js, I can call db initDB here, and initDB needs a callback function, as you learned. A callback function that will either give me an error or the database, because here I want to also call the callback with null and then the database like this. And now in app.js, I know that if I'm in here, I can check if the error exists, and if it does, I'll simply console log the error. But else, if I got no error, then I can call app listen, which starts the Node.js server. So the Node.js server in this setup here will start when the connection is established. Now you can always tweak this, but this is a basic setup that ensures that the database is, or that our app here connects to the database at application startup before it starts listening to incoming requests. And then this simply will keep on running. Now in products.js, we also don't need the Mongo client anymore. We need MongoDB though for the decimal import. But I can now add my own import, db, by requiring. And now we go up one level with two dots. And then we point at db like this. So at our db.js file. And then in the places where we work with the database, we simply replace this entire part where we connect and so on with a call to db get db. And that returns us the connected database. And therefore, this closing pair of brackets can be removed. And now we just interact with the database here, and then the rest of the code stays as it is. And in post, it's the same. We replace that code here with db get db and remove that redundant pair of brackets. With all these changes, let's quit our currently running backend server. Restarting, router get catch is not a function. Let's see what's wrong here. Oh, yeah, that catch block here, that is also redundant now, because that was related to catching errors during the establishment of our connection. We don't need that anymore. So let's remove that outer catch block on our get and post route so that we only have the catch block on for each, or the catch block on insert, but not the one that was related to connecting. And let's now try this again. This looks better. We get no error. And if I now reload that front page here, now I have an error. client is not defined is the error I get here. And that makes sense because I still have the code to close the connection, which I don't need to do. And I'll say some words about that in a second too. So make sure you remove all client close calls here in your products.js file. And thereafter, restart. After reloading, I get a strange result because I accidentally deleted my products constant, and therefore I load my old products, which I have up there. Now, I should simply comment out my dummy products up there, which I don't need anymore, and then simply recreate my products down there as an empty array to which I push all the products. So now with that, finally, if we now restart the backend server and we reload that starting page, we should see only that one product which we added. So now we have the same functionality as before. And let's also confirm this by adding a new product. And for this, I'll just use some of my dummy data, lovely earrings, price, and the image URL here simply is this URL. And then in there, let's also add a description. Like this. Now if I create that product, you see the lovely earrings exist here too. So now we got that all set up. We're now able to store data, to get data. Now the next step is of course to also get data for a single product. If I click on details here, which right now doesn't work. And I also want to drop some words on reusing that connection, which we're currently doing. I'm using one and the same connection all the time now, and this is actually something which you should do, because you'll use a concept called connection pooling, which is provided by the MongoDB driver here by default. That means it actually establishes a couple of connections, or at least it's ready to quickly establish them, and therefore you can handle multiple incoming requests to your Node REST API simultaneously, because you can only send one request per connection to MongoDB normally, but since you have a connection pool here of multiple available connections, even if you have multiple incoming connections to Node.js, you can forward them to MongoDB thanks to this connection pooling. So this is also an advantage of this approach where we reuse one client, because here we actually have a shared connection pool then. Now, to fully reuse that though, we should not call DB here. So DB should just be the client instead. And therefore, in products.js, when we call getDB, we have to call DB ourselves. So this is one tiny change you should make to be sure you can reuse your connections. But with that out of the way, and the backend server restarted one more time, everything should still work right. So now let's work on getting a single product. So now that we can store products and fetch all products, let's work on getting a single product. And for that, we can use our get route here. This parses basically an ID, which is encoded in the URL. If we view the details here, you can see that URL here. That is the ID as it is stored in MongoDB. And therefore, we can use that ID to fetch our product, of course. Hence, what I want to do here is I'll reuse my code here with find to find that product and replace that dummy code here with that code. However, I'll not use find but find one, because of course I know that I will only find one product here for a given ID. But that is a filter which I need to add here. Now I want to search for ID being equal to that ID. And for that I need to get access to the object ID object. So I'll name that constant object ID and import it from MongoDB. Object ID. So just as I created a decimal 128 object, I can also create my own object IDs, which MongoDB understands. So now this is stored in this constant, and down there, I can simply use that with the new keyword. So the object ID is a so-called constructor function in JavaScript. And there I can pass in a string. Now that string is basically extractable from the URL with the help of Express, which is the Node framework I'm using here, with request params ID. So this gives me access to the request parameters, so the data encoded in the URL, and then I'm extracting ID because I named it ID here. And that is then passed to this constructor, which gives me an object ID object, which MongoDB understands. find one, then returns a promise. So I have catch and then. In the error case, I'll reuse my error code from down there and simply send an error response. In the success case, I should get my product document, and then I can return this with status code 200 for I got something, and simply pass it as JSON data to my front end. So now this should be some code that works and allows me to fetch a single product. If you save all files, you can restart your backend server and now try reloading that page. Now, it almost works, but I get an issue regarding the number decimal. Well, the problem here is that a single product has its price stored as a decimal 128-bit, and therefore I need to convert it. So I will simply set product doc price equal to product doc price to string, what we already did earlier, just to make sure that this is handled correctly. After this little addition, we can restart the backend server once again. And now if we reload that front page, we see the product data on the detail page. So now fetching all products is working, fetching a single product is working. Now, of course, adding products is working. Now I want to make sure that editing and deleting works too. So that is what I'll work on next. Let's make sure we can also edit products. Now, as always, I'll copy my code to get access to the products collection. And for editing, I have actually two steps which I need to execute. First of all, I need to get the product. That should already work because I reuse the logic I use for getting it for the detail page. And hence, indeed, the form here is pre-populated with the product data. Now, when we click that button, a request will be sent to this patch route here. And there I still need to add some code in this place to store the updated product in the database. So I still get access to the products collection here, but then I can call update one here to update one product because I know I will only need to update one. And I'll identify that product by the ID, which again is encoded in the request URL. So again, I'll create a new object ID object and I pass my request params ID here, just as before. So now this finds me the product I want to update. Now you learned how you can update it. And I will simply use $set here as a key name to define the logic I want to apply to update the product. And I will update it by basically setting updated product, because here I describe all the changes that should be required. And we can confirm this by going into the shell where I am connected to my database. Here, this is how the product is stored. We have a name, description, price, and image. And that is exactly what I set here. Name, description, price, and image. So I set new values, which are parsed from the incoming request for all these fields inside of the document I passed to set. Now, one thing I need to change, however, is here. The product price should again be handled with decimal 128 from string. And for that, I first of all need to convert the price to a string like this. So now I have all the logic I need to update a product. Update one then also returns a promise. So we can reuse that well-known error handling code, which I have here. So let's copy that over into our catch function down there. And in the then block, I get a result, which I could output, but I know at this point that we were successful. So here I'll just return product updated. And the ID, well, that is something I can get from my request params because I already used that ID for finding the product. With that out of the way, we can restart our backend server. And now let's try changing the product. Let's add a couple of exclamation marks and let's change the price. If I click update product now, here we don't see that. On the backend, I didn't get an error though. Now let's look into our database through the shell. And indeed, here we see something strange. A nested updated product was added with the updated data. Now what's happening here? Well, the way I wrote my update code here, this is basically translated to this by JavaScript. So I'm passing an object to set where I instruct it to basically add a new field called updated product with all that data. So what I indeed want to do is I want to set equal to updated product, because updated product already is an object describing the entire change. So this is what I want to do. Now to fix this manually, I'll quickly go into the shell, take the object ID of the product where I messed this up, and then use update one here. We're calling update one like this, finding the product for this ID. And then I can use $unset, as you learned, to pass the key name, which is updated product, and set this to an empty string. And now, if I find all products again, this was cleaned up. And now with the code also fixed here, I just need to restart my server. And now if we edit this again, add a couple of exclamation marks and change the price, and I click update product, now this looks much better. And now if we also inspect this in our shell connected to our database, here of course we see there is no redundant data now. This was updated correctly. So this is how we can update the data and how we should make sure that we will update it correctly, I guess. Now, one thing is missing, and that is how we can delete a product. Now, I'll do this in this same lecture because it's really simple. And of course, feel free to pause and do this on your own. It's a great practice. We do it, of course, in this delete router method. And we do it by, first of all, getting access to the products collection again. Like that. Then we can call delete one here. And again, we will identify the product by creating a new object ID object to which I pass request params ID, because we do extract the ID here too. It will be part of the URL. And then we have the then and the catch block. For errors, we can use our well-known error handler. And for the success block here, that we were successful, I'll move this response in there. And that should be all. That should be all the code we need to delete a product from our products collection. So as before, let's switch to our terminal where the backend server runs, quit it, and restart it due to our change. And let's then simply hit delete. Now, was that successful? Let's reload the page. Looks like it was. So the fact that it didn't update is just a little error in the React code. You can fix it by going to that products.js file in the product folder, in the pages folder, in the source folder. And there, grab all the code you find in component.mount, copy it, then add a new function between render and product delete handler, which you can call fetch data, created like this, with this syntax, paste the code you copied in there, and then inside component.mount, you can call this fetch data like that, and then you copy that call and also execute it here in the then block once something was deleted. And with this tiny change made, if you reload the React app, you delete the earrings, now this page is updated. So now we can add products, fetch them, fetch a single product, and also delete products. And indeed, if we go to the Mongo shell and we look into the database, nothing is in there because we deleted it all. Now let me show you how you could add pagination before we also add user authentication to our application so that I can explain what's important there. Let's work on pagination, so on being able to flip through multiple pages of products. That is something you require in quite a bit of applications. And for it to work, we of course need some product data. So what I'll do is I'll again go to my products.js file in the routes folder, in the backend folder. And there I'll grab some of that dummy data I prepared, like the stylish backpack with the price of $79.99 maybe. Let's grab that image URL, which uses our local image. And here I can also copy the description. Click create product, and here it is. Now let's add another product, maybe the working MacBook, which is not the case for all modern MacBooks. Let's say for this price, let's grab that image. And let's grab that description here. And now we got that here too. So now I got 2 products. Now let's say for some reason I only want to display 1 per page. And I'd like to control this with so-called query parameters. So here I could have page equal 1 to indicate that I'm on page 1 and I only want to have 1 item per page maybe. And now I would be on page 2 and I only want to show that 1 item that belongs on page 2. So in my case here, the MacBook would be on page 2, stylish backpack would be on page 1. Right now, adding this query parameter does not do anything. But we can handle it. We can handle it here when we get all products. I had some dummy pagination in place before. Comment out the first 2 lines. This fetches the information which page you want to view, and it assigns a default page size, which I'll now change to 1. So 1 item per page, and this is the page I want to view as a user. Now, how can we implement pagination? Do you know that? Well, on our cursor, there are 2 methods that help us with that, or 3 methods. First of all, we can sort. We can sort our results, and we can sort them, let's say, either by ID, to keep that order we see here, or maybe we want to sort them by price. We could do that too. Let's mix it up. So let's sort them by price. Price descending. If I now save this, and I go back to my backend terminal, and I restart that server, if I now reload the starting page, they are still on 1 page, but they're now reordered. So that is already nice. But of course, now I can also use skip and limit. And I want to skip the amount of pages I'm into times the items per page. So here, let's say I'm viewing page 2. Then I want to skip query page -1 because I want to skip all previous pages. And that should go into parentheses, times how much is on a page size. So if I'm on page 2, I will skip the first 1, 2 minus 1, so 1 times page size. So 1, I'll skip the first 1 product, or products if it's more than that. And then, of course, I also want to use limit to not view all other products, but also only, well, as many as page size says. So if I want to view 1 item per product, I'll limit my result to that. Now with that added here, I need to switch to my React code real quick and make sure that I forward the query parameter there. And to keep this really simple, I'll remove it from that URL and not parse it manually from there. You could do that, but here I simply want to show the MongoDB functionality. So here in fetch data, you can simply add the query parameter here because this is the URL which reaches your node backend. It's not the URL you enter into the browser. This is it. And if you enter 1 here, you can reload the page and you should see the MacBook. And if I now enter 2 here, so to switch to page 2, and you reload the page, well, it does it for us even, you see a stylish backpack. Now in reality, you would of course probably implement some buttons that do that for you, that allow you to switch that in the React app, but since this is not a React course, I'll not focus so much on the React side. I'll simply not use pagination here, but I wanted to show you how you could implement pagination with sort, skip, and limit, which I'll comment out here if you wanted to. So let me quickly restart the backend. And now I got all the data on the page again because I commented this out, but this would be how you can sort and how you can implement pagination. Now, one quick note about sorting in the last lecture. I sorted on the price. And if you do that often, it is of course a good idea to create an index on the price in your products collection. Now, as I mentioned at the beginning of this module, creating such an index is not something you would do from inside your node code, because you won't do that upon an incoming request or anything like that. This code is really for your application logic, not for managing your database. So if you want to do something like create that index, you should do it from inside the shell. There, you can, of course, say db products, create index, and then simply create an index on the price in ascending or descending order. Doesn't matter what you use in your Node app because the index can be traversed in both directions by the Mongo client. So if I do that, now you see the index was added. We get a bit of more detailed output there than we did before because we're using a slightly different setup here. But in the end, we now added an index, and now we don't need to change anything here in our node code. We also don't need to restart our node server. We now just have an index added in case we did want to sort. And we can, of course, comment that back in even if we're not using pagination. So that's just a side note. If you do change some configuration or add an index, you would do that outside of this application. So we worked a lot on the products, and I hope it's now clear how you can do these basic CRUD operations from within a driver with your connected Mongo database. Now let me also talk a bit about authentication and users, because you might note that there's a logout button, and actually if we click it, well, then we can sign up or log in. Now, important, this authentication here is totally related to my app. I want users to be able to sign into my store. This is not related to the Mongo database at all. This is really important to understand. People will not log into my database here. They can't enter the credentials we set up on the cluster. So what we configured here for the users, we're not talking about these users at all. Our app will not create users here or use these users for signing in. These are the users, the clients, connecting to our database. And in our case, our client that connects is our Node backend, not the React frontend, and certainly not the users of our app. I just want some users in my app, and therefore I will store the user data in my database, but they will not be able to access the database. That is really important to understand. Now, with that, I can go to the auth.js file in the routes, and there I already have some code in place for signing users up and for logging users in. Now, for signing users up, which is a sensible thing to start with, I of course also want to connect to my Mongo database, then use a different collection, maybe named users, and there the user data should be stored, the email and the password. Now, the password will also be hashed first. I already have some logic in place which takes the password and hashes it. This is the encryption at rest, or a part of it, the part where we do encrypt some data on our own, so that even if our database gets compromised, the passwords are not stored as plain text there. So inside of here, I now have my hashed password here, and I can store it to MongoDB along with the email. And that is exactly what we will do now. And of course, as always, feel free to pause the video and try writing this code on your own, because in the end, you'll just insert a document here, nothing more. Now let's do it together. First of all, I'll import my DB helper by requiring it from the db.js file, the same I did in products.js. And then here, where I have my hashed password, I will call getDB, then call DB, so get access to the database itself, and call collection to get access to a collection. And I will get access to the users collection, which will be created dynamically if it doesn't exist yet. Now there, I simply want to insert one new element, and that one new element here will simply be my user data. So there, I will store my email, so I'll name that key email. You could name it however you want, and I'll take the email value, which I extract up there. And then I will also add password, where I take the hashed PW value. So the hashed PW value is something I get here from that hashing package, which does the hashing for me. So I'll store that too. So this will insert a document, and I will then add a then block to do something once this insertion completed. Now in the error case, I'll copy the code from this catch block, which is related to catching errors during the password hashing process. Now this catch block here is related to catching errors related to inserting the document into the database. Or here, I succeed. So here, I should successfully add my user to the database. So let's maybe console log the result here. And then here, I will use a token-based authentication approach, which means I'll create a token which I return to my client-side app, to the React app, which then could theoretically handle that token to authenticate itself to my backend for future requests. And this is a bit beyond the scope of this course. If you want to learn more about this, check out my upcoming or already released Node.js course, where I will cover this, and also a free series on my YouTube channel or on my website, academind.com. We built a Node RESTful API there, and there I also have this authentication process in there. You'll find a link to that in the last lecture of this module. So here in the result, in the then block basically, I know that we inserted our document, our user. So in that case, I will send this success response and I will create that token. So let's copy that here. Now create token, as a side note, is this function which just creates a so-called JSON web token. And again, this is the part you can learn more about in my Node course or in the free series. So I just return that token here then. And I can also return the email of which this was created on the user object. So now we have all the code in place we need to create a new user entry in the database, hopefully. So let's give this a try. Let's save that file and restart our backend server. And then here on the front end, I switch to sign up and I'll enter some dummy email address and some password. And actually, I can tell you that I will enter tester here as a password and then click sign up. Now this seems to work. And on the back end here, I see a log with some data about the operation. One document was inserted. This is the ID. And this is the document which was inserted. And we can also confirm this in the shell by accessing users and finding all users. And there you also see that encrypted password. That is not the password I inserted, but the encrypted form. So that is that encryption in place. And that is our own encryption in place here, I should say. So this insertion works. Now we do have an issue if I do enter that same data again. The same password is okay, but the same user is not that great. Because now if I check my users collection, you actually see the same email in there twice. And that is not something you want typically. So in the next lecture, let me show you how we can fix this and how we can ensure that email is unique. Maybe you also already know the solution. So how can we ensure that email is unique? So first of all, I'll delete that redundant entry here. So in my users collection, I'll delete one entry and I'll identify that entry by ID by using that object ID here. And now we can add a unique index. So on users, we can create that index on the email field. We pass some configuration here where we set unique to true. And now we'll get an error if we try to insert something which exists already. So now I inserted that index. And now let's try inserting that same email one more time. Now you see I get an error here. And indeed, I print the error here on the backend server, duplicate key error collection. So now I get this error, and of course you can handle it in a different way if you want, but now we make sure that no duplicate data for the email can end up. So that is another useful thing which we simply added by adding an index. In the last lecture, we added user sign up. Now I want to add user sign in. Now for user sign in, a request will reach this route here in the Node app. And there I also get the email and password with which the user tries to sign in. And now we need to write some logic to check whether that is some valid data. And for that, I first of all need to try to retrieve a user by that email from inside my database. So to do that, I get access to my database, call DB here, and then collection and get access to the user's collection. And then there, I want to find a user. Now for that, I want to find one element because, well, there should be only one user for that email anyways, if at all. And I'll search for the email, so a good thing that we created the index, and pass my email, which I extract here, as a value. So I'll search for a user with that email. And then I either get an error or I get, well, a user. In the case of an error, I will return this error here, a 401 error. In the case of a success, I'll get my user document here. But now we're not done. I still need to verify whether the password is correct. And for this, I'll use the bcrypt package, which I also used for hashing. And there is a compare method. And compare simply takes a string as an input and compares whether this can be the valid password, basically. So I pass in the password which I extracted from the incoming request, and I pass in the hashed password which is stored in a database. And then this package compares whether the hashed password could be based on that password the user passed in. So here I'll pass in the user doc password field. So basically that will be this hashed value here. So this is what I pass in, and I will actually return this because bcrypt compare also returns a promise. And if I return a promise in a then block, then I can simply chain another then block. And I could have done that down here too, by the way, because collection insert one returns a promise. So I could have returned this entire block and then simply added this then block after this first then block. You can do that if you want. Here I will do it. I return the compare function, then I add another then block, and in here I know that we found a user with that email and that the password is valid. So in here, I don't really care about the result, but I know that it should be correct. So let's grab that response and let's send a success response here with a message of authentication succeeded. And now here I'll also create a token. So I'll take that token constant, create that before I send the response, and then include that token in the response. And now let's see if that works or if there is some gotcha. So if I now restart my backend, let me switch to login, and let's try logging in with a wrong email. And I get an error. Now let's try logging in with the correct email, but a wrong password. And this succeeds. And the reason for that is that compare doesn't throw an error if it fails. Instead, it yields a result here. And I can console log that result to see what's inside there. So the result in the then block after comparing. If I now restart my backend server, and I log out again, and go to login mode, enter the correct email but the wrong password. You see I get false as a result here. I don't get an error, I just get false as a result. So it basically tells me this did not succeed, but it throws no error. So I should simply check if result or if not result, so if this is false, and then I can simply throw an error here. And this will then not execute this code, but go into the catch block. So with that check added in the then block here, now if I restart my server and I go back to that login page one more time with the correct password but wrong, with the correct email but wrong password, I fail. Now let's try this with the correct password but wrong email. I fail. And now correct email and correct password. And I'm forwarded. And now we got this in place too. So that's a bunch of JavaScript logic, but also some logic where I fetch data from MongoDB. And this is basically it. Let me now conclude this in the next lecture. So that's it for this module. I hope this showed you how you can add MongoDB to a basic application, in this case with the MongoDB node driver. Can you improve that application? For sure, but it's not so much about the app, but about how you connect to MongoDB, how you manage that connection efficiently, and most importantly, how you perform your CRUD operations and which kind of operation you would not perform here. For example, creating indexes. You also saw that it's perfectly fine and what you should do to dive into the official driver docs and find out how to use that driver, how to create a decimal 128-bit object, how to create an integer 32. Definitely use the docs, use the knowledge you gained in that course, because as you saw, for inserting, finding, and so on, all these operators, all the logic is the same. That is exactly what you learned in this course. So with the knowledge taught in this course, the official driver docs, and this module here, you hopefully now have all building blocks you need to build amazing MongoDB-based applications. In the previous module, I showed you how you can build a real application using a MongoDB driver and therefore interacting with your MongoDB database. In this module, I'll show you a totally new set of features the MongoDB company also provides. These features are loosely also related to their database solution, so to MongoDB, but they basically enter a new realm. So these features are not directly connected to the database, at least. These are brand new features, as you will learn. And therefore, everything you learned thus far about the database is not really touched by this, but the things you'll learn in this module can help you with building modern web or mobile applications in general. So what's inside this module? I will explain what Stitch is. MongoDB Stitch is the name of that service offering, and I will explain what's behind that, which services can be found in the Stitch environment, and what these services do for you. And after understanding what Stitch is, we will also use Stitch. So we'll basically take the application from the last module and we'll use Stitch to transform it a little bit. And as you will see, we'll be able to get rid of our own Node RESTful API, which is a big deal because it allows us to basically focus entirely on our user interface and our core business logic, and we don't have to write the boilerplate code of setting up a REST API, of doing authentication on our own, and so on. So that is pretty exciting. Let's dive in. So first of all, what is Stitch? What is MongoDB Stitch? It's a serverless platform for building applications, you could say. It's a collection of services offered by the MongoDB company that you can use when building an app. And with app, I mean basically a web app or a mobile app or also a desktop app, so that you can focus on your user interface and your core logic, even the logic which should run on a server, so on a backend, but you don't have to write the entire boilerplate for setting up the server, for managing the server, or for example, for creating a RESTful API on your own. That is all handled by Stitch. It all is kind of built around Atlas as a cloud database, or at least integration with that is particularly easy. And one core feature, for example, is authentication. Now here, I'm not talking about users for the MongoDB database as we managed it thus far. You remember in the last module, we created a couple of users that could interact with the database, and we used the user with the read-write access in our Node application, and we had to use it in the Node application so that the credentials don't get exposed in our user interface. Now, I'm not talking about this kind of database authentication. I'm talking about the authentication we have in our app to support users. Or even if we don't want users, even in such a case, there is a solution. Now, why is that important? Because Stitch gives us access to our MongoDB Atlas database. And this access will then be available from inside our client-side application, for example. So, for example, in our concrete case, it will be available in the React app. Now, in the last module, I mentioned that we shouldn't access the database from in there because we don't want to expose our database credentials. Now, the idea behind Stitch's solution here is that it doesn't expose our database credentials. Instead, our application users can sign up and log in through Stitch's service, and the user will get temporary credentials for fine-grained access to the database. And we can lock down what a single user can do. So we could say a user is allowed to insert documents into this collection, and there he may set that and that field. This field may not be changed by the user. We can lock that down, and I will show you how to set up such rules in this module. And therefore, we can pass the authentication or the rights to the users of our app because they don't have full access to the database, as they would have with our MongoDB credentials, which are not exposed. So Stitch manages this behind the scenes for us, that it takes our rules into account and makes sure that users do have access to the database, but only to exactly the things they have to do, like create new products, which they did in the last module too, but there we controlled access through Node. Now Stitch does this. So this is one important piece. We can also react to events in Stitch. So for example, if something gets inserted into a database or something gets updated, we can run some code that does something, sends an email or logs something into another collection or whatever we need to do. And that is the third building block. We can execute code or some kind of functionality in the cloud. So Stitch is not just a tool set which helps us build beautiful UIs or client-side code. We can still execute code in the cloud with so-called functions, so essentially just code snippets which we define, where we don't have to write the boilerplate of parsing incoming requests or exposing routes in a RESTful API, but where we just write the code we want to execute. And then we can either call that code directly from inside the client or from inside another function, or we set up a trigger with that middle position there, react to events. We set up a trigger to execute a certain code snippet when, for example, something gets inserted. So we're really flexible here. And if you worked with something like Firebase or AWS Lambda, well, then this function part on the right here would essentially be Lambda or Firebase Cloud Functions. And MongoDB Stitch as a whole is kind of MongoDB's answer to Firebase, you could say, if you know these tools. Now, in detail, for accessing the database, we got Stitch Query Anywhere, which is their solution to allow us to run queries based on the rules we set up for the users of our app directly to our database. There also is MongoDB Mobile, which I'll not touch on in this module. MongoDB Mobile is basically a local MongoDB database, you could say, which you can install on mobile devices so that you can store data and sync it to the cloud. Even when you're offline. So store the data when you're offline, sync it to the cloud when you're back online. That is a whole different topic and I'll not cover it here. React to events, that is Stitch triggers. That's simply the name of the service which allows us to configure triggers that will then call Stitch functions. And additionally, there's a feature called Stitch Services, which allows us to integrate Stitch with other services, like for example, AWS S3. That would be useful for uploading files because Stitch has no built-in file storage. So we got no solution for storing files. MongoDB itself is a bad solution. A database should not be used as a file storage. And there is no other service that would allow us to store files. And that could be solved by using Stitch Services, reach out to AWS S3, which is a file storage, and then communicate with that and store files. And you find plenty of examples for such use cases in the official Stitch documentation. So definitely dive into that if you're interested in more details. So this is the big picture. We got our cloud database, which we can work with Stitch Query Anywhere. We also got the events, where we can listen to authentication or database events. And then we can execute code in the cloud. And we can also execute that code not just upon events, but also call it manually. That is the idea here. And the idea is that we build our client-side application, and we also have some server-side logic still. We have some code that should run on the server. We also have our MongoDB database, or Atlas to be precise. And in the last module, we built our own backend, the Node REST API that talked to Atlas. Now this will be replaced with the Stitch service, you could say. So even though I called it serverless, there still are servers somewhere. But Stitch manages a lot of the boilerplate, a lot of the heavy lifting for us. And we just communicate to our services, to Atlas, to other services like database functions and so on. We do that with the help of the SDK, and now we can focus only on our user interface and our logic and not on all the boilerplate. Now let's dive into Stitch, and you do dive into it from inside your MongoDB Atlas console. There I got a running cluster, as you can tell, and now we can also add some Stitch apps by clicking on Stitch apps here on the left. Now there, simply click on Create New Application and give your application a name, like My Shop. The name is up to you. You can link it to a cluster, So here I'm using the only cluster I have, and click Create. Oops, that should be one word without white space. So now, as it says here, this will take 1 to 3 minutes to complete, so let's wait for this. And in the meantime, make sure you download the attached, slightly modified version of our application we built in the last module. Simply download it, then in the downloaded folder, extract it, move it somewhere where you want to store it, and then navigate into that folder in your terminal there. And then first of all, run npm install again to install all dependencies. This is required because the attached download does not include them to, well, basically make it smaller. So make sure you install all these dependencies, and thereafter rerun npm start. You don't need to run the npm run start server, which we used in the last module, because we'll not use our own server anymore. Oh, and this is already done. So here we are redirected. That's great. Now, before we dive into Stitch, let's finish the preparations for the project. And when that app loads, you should end up on the off screen. Because I changed one thing, we're not authenticated by default anymore. We had a dummy solution in place there anyways, but now I switched that. And I also added something else, which becomes important later. So this is the running application. With that, we're now prepared. So in the next lecture, let's dive into all of that and learn how we can work with Stitch and what we can see here. So this is the Stitch interface. You can always go back to the cluster screen by clicking on that back button here. And on this page, you can manage the different features Stitch offers. You have that Getting Started page, which actually allows you to move through a couple of steps to quickly get started. I'll not move through them right now, at least not through all of them. Let me instead explain what else we got here. Now, the Clients page here allows you to choose which kind of client you're using. Are you building a web app? Then you would choose JavaScript, and that is the case for us. We have a React app as a client, a single-page app. Or if you're building a native mobile app with Java or Swift, so Android or iOS, then you would choose these tabs to see how to install MongoDB Stitch, because you'll need a SDK installed locally to use the many Stitch features from inside your client. And all the steps are outlined here. We'll do this together in a second, no worries. Now, we can export our configuration if we want. I'll not do that right now. Under configuration for the Atlas cluster, this is something we can ignore here, would allow us to connect to our Stitch app differently, not something we'll do here. Rules will become important for accessing our data. That will become super important, actually. Triggers is what I mentioned on the slides, where you can set up some listeners to database or authentication events, and you can then execute functions. Services are these services where you could integrate AWS S3, for example, to suddenly add some functionality which Stitch has not built in, but Stitch gives you a bridge to other services. So also services of other companies. AWS is another company in the end. Users, here you can see users who signed up with your app, and that authentication, user management is all handled behind the scenes by Stitch. So you don't need to worry about saving the passwords in a secure way. You don't even store them in your MongoDB collection anymore. That will all be handled by Stitch, invisible to you, and this is pretty awesome because it allows us to focus on our core business logic. Values, these are some static values which you could enter, which you could then use in your, well, rules and functions, as it says here, by accessing this special placeholder. Functions is then the part where you can create a new function to, well, define some JavaScript code that executes on demand on the server side, as it says here. You can also view some logs for what happened in your Stitch app, and we'll see, you can see that later once we got something to happen. Push notifications is also something I'll not cover here, but you could add push notifications to mobile apps. So that is the rough overview. Now let's get started by installing the Stitch client. Therefore, on Clients, Browser, if you scroll down, we'll use this solution. So you can copy this command here. We'll use npm nodes package manager to install another dependency. And I will execute this here, or actually in that terminal where I ran npm start. You can ignore these warnings, by the way. And just paste in that command you just copied. And this will now install a new package, the JavaScript SDK for Stitch, which we need to interact with Stitch from inside our browser-side application. So this can take a few seconds until it's downloaded and installed, and I'll be back once it's done. So now it is done, and we can therefore restart npm start to bring up that React application again. And now the important thing is that from now on, we'll be able to work without our backend folder. So without our Node API here on the backend. And that is, of course, pretty awesome. Now, that also means that now we can simply delete that folder. So now we got no backend, and therefore our application will be broken now. Because, well, if we try to log in and so on, that would all not work because all the logic that is required for logging in is now not available anymore because I deleted the RESTful API which we used for that in the past. But that won't be a problem because we'll use Stitch now. And here you actually have a short snippet on how to use Stitch. Let's dive into using Stitch in the next module and let's learn how we can use it to, well, interact with our database and fetch data and so on. So let's start using Stitch. Here we actually have a pretty helpful snippet that shows us how we can use Stitch in our client-side code. But of course, we'll walk through that step by step together. Now to get started, let's dive into the source folder in our code and there in the app.js file. Make sure you set is_auth to true here so that we start in authenticated mode. We'll change this later. Now in authenticated mode, you'll see I'm on the products page, but of course we can't load products because I deleted my entire backend and hence we get an error. But we'll fix this. Now we know that there actually are products in our database because we created them in the last module. And even if you didn't, no worries, we'll also add the code to add new products in this module. So how can we now fetch products with the help of Stitch? Well, first of all, we need to import Stitch in the file where I want to use it. Now, where do I want to use Stitch? Well, for now, let's go to the products page here in the pages folder, products.js. That is where I have my fetch data method where I tried to fetch data from my own API in the last lecture. Now, this will now not work anymore. Now I want to use Stitch here. To use Stitch, I'll go all the way to the top because first of all, I need to import some things. So I'll import some things from the MongoDB Stitch browser SDK package. So this is the name of the package. And from there, I'll import Stitch itself. This is an object that allows us to basically initialize everything and then work with Stitch. And I will also need to do some other things. But these things, like for example authenticating, will not happen in here, but in the app.js file. In the app.js file, there I'll also import Stitch. By the way, you can remove the Axis import, we'll not use that anymore. You can import Stitch here. And the first thing I'll do with Stitch is actually in my app here, I'll add a constructor that is a default function that will be executed first by JavaScript. So this is not related to Stitch, this is pure JavaScript. And I will use Stitch here. And on Stitch, I can call initialize default app client. And now here I need to pass a client app ID. Now that client app ID is something I get from my Stitch page. And actually here, I already see exactly my ID. So we can use that ID here and copy it over and pass it as a string. This is the first thing you need to do in any application that uses Stitch. You need to initialize Stitch with this command. Now with Stitch initialized, you can now start using it. And we can start using it inside the products.js file, where I also import Stitch. For example, when we try to fetch data, which is actually the first thing we do when this component mounts, so when this component is loaded. So here, instead of using Axios, I can simply use Stitch and then get app client. We initialize it in app.js. Here we can get the initialized app client. And then you get a service client. Now, what is a service client? That would be something like AWS S3 if you now want to reach out to some functionalities exposed by that. But another service client is also MongoDB, so the database. And to use that service client, you need to import something else from the MongoDB Stitch browser SDK, and that is the remote Mongo client. So it's basically a Mongo client built for usage in the browser. with taking that different way of authentication and so on into account. You pass it here to get service client. You pass remote Mongo client.factory. That is essentially just a reference to a method that will be used internally by Stitch to initialize that Mongo client. Then you pass a second argument, and that is the service name. The service name here in our case is MongoDB-Atlas, and you must get that right. So this is not up to you, it has to be named like this, MongoDB-Atlas. This is something we can now use because this gives us access to MongoDB. So I'll store the result of this operation in a constant named MongoDB. And we can now use MongoDB, so this constant here, to work with our database. So here, I can now access a database. I can call a database function to which I pass the name of the database. And here, the name of my database will be shop. That is the database I created in the last course module. If it doesn't exist yet, it will be created on the fly. And then I access a collection in there, and that will be the products collection. And now you can call the normal CRUD methods you know. Find, insert one, update one, delete many, and so on. So here, I will now call find to find all products without arguments. And now we have a cursor again, but we get a bit of a simpler to use option here. And we can now simply use as array and let Stitch do the step-by-step fetching for us. If we needed more control, we could get access to the iterator, which basically allows us to write our own loop then. So here I'll use as array to get access to the results as an array. We execute that function and we get back a promise here. Hence, we again have then and catch here. So now in then, we should be getting our products, and in catch, we'll have an error. Now, if we have an error, well, then I'll just copy my error handling code from up here. This will essentially just throw an error message where I can say fetching the products failed. And we can also log the error so that we can see it, what exactly went wrong. And here, if I do have the products, well, then I, of course, want to set my products here equal to the products I fetched. So I can use this set state, and this is now React code, not Stitch code. And I can set products equal to the products I get here. So this is the products in my state. That's a React thing. That, the right side of the colon, that are the products I fetched. Okay, so this is the logic that allows me to fetch data. Now, I also need to go back to app.js real quick. I deleted the Axios import, and therefore all the places where I use Axios would now throw errors. So what I'll do for now is I will simply take that entire code here in the auth handler and comment it out, because it would lead to issues. If you now save everything, I get an error here that I must call super. If you do add a constructor, as I did here, you have to call super in there. So let's do that. Now I have another issue here, and that issue is that I failed to get my service client here. The issue is here in fetch data. Get app client is the issue here. I should access stitch.default app client. Sorry, this property. You should access this property, not get app client. Little mistake on my side. And now we get an error, but this error is expected. We must authenticate first. And that is related to what I explained on the slides. You have to have authenticated users in your application, because each user then receives a set of things this user may do, and then only that interaction may happen with your database. And this is then your way of protecting your database against unwanted access. Because you probably are fine with users creating products, that is what they would do through your app anyways, you just want to make sure they can't start deleting let's say your orders, and you can control that a logged in user may create products but not delete orders. So these are things you can all control. So now we need to authenticate. Let's do that in the next lecture. How do we authenticate in Stitch? Well, for authentication, we can dive into Stitch again, and then under users in the Stitch console, under providers, you see different ways of authenticating users. You can use third-party providers like Facebook or Google. You can manage your own emails and passwords, and you can even allow anonymous authentication. And that is what I will turn on now by simply switching that. So now if I save that, people can log in anonymously. And I will show you how that works, and we'll switch to real users later too. So I want to log in anonymously. How does that work? Well, for that, I'll go back to the app.js file. In there, where I initialize my app client, here I also can log in. For that, I'll simply store the client, which will be returned by the initialize default app client method. I'll store the client in a constant. And now, for anonymous authentication, I need to import anonymous credential. That is something I need to import here. Anonymous credential from the MongoDB Stitch browser SDK. With that imported here, we can call client.auth to access the auth features of the Stitch SDK. And then here, we can call login with credential. Now, to this credential, we can pass different credentials. And the credential then depends on the authentication methods you want to use and you unlocked in your console. So in my case, I only unlocked anonymous authentication for now. So here I will pass the new anonymous credential. And for anonymous credential, we don't need to pass anything else. We can just pass it like this. And this will log us in anonymously. If we now save that, we let our app reload. You see, we don't get this error anymore, but I still get another error. I get a Stitch request error saying me that unexpected token in JSON at something occurred while decoding a response from Stitch. Now this error is stemming from the product.js file, line 45. And if we have a look at that file, we can quickly see, well, it's coming from this console log. So we get an error when we try to fetch products. Now we are authenticated and still we get an error. And that is related to the rules we need to set up for accessing our database. Because as I mentioned, by default, nothing is accessible. Everything is locked down and you have to inform Stitch which user or which authenticated entity, because right now we have that anonymous authentication, but we still have an authenticated entity there, what kind of access is allowed there. So people are allowed to log in anonymously. So that means every visitor of our page is logged in. Obviously, we don't want to grant many rights to our users then. And in general, when we want to enable any data to be fetched, we need to dive into the rules here and set up the rules for our data. Now here you have to add a collection. And now this does not mean add it in the database, but add it in the rules here so that we can set rules for a collection. If nothing is added here, everything is locked down by default. And that is, of course, a great security setting. So here, first of all, the database is the shop database, and the collection for which I want to set up some rules is the products collection. Now, here you see you got a couple of templates. You can say users can read and write their own data. Users can only read all data, can read and write their own data. Now I will go with no template here, click add collection. And now you have this set up. Now for one, you could set up some validation here. You could set up schema validation here, and Stitch would automatically give you an error if you try to save something which does not suffice this criteria. You learned more about schema validation in an earlier module in this course. But I'm interested in the permissions. And here, you basically set, for example, default permissions, which apply to every authenticated entity, including our anonymously signed in users, so every visitor of our page. And right now, everything is locked down. Now we can enable read access here, and this will allow reading documents in this collection and reading all fields. You could even add a field here, and you could say, well, the title is not available for reading it, only the other fields are. So that is something you could do if you wanted to control that some field is not retrievable or not writable. So you got fine-grained control up to the field level. Now here, I'm fine with people fetching all documents, so now we can save that. And now with that, anonymous users should be able to read all the products in our shop database. So if I go back to my application and I reload here, I don't get this error anymore. I also don't see the products here, but that is simply related to the fact that I never changed the isLoading state here. So that's a pure React thing. So here when I set the state, I should also set isLoading to false because we are not loading anymore. And by the way, if I have an error, I should also set the state and set is loading to false, because even if we have an error, we're not loading anymore. Now with that change, if I saved it, now we get a different kind of error. Objects are not valid as React children. Now that simply is related to what we get back as products. So let's simply console log our products here to see which format Stitch gives us. So if I now reload, we get this output and we see we are fetching 2 products because I got 2 products in the database from last module. And here I got an array of product with price, name, image, and description and underscore ID, which is an object ID. Now, which problem do we have here? Well, the problem is previously in the last module, we parsed our MongoDB data on the server. For example, we converted this decimal 128 thing to a number or to a string we could work with. Now we're not doing this, and hence we're getting these native MongoDB types, and you can also see that here that we have these special types, object ID, decimal 128, with which we can't work. So we need to convert them here on the client now because we're doing the entire data fetching on the client. The solution is that we transform our products here on the client. So let's do this in the next lecture. So we need to transform our products here on the client to make sure that we parse the values like decimal 128 or object ID, which are not known by native JavaScript or by React, that we parse that into normal JavaScript primitive values. For that, I'll add a new constant here, transformed products, and I'll use a native JavaScript method, the map method, to take an array, products, and map every element in that array into a new element and return a new array of all these new elements and store it here. So map takes a function which will execute on every element in the array, and the input here will basically be a product. You can name this however you want, but we'll have a bunch of products in that array. And then I return my changed version of that product. So therefore here, I will simply change 2 things. I'll change underscore ID, and here I take the existing underscore ID and I call toString on it. The same is repeated for the price. I also call toString on that. Now if we save that, you see, if we reload, it is working, it is fetching the data. The images are not displayed because the images were hosted on my backend, which I deleted. Hence, the images are lost now. We would have to pick publicly available images now when creating new products. But this is working. So now we're retrieving the data and we're parsing the unknown types so that this works and so that we can get our data anonymously authenticated. Now let's try adding the other functionalities for adding, deleting, and editing products. So let's continue with deleting products maybe. For this, I got my product delete handler in here, and I'll later remove all that code down there. For now, what I'll do is I'll again get access to MongoDB with the same code I used in fetch data. And actually, I can also copy that code here where I reach out to the products collection, because that will be the same. And yes, you could outsource this into a separate function therefore. Here, I will then call delete one because I want to delete one product. And of course, I need to pass my filter just as you always did it, just as you learned in this course. So I want to delete one product which I identify by ID. So I will delete one product where the ID is equal to the product ID I get as an argument here. Now then I can chain then and catch. And I can basically copy the code I have down there. So I'll copy the function I had for catch and move that into my catch block up there. And well, basically I can also use the entire then block and reuse it up there. So with that, this should delete my items. I can now get rid of that old code where we used Axios and only have that new code where I use MongoDB Stitch. If we now save that, the page gets reloaded. And let's now try to delete the working MacBook. If I click on delete here, you see I get back a deleted count of 0. And do you have an idea of what's wrong here? Well, the problem is that I have an ID, which is a string, and I'm looking for an ID in my database where this equals the string I get here, but the ID in the database is an object ID. So we need to create an object ID. And we can do that in the browser with the help of a special package, which we can install with npm install --save, --save bson. This is a package that allows us to create bson types, so these special types MongoDB works with, in the browser. And we can create an object ID object in the browser, therefore. So with that installed, we can get rid of access for one. We can now import bson from that bson package here. We can use bson down there in our delete handler where I'm looking for the product ID. We can use bson dot and then simply object ID. And we have to instantiate this. Now with that, we're creating a new object ID here and we're passing our string there. Now if we save this, that won't suffice. We also need to restart React, the React server, because we installed a new package. So now, once this reloaded here, we can try deleting again. And now you see it deleted one product. So now this works thanks to us using bson. Okay, so in the last lecture, we also added deletion functionalities, and you learned that you have to convert your code or your items to these bson equivalents if you want to use them in a query or want to store them as such objects in MongoDB. Now what's missing? Well, we also want to be able to view the details page and to edit products, as well as add new products. So let's work on the details page. And definitely feel free to again pause the video at this point and go ahead on your own to try that out. Of course, we'll do it together after that short pause. So, were you successful? Let's now do that together. So I will go into my file that is responsible for viewing the details, which is the product.js file. Here, when this page gets loaded, essentially, I'm trying to fetch a product, and this old code won't work anymore. Instead, we again need to replicate this code here, where we use MongoDB, and of course that also means we'll have to add the imports to this file, so to the product.js file here. So we can go up to products.js, and here we can simply copy these two imports because we'll need all of that in the product.js file too. We can replace Axios with that because we'll not use Axios anymore. Now in component.mount, I'm reaching out to my products collection thus far, and there I of course want to find a product. So I'll use the find method to find a product where the ID of the product matches the ID I get here. So I'll look for equality of ID, and well, then we need to construct an object ID again with bson.objectID. And there I pass this props match params ID. So exactly what I used down there to get my ID of that product. And this should now give me all products with that ID, of which there, of course, should only be one. So thereafter, I can use then and catch. So that should still work. I can copy that. And I can get rid of my Axios code. So with all of that, if I save this, let's click details, and we get an error. Collection find is not a method. And yeah, it makes sense because what does find return? A cursor. We don't have find one. That was my mistake. We have find. So therefore, I have to call as array here, and then that gives me a promise. So now I get back my results as an array. That also means that I have an array here. So product response actually will not hold any data I can extract. Instead, this should be an array of products, and I simply need to access the first and, as we know, only object in there. So that's a slight adjustment that is required as array and then extracting the first element. And now if we reload that page here, we again, of course, get the issues regarding the bson types. And that can be solved in exactly the same way we did it before. Here, when we want to render a product, well, I'll just create a new product and then basically take my old product here. So that is what I start with, that I just store the first element in product response, which is the product we fetched in a new constant. And then on this constant, I can change my ID and set it equal to product.id to string. So I convert this to a string. And I can also grab my price and set this equal to product price to string. So just what I did in the other lecture. And then product is what I use down there. So now if we save this, page reloads, and now we see the backpack details without the image again, because we deleted that backend folder where the image was hosted, but the other part is working. So now let's add some functionality to add new products so that we finally can add products again where the images do work. So it's time to add the functionality to add a new product. And we do add this in edit product. There we have the code to, first of all, get an existing product or the details for an existing product. We'll care about this later. But we want to care about this case here, where we check where we're editing or adding, and then we execute different requests. Well, that is in the end where I want to pick up. And here, if we're not editing, so if I would create a new product, this is the part where I will now add my code. Again, I will simply import these two imports into edit product.js because we'll need them here. I'll leave access in there for now so that the code doesn't break immediately. And then here in else, of course, I will use that same code I used before where I get access to MongoDB to the products collection. So I'll copy that into here too. And then there, I want to insert one new element. And that one new element, of course, is my product data here. So I will pass product data into here. However, now I need to make sure that I do convert the types of product data. So the price, for example, should be a decimal, right? And here I can use bson.decimal 128, not with a new in front of it, just like this. And then there is a from string method. So I can pass a string in there. For this, I have to convert this to a string first though, or make sure this is a string. It should be by default, but to be really sure. And then simply create such a decimal 128 object based on that string. With that added, here I got the logic to insert one product. And now this, in the end, is my new request, or not const, just request. I'm initializing this variable up here. Here I'm assigning a value. Request will hold a promise because insert one returns a promise. And here I then just handle that promise. We can also output the result here to see what we get back. With that, if I now save that, this page should reload. And now let's add some content here. Let's also grab some image of your choice. So here I'll just paste in the URL of a burger, a tasty burger, and then click create product. And I actually get an error. Unexpected token at position something. Now, what could be the reason for this error? It has something to do with, well, something we covered earlier regarding to how we work with users and permissions. Well, we're simply not allowed to write data. That is why we have a 403 error there, which is the code for not authorized. We have to go into our Stitch rules again, and keep in mind, we're only able to read products, and that is that fine-grained control I meant. Now, we have to unlock writing too, so that we are able to save that. And with that changed, we can go back. You don't even need to reload the page, and you can just click create. And now it works. And now you see the burger here. So that shows you again this fine-grained permission setup that Stitch uses. So now that we can view all products, the details of a single product, and delete a product and add a product, of course we want to be able to edit a product too. This is again an awesome time for you to practice this, because we'll only use things we did thus far. After a short pause, which you can use to pause the video, we can of course continue together. So, were you successful? Let's do this together. Now for editing, we start on the edit product.js page or on that file. And first of all, we need to ensure that initially we load the detailed data for the product that should be edited correctly. Now we got that code to load such data in the product.js file, where we already load some product detail data. So we can just copy that entire code here essentially. And yes, you could of course refactor this to outsource it into one file. I'll go with the more verbose approach here to make this really clear where I'm using what. And now I'm getting access to the collection. I'm finding the right product here, convert it to an array because I have a cursor here, get my product, convert the native types, and then I just need to make sure I set my state correctly. So the error handler is all right. We can leave it as it is, but here I want to ensure that I set my state like this. I set is loading to false, and then I retrieve my product data. That to string conversion here is not required anymore, but the rest should be fine. Now we can get rid of that Axios code down there, and we can save this file. Now if I click on edit, yes, this works. It fills out the blanks for us. So now we are loading the data. Now we just have to make sure that the update product button works. And for that, we of course need to work on this place where we send a patch request with Axios. This is not what we'll do anymore. And hence we can now also remove the Axios import finally. Instead, we'll do almost the same we did when we insert a product. So we can copy that code, or to be precise, since we reuse that part, we can also just move it out of there. But then we can copy this code, move it into the edit case here. But there, of course, I won't insert one product, but I'll update one. The first argument, therefore, is the selector, which product to update. And here, I want to update the product with the right ID, obviously. So I'll select the product where the ID is correct. Where the ID, and now I need my BSON type. So where I have BSON object ID, where the ID matches my object ID here. Now, what is my ID? Well, I can get this from the props match params ID. And that is how I extract my ID in component did mount to, right? This is how I get the ID there. And this is how I can get the ID down there. This gets stored in the request, and it should, so that I can handle it in the same way I handle the insertion of a product. And now the page reloads. And if we now change the price, for example, and I click update product, it changed here too. So now we got all the CRUD functionality added, and we're now handling it fully with MongoDB Stitch, and still in a super secure way. But of course, the next step is that we now add users, and not this anonymous access which allows every visitor of our page to do everything. That might be what we want for some parts of the page, but let's say for some parts, or in our example for everything, we actually want to lock it down to real users. And this is something we'll work on now. So time to work on authentication. And for this, first of all, we can go to the app.js file and set the default off mode to false. Now if everything reloads, we start on the login page. And I want to start there so that we can switch to sign up and create users and then log in with these users. Now Stitch offers us a simple way of adding real user authentication. And for that, we just have to go back to users, and under providers, we can now disable anonymous login and save that, and instead turn on email password login. So we enable this. Now, email password login ships with confirmation and password resetting built in. Now, I'll not show the password reset part. You can learn all about that in the official docs. It's really easy. But we need to enable email confirmation so that anything works. So for this, users should receive an email where they are forwarded to localhost 3000 confirm account. And you need to get that right. Your React app will run on this host. If you deploy it onto a real server, you should of course update this. And this is a page which I prepared, a route which I prepared, which we then can work on to confirm the account with Stitch. Now, this last field here is optional. You could enter the subject for the confirmation email, as is this field. This field is required, and it will enter something there, but this will not work. Right? So this is not a route I added. You could, as a challenge, do this on your own. I don't need resetting in my app. I want to have, or I need to have confirmation though. So now let's save this. And now we enabled this user email authentication. How do we now use that in our app? Now let's add our user authentication logic. And that means we want to add functionality to sign users up and to then also log them in. Now for that, I'll go to my app.js file, because that is where I have the code to, well, do both, sign up and log in. And here I need to import other things from my browser SDK. I don't need the anonymous credentials. Instead, now I need to import the user password of provider client for now, for registering users. That allows me to go down to my auth handler, where I first of all check the validity of the input. And then here, we will use the stitch client. Now, I do actually initialize the client here. So what I can do is, I can also, instead of storing it in a constant, store it in a property of this class. So this client simply turns this into a property. I have to use this client here too now. And this allows me to use it in other functions than the constructor too in that same class. So here I can then say this client auth. And then here I'll get my provider client. And that provider client, or what I pass here, is the user password of provider client, and they're the factory. So this basically initializes my user password of provider functionality, you could say. I'll store this in a constant, which I name email pass client, but the name is totally up to you. And then we can use that email pass client, which simply stores the result of this initialization here, to then call register with email. And here I need to pass in the email and the password the user gave me. And that is, of course, data I can extract from my auth data. So here I pass auth data email and auth data password. This will now sign the users up with Stitch. And again, they are stored by Stitch, not in one of my collections. They are stored by Stitch. And we then have a promise here with then and catch, where we basically find out if it was successful or not. Now, in then, let's see if we get any result. We can console log here. And in catch, we might get errors, of course. Now, I have a catch block down there, and I will actually copy the code I have down there and use it in here. Just comment this in again. And with that, I should be fine. So let's now see if this works, if we can get some result with that code. And I, of course, need to change one thing for this to work. The part where I use my anonymous credential, this one here, well, this has to be removed, right? Because I don't sign in anonymously anymore. So now let's switch to sign up. That's important. And now you need to enter a real email so that the email reaches you. Now, once you click sign up, we see undefined here. So we don't actually get back a result. So this result here, we don't actually get any data. So there's nothing we can log. But we should receive an email now. Now, in that email, you should have a link, which you can click. Now, if you click that link, it looks like you're back on this page, but in the developer tools, you should actually see this account confirmed output from the confirm account JavaScript file. If we dive into that confirm account file, this line is responsible for that output. And there indeed, I already do parse some data, which we'll find in the URL of that confirm account page. And you can see that data in the link you clicked in the email. And we now need to use Stitch to send that data to the backend of Stitch to confirm our password. We do that by also importing Stitch in here, so from the MongoDB Stitch browser SDK. And now we just need to call some method there to work with Stitch. We also need the user password of provider client in that file, so in the confirm account file. And then we can use Stitch, get the default app client with this property, and call auth there. And then on auth, you call get provider client and pass your user password of provider client, the factory, just what you did before. So you simply replicate the code you had in the app.js file. So that is our email pass client. You can name this constant whatever you want though. But now we can use that email pass client here to then call confirm user. And to confirm user, we need to pass that token and token ID, which I already parse from the URL here. And then Stitch behind the scenes will validate if that is the token and token ID that was mentioned in the email. And therefore, if that all matches, it will confirm the user. Now, this will give us a promise, which either succeeds or, well, fails. If it fails, I'll, for now, just log the error. If it succeeds, well, then I want to redirect the user to the starting page. And with that, let's save all of that. And with that being saved, click on that email link again. You should have now seen confirm account for the fraction of a second. For me, unfortunately, this always gets open on the second screen. But if we now go back and we sign up again with a real email, that's important, then I get an error that is stemming from the app.js file here when I try to extract something which was required when I used Axios. So let me simply replace this with an error occurred here. And then let's try this again with a real email address, as I mentioned. I get this error now. And here, in the error I get back, we actually see that the name is already in use. So now let's try adding the login in the next lecture so that we can use that confirmed user to log in. So now that we added sign up, let's also add login. For this, in the auth handler, in the app.js file, we need to find an alternative to signing a user up as we're currently doing it. And previously I had a if check here. So let me reintroduce that if check here. And I'll again work with that request variable, which I'll also re-add here. And now request either holds my email pass client register with email logic. That happens here when I want to sign up. So then request is equal to the result of that. And I can then use request down there. Or I do log in. And now how do I log in with Stitch? For that, I need to add an import first of all. I need to import the user password credential. You remember, previously we used the anonymous credential. Now we simply use the user password credential. So I'm importing that. And I'll now create a new credential here. Credential. A new user password credential with the two pieces of information I have. So with the email and the password. So I'll again pass auth data email here and auth data password as a second argument. So now with the credential, we can log in just as we did it before with the anonymous credential. So here, to log in, I'll actually use my general Stitch client with this client, then auth, and there I can call login with credential and pass my credential, which I created here, as an argument. Now this will give me a promise, and hence I can safely store this in request. And then here, let's see what we have as a result now. So in here, let me console log result. So now we should have a login flow too. So let's go back to our application, make sure you're in login mode, and then try the credentials you used for signing up with your email and, of course, the correct password. Now, I get a reply here, and that reply looks positive. It's not an error. And this simply confirms to me that I am logged in. And the whole session of the user, to the tokens to be precise, are managed by Stitch behind the scenes. You can, by the way, see them if you go to the application tab in your Chrome browser DevTools, and you then check out your local storage. You should see that Stitch client thing here, which in the end stores information about your user, where you see, for example, the token that is managed for you. So that is what Stitch does for you. You don't need to worry about that. You now have a way of logging in. So what you know here by this point is that if result is set, because it was undefined for signing up, if you remember. So if we have a value for result, then we are logged in. And in this case, I want to also change my authentication status. So then I want to call this set state is of true, so that I also reflect this in my user interface. So now, again, if I do enter my valid credentials here, I am logged in, and now I load my products. Now let's also adjust our rules such that only logged in users can interact with the products. So I added authentication. Now if I go back to my Stitch rules here, I have these rules for my products, right? And right now I got these default rules where everyone is able to read and write. Everyone still only means logged in users. And since I disabled anonymous authentication, this can only be email and password users. So even though it says default, it's not that every visitor can read and write everything. You have to be logged in. To prove this to you, let me go back to app.js and temporarily set isOff to true so that we start in authenticated mode. And this will reload and it will load the products, but it only does so because Stitch behind the scenes did log us in automatically because it stored our status in local storage. So let's go to application local storage and actually clear local storage by right-clicking on that and clearing. And now if you reload that page, you get an error, must authenticate before. Now, of course, you could handle this in a more graceful way, but this proves to you that only authenticated users are granted access. So now I set isOff to false by default again. And if I now log in with my valid credentials again here, whoops, I mistyped, but that's good to see too. But now I entered the valid credentials and now that is all loaded. And that error you see here only stems from the missing image. So now this is all working, as you can tell, and now we are using MongoDB Stitch, and we don't need to write our own backend, which of course can save us a lot of work and time, and still we have a secure solution. Now we talked a lot about how we can use Stitch to query data and how we can authenticate users. Dive into the official docs if you want to learn more about that and how you can lock down access even more and how you have fine-grained control. Now I want to talk about some other Stitch features, briefly at least. To be precise, I want to talk about functions and triggers, because these are also two other major features. Now, functions. This allows you to write some code that you can execute. Let's click on Create New Function, and let's name it Greet. It'll not do that much useful stuff, but it'll simply greet users. With that, default settings are okay. You can click Save, and now you can write your function code. Now you write JavaScript code, and for all the features, again, the official docs are the right place to go. In the end, what you can do here is you can execute any JavaScript code, you can access other services, you can access your database. Here's a snippet that shows you how that would work. And you can also simply log something so that I can show you that this works. Not a super useful function, but at least I can show you how we can call this. So I'll save my function code here, and now I want to call this function. And we can call it from inside our frontend, from our client application, through that Stitch SDK. Now let's say I want to call that function whenever my app loads. So essentially, I can do this in the app.js file in the constructor after I initialized my client. Here I can use this client and then execute call function. And here I simply pass a name to that function, or the name of that function. And that is, of course, greet. And it will only look into my Stitch app, which I initialize here, and then find that function. You can also pass some arguments as a second parameter. So this would be an array of data you pass into the function. You can also have a look at this. Can pass max in there. And now, if I go back and edit my function slightly, I can also output arg here and see what I get there. So now let me save that. And let me now reload my app. And this should execute the function. I don't see anything here, but on the back end, let's go to logs. And there we see a bunch of logs, but we also see two function calls because the app was loaded twice, because I saved it before already. And there indeed you see greet max as the output. So you see max was an argument that was passed to the function, and hence I could also use it here. So it's as simple as that. That is already how I can call a function from inside my code. Important is that this function runs totally on a server. Users cannot see your code in there. So if you got any code you want to execute that users should not be able to see, you can put it into a function and call that function from your front end, and then this code is invisible to your users. And you can also put longer taking tasks in here, for example, that you don't want to execute in the browser. Stuff like that. Now you can also execute a function from inside or upon a trigger, I should say. So we can go to triggers, and we could add an authentication trigger to basically say, okay, when a user was created or logs in or is deleted, then I want to execute something, some function, or a database trigger. Now let's go with a database trigger here. You can give it any name you want. I'll name it product insert. Should be enabled. And I'll listen to an event in the shop database and there in the products collection, and I'll listen to an insert. Whenever something is inserted into this collection in this database, then I want to execute a function. To that function, I'll pass the full document which was inserted as an argument, and then I'll execute my greet function, let's say. You can now click save, and that is already it. What you can now do is you can go back to your app and log in real quick. And if I now add a product, and I'll really just type in some dummy data here so that we can quickly create it. Now that I created it, if we go back to the logs here in our Stitch console, you see product insert, that trigger was executed, and you see the output of the result is greet, and then a more complex object in the end, because that function receives the full document and some other metadata, and therefore well, this is not output here, essentially. If you want to see what's being passed in detail, you can, of course, dive into the official docs, or maybe write this object into some dummy collection. You can insert that object into a dummy collection to then also see what's in there. And these are functions and triggers. Very useful features that allow you to write code that runs on the server, and even control that this code should always run when something happens to one of your collections. You could create an entire course just on Stitch, because it really is a complete different offering in addition to the MongoDB database world. This course, of course, is about the database, which is why I only wanted to give a brief introduction to Stitch. Stitch really helps you build complete applications with everything you need: authentication, server-side logic, even file storage, if you use a service like S3 then. And of course, you have the entire Mongo database, the entire database world, which you learned about in this course, at your disposal too. So if you're building modern applications and you want to focus on your code, on your logic, then using a solution like Stitch, together with all the power and the cool features MongoDB, the database, gives you, is really a great approach that allows you to build amazing applications quickly. Now, that's it for this course. I hope you enjoyed it. I hope you got a lot out of this course, and I can only encourage you to keep on learning. Don't stop here, because taking a course is great. And I got more courses if you want to dive deeper. But if you want to master something, if you want to get really good at something, you have to apply what you learned. You have to use it. Use it in your day-to-day projects. Build demo projects where you apply what you learned. Make sure that you don't lose that knowledge, because taking a course gives you that solid foundation, but you only become good at something if you then use that foundation to use it in your day-to-day work, in your everyday work, in your projects. And therefore, I would of course love to see you in other courses, but either way, I wish you all the best for your future.